Morning, sir. Good morning.
Very good morning to you. Can you hear me?
Yes, sir. Yes, sir. Yes, sir.
बोलो ग्रुप में डालो सब लोग ज्वाइन करें sir, good morning.
Very good morning.
Kushal sir, good morning.
Yeah.
Good morning, organizing committee members, all of you. Good morning. Very good morning to all. Wish you a very happy and excellent day.
So for the plenary lecture, I think the keynote lecture third, the speaker has already joined, and we will introduce them and we'll start our session on the time.
But who is the chairperson of the session?
Chairperson Dr. W. Rajendra and me will be chairing the session.
Fine, thank you very much. Because Professor Mangala Gunteleke is the Secretary General of the SAP, South Asian Association of Physiologists, of which I am the president. So I am just want to listen her. She's an excellent speaker.
Sir, I would request, because what happened, another chairperson, Dr. Bindu Kuti, some or other how may not be able to join because of some urgent work. So I would request you to kindly chair the session.
No problem. She is like my younger sister.
Sir, that would be,
yes, no problem.
So you
Yes,
please
yes.
chair the session with Dr. W. Rajendra. Thank you.
Right, right. No problem. You
Thank you.
just ask Dr. Rajendran to take care of the her biodata and all to read
Yes.
and introduce, and I will interact with her at the
No
end.
problem, sir.
Right.
Okay, sir.
Can we start now?
Yes, sir.
Okay.
I
Very
think you
good
can
morning.
start now. We should not be
Yeah.
delayed.
Yeah. Very good morning to all of you. So it is my privilege to introduce Professor Mangala Gunathalake.
Rajendra, sir.
Very good morning, madam. Hello.
Sir, shall I officially start, like,
Sure,
formally start the session?
please, yeah.
Okay. Thank you, sir. Thank you for the permission.
Okay.
Good morning to all the participants and the eminent scientists present with us today. We heartily welcome you all back to the Day 2 program of the 9th International Conference of Federation of Indian Physiological Society 2022, organized by National Institute of Pharmaceutical Education and Research, NIPER, Hyderabad. We shall begin with the first session of today's program, that is Keynote Lecture 3, to be chaired by Dr. W. Rajendra and Dr. Kushal Das. Now, I'll request the chairpersons to kindly take over.
Thank you very much for giving the opportunity to be the chairperson for this Fips symposium. I'm very pleased to introduce Professor Mangala Gunathalake, who is currently the professor at Department of Physiology, Faculty of Medicine, University of Colombo, Sri Lanka. Professor Gunathalake has pioneered immunogenicity studies in canines following anti-rabies vaccination in the country. Results of the studies were used to revise the canine vaccination protocol in Sri Lanka in 2013. She is the founder president of Sri Lanka Association for Laboratory Animal Science, established in 2012, and introduced several alternative models, including zebrafish embryo model for Sri Lankan researchers. Professor Gunathalake has introduced laboratory animal science education to Sri Lanka in 2011 by conducting the first certificate course in LAS in the Asian region with support of international LAS organizations. She is the country representative in International Council of Laboratory Animal Science and was a member of Asian Federation for Laboratory Animal Science Associations. Professor Gunathalake is the founder director of 3R Center for Laboratory Animal Science in Sri Lanka. Furthermore, she is the joint secretary of the South Asian Associations of Physiologists since 2012 and a member of the Education Council of Federation of Asian Oceanic Physiological Sciences. Keeping in view of her significant academic and research contribution, she was conferred with many prestigious national and international awards. To name a few, National Honors Vidyanidhi in 2019. So in her biodata, I've seen very interestingly, the Vidyanidhi is in front of her name. That means that it's a very, very prestigious award, like Padma Shri in India. Turkey Innovation Award 2018, USA, Charter Program Veterinary Scholarship Award by Charles Laboratories Corporation, International Opportunity Program Award by the American Physiological Society, Best Women Leadership Excellence Award in Academic Sector by the South Asian Partnership Summit and Business Awards, Women Leadership Experience Award in Academic Sector by the South Asian Partnership Summit and Business Award, National Award for Science and Technology Achievements by National Science Foundation 2014, National Research Council Merit Award for Scientific Publication. The Commonwealth Bureau of Animal Health Prize and recognition of her achievements and contributions to science and technology. She has many publications to her credit in the form of conference papers and journals, newsletters, news articles, books, and e-learning publications. She carried out many research projects funded by National Science Foundation, University Research Grants, University of Colombo, IRQE grant, Sultan Qubas University, Muscat, Oman, Laboratory Animals Limited, UK, International Council for Laboratory Animal Science, Asian Federation of Laboratory Animal Science Association, International Council for Laboratory Animal Science, Animal Physiological Society, International Opportunity Program Award. This is very few awards, and because of time, not limited time, so I could not give details of many awards. I, on behalf of Federation of Indian Physiological Society, welcome Professor Mangala Gunathalake to enlighten all the participants with our illuminating keynote lecture on the topic entitled, "Do we consider immune response following canine anti-rabies vaccination to tackle human rabies?" Thank you very much for the opportunity. Over to Professor Mangala Gunateleke. Thank you, madam. Welcome to our conference.
Thank you, sir, for that kind and long introduction about me. And Aiboan, Vanakkam, and good morning to all of you who joined online for this session. Let me share my screen. Hope that my presentation is visible to all of you. Can you all hear me?
Yes. It is visible and audible.
Right. Thank you so much. At the outset, I would like to thank the organizing committee members, Professor Amar Kumar Chandra, and the president of the Fips, Federation of Indian Physiological Societies, for inviting me to be a keynote speaker in this important session. And the title that I selected for my talk is "Do we consider immune response following canine anti-rabies vaccination to tackle human rabies?" I am Mangala Gunatilaka, attached to Faculty of Medicine, University of Colombo. Very briefly, just to introduce, rabies is one of the oldest and most devastating zoonotic diseases known since 2300 BC. And today, rabies is considered as a neglected tropical disease, which predominantly affects poor and vulnerable populations who live in remote rural locations. So with that brief background information, I would like to take you through reporting from a laboratory, that is a historical perspective, and briefly about pathogenesis of rabies, what is the global perspective, and also I am going to mention about the Indian and the Sri Lankan situation, and about the dog vaccination and research-based evidence, and what are the ongoing research in this line, and finally about a take-home message. If I report from the Louis Pasteur's laboratory, Louis Pasteur, as you all know, was a French scientist who was working on bacteria. So he is considered as the father of bacteriology. As rabies was prevalent during his time, he had extended his investigations into this deadly disease. He had inoculated the rabies virus into different animal models maintained in his laboratory. And you can see in the right-hand side, the figure, how he has maintained different animal species in his laboratory. These investigations led Louis Pasteur to develop his rabies vaccine by growing virus in rabbits and subsequently dyeing the affected nerve tissue to weaken the virus. And there was a report taken from the Google, and the report titled "Rabies Vaccine Saves a Boy." Pasteur had indicated on July 6, 1885, the vaccine was administered to Joseph Mister, a 9-year-old boy who had been attacked by a rabid dog. The boy survived and avoided contracting rabies, which would have almost certainly proved fatal. Report further indicates, good thing it worked. Pasteur was not a licensed physician and could have been prosecuted had the vaccine failed. The legalities were forgotten and Pasteur instead became a national hero. As stated in the report, by the end of 1885, several more desperate rabies-exposed people had traveled to Pasteur's laboratory to be vaccinated. During 1886, Pasteur had treated 350 people with his rabies vaccine, of whom only one had developed rabies. And September 28th is declared as the World Rabies Day to mark the death anniversary of this great scientist, Louis Pasteur. If I come to pathogenesis of rabies, very briefly, I would like to mention the rabies is caused by a virus. It's a bullet or rod-shaped virus, single-stranded RNA, this virus contains, which belongs to the Rhabdoviridae family. And when there is a bite by a rabid dog or scratched by a rabid dog, what happens at the site of inoculation? At the site of bite, there is viral replication, viral inoculation, and then viral replication. And what happens? These virus binds to nicotinic acetylcholine receptors at the neuromuscular junction, and these virus particles, they travel through the axons of peripheral nerves, reaching the spinal cord. Even in the spinal cord, there is replication of the virus, and it reaches the brain. So brain gets infected with this virus, and there is neural dysfunction in the brain. And finally, what happens? This virus transmits to the salivary glands, cornea, and skin and other tissues. So this is very briefly about the pathogenesis of rabies. If I just consider the global perspective about this deadly disease, it's a deadly zoonotic disease which could be prevented by vaccination. And according to the guide given here, this statistics is based on the 2016 WHO report. And according to the guide given here, you can see there are some of the countries which do not have these dog rabies or human rabies. So it is the North American region, the UK, Australia in the Asian Oceanian region, New Zealand, and Japan. In these countries, there is no dog rabies, no human rabies. Now in South America, there are pockets of different countries where there is controlled dog rabies. But when you look at the map, right, major part of the map, that is the African region and the Asian region, those regions are endemic to dog and human rabies. That includes India and Sri Lanka. And if you look at the world death rate due to rabies, it is approximately 59,000 deaths per year, which could have been prevented if we take proper measures to control rabies. And at the same time, it is mentioned that there is expenditure of about $8.6 billion per year, that is for the prevention and control of rabies that is around the world. And as I am doing this keynote lecture to professionals, scientists in an Indian platform, so I just search for information that is related to India. So this newspaper article published in January 2020 indicates rabies still very common in India. Despite a drop in number of deaths, non-availability of vaccine and untrained staff leave many victims vulnerable to death. So further information was obtained from the WHO website. It says that India is endemic for rabies, accounting for 36% of the world death, which is a high percentage. And true burden of rabies in India is not fully known because of the higher population in the country. Approximately 18,000, 20,000 deaths, alarming number of deaths annually due to rabies in India. And about 30 to 60% of reported rabies cases and deaths in India occur in children under the age of 15 years, as bites that occur in children often go unrecognized and unreported. Coming to the Sri Lankan situation, so this diagram indicates the progress of dog anti-rabies vaccination and human post-exposure treatment, leading to reduction in number of human deaths over the last 40 years in the country. Now, in this diagram, in the right-hand left-hand y-axis, it indicates the number of dog vaccinations. In the right-hand y-axis, it indicates the number of human deaths. And in the x-axis, it gives the years, starting from 1970 to 2020. And this yellow or the dark yellow or the orange line indicates the number of human deaths per year. And these purple bars indicate dog vaccinations, and the green bars, light green bars, indicate number of human anti-rabies vials used. As you can see, there is starting from about 377 in the year 1973. So there is a reduction gradual. There were changes in some years, but there is gradual reduction in the number of deaths, human deaths due to rabies. Now in 2020, it is below 50. That trend was started from about 2011. So it is less number of deaths compared to the initial situation as indicated in this diagram. And when we consider about the transmission of this deadly virus, so there are two cycles, urban cycle and the sylvatic cycle. Now, when we consider about the areas or the countries where the rabies, dog rabies is endemic, so urban cycle is the important cycle, that is dogs are considered as the main reservoir and the transmitter of rabies. But at the same time, there is this cycle, the other cycle, that is sylvatic cycle or the wild cycle, where the wild animals are responsible for the transmission of rabies infection, the virus. So the foxes, jackals, mongooses, and other mammalian species are responsible. And the WHO says if there is the dog vaccination, that is, if we can cover the dog vaccination up to 70% in dogs, that is high risk areas, that can break the rabies transmission cycle. Not only the urban cycle, but also the sylvatic cycle, because when we have this kind of vaccination that is high target, what will happen? We can establish a herd immunity, and we can maintain that herd immunity. Then when we maintain that herd immunity, what will happen? Again, the sylvatic cycle spreading of rabies can be removed or prevented. So this is considered, vaccination of dogs is considered as the most cost-effective strategy for preventing human rabies. We conducted a survey that is around 2017 and 18 to find out about the human, the dog immunization coverage achieved and the percentage of free-roaming dogs in the country. So the vaccination coverage in dogs, it is less than 50% according to our survey. And there is comparatively higher percentage of free-roaming dogs, it is about 30%. So because of the presence of relatively higher percentage of free-roaming dogs, controlling dog rabies is a challenge. Despite that challenge, we were able to come to a satisfactory situation in the country. And also, being a veterinarian by profession, although I teach medical students, I am a veterinary surgeon. And during my clinical practice, I encountered that there were vaccination failures even after vaccination of puppies and dogs. So because of the vaccination failures, and also there is no monitoring of the vaccine efficacy happening in the country, even at random level. So those are the deficiencies in this challenge. When we consider about the dog vaccination against rabies, there are two important things that we have to consider about the potency of vaccines available, that is the dog, the vaccines meant for animals, and also what is the efficacy of vaccination. So these are the two important determinants about the satisfaction of the vaccination. Now, when we consider about the efficacy of vaccination, we can determine the efficacy of vaccination by measuring two things. That is about the cellular immunity or cell-mediated or T-cell mediated immunity. The other one is the humoral immunity or antibody mediated or by measuring the antibody titer following vaccination. So because of the challenges that we faced, that I experienced during my clinical practice, and also there is no checking of the efficacy of vaccination at even at random level, I thought of initiating immunogenicity studies in dogs following vaccination. So I pioneered in immunogenicity studies in dogs in the country in collaboration with the Department of Rabies Research and Vaccine Quality Control of Medical Research Institute. Although they do on human samples, the immunogenicity after human anti-rabies vaccination, this was the first time, and they agreed to collaborate with me to conduct these immunogenicity studies. And they have a well-established method to determine the actual level of antibodies following vaccination. That is the rapid fluorescent focused inhibition test. It's a virus neutralization test. And the project one was carried out, designed by me, that was in around 1998. And it is to determine the virus neutralizing antibody titers on different identified dates, that is day 0 immediately before vaccination and after vaccination on different time points. That is day 31 a month after the vaccination, 6 months after the vaccination, and 1 year after the vaccination. In order to see the immune response that is after vaccination and how long that the immune response is maintained after vaccination, that is until 1 year. So I selected my hometown area and its suburbs to conduct this preliminary study. And in this preliminary study, we recruited only the domestic dogs, and you can see the number of dogs recruited. It is only a minimum number. And there were two groups, adult dogs and puppies. Adult dogs between 1 to 5 years, and the number is 33. And puppies, it is 3 months old puppies. 19 puppies were recruited to this study. And the adult dogs group was subdivided into two subgroups. That is the group A, that is with the previous vaccination history, dogs having this previous vaccination history, and group B without the previous vaccination history. And when we take the puppy group, the C subgroup included puppies of vaccinated female dogs. That means the mothers are vaccinated, and the D groups, mothers are unvaccinated. So only 4 groups, domestic animals were included, and the number was limited to 52. And when we look at the immune response following vaccination in these different groups, in adult group, that is group A with the previous vaccination history, you can see that the initial the immune response starting, that is D0, starting at 5.73 something and going up to 26. These are the mean antibody titers. And coming back at the end of 1 year, it is more or less to the same level at the beginning, that is day 0 level. And the other important thing, 0.5 international units per milliliter is identified as the protective level of antibody titers to have in animals and also after vaccination in humans. So that is the protective level indicated by WHO. But when you take compared to the group A, group B is the unvaccinated animals. That means without any previous vaccination history. So you can see day 0 sample, they don't have the 0.5 level. And also their antibody titer after 1 month, it is not so high like in group A. And finally, this 361 year after immunization, although they have this mean antibody titer 1.3, most of the animals, they didn't have the protective level of antibodies. And when we consider puppies, now you can see even after vaccination, their immune response is 0.84. It's not very good immune response. And after 6 months and 1 year, they are below 0.5 level. And similar pattern is observed in puppies of unvaccinated mothers. And coming to the project 2 that we conducted, it's a comprehensive study that is on samples were collected on the same timelines, that is day 0, day 30, day 180, and 360, that is 1 year after the vaccination. And we included a representative canine population in this study. And the number of canines or dogs included is 380. Basically, there were 2 groups. The stray animals were included, not like in the preliminary study, only the domestic animals were included. In this one, stray dogs were also included, more than 1 year of age. And the domestic category, there were juveniles, adult dogs, and puppies. You can see the age differences that we included these different categories of animals. And stray animals, again, with the previous vaccination history, because the National Rabies Control Program has documentation where the areas are covered with the anti-rabies vaccination. So there are areas we obtained from the same documents where the areas, the dogs were not given the vaccination. So we recruited stray animals to group B who did not have previous vaccination history. And domestic animals, as I mentioned earlier, based on the age, vaccination state, whether previously vaccinated or not, whether regular vaccinations had been done. So considering all these things, we groups C to H in this second comprehensive study. And these are the results of these different groups. I'm not going into details of these things because it is a little bit complicated. And also here it shows not the mean antibody titers, but the median rabies virus neutralizing antibody titers in the stray group and the domestic group. And based on the 2 studies that we arrived at conclusions, and the recommendations that we made includes the following: anti-rabies vaccination to puppies, as based on the antibody titer measurement, there was no protection by maternal antibodies until the first anti-rabies vaccination. And also the first anti-rabies vaccination should be done before the age of 3 months. And first booster at a suitable interval, that is in the first year of life after the first vaccination. So it is necessary to give a booster vaccination at a suitable interval. Why? Because there is no maintenance of antibody titers until the 1 year of the booster vaccination. And it is necessary to go for annual revaccinations. And these were the results or the research-based evidence available in the country. So the Faculty of Veterinary Medicine and Animal Science, they used our research data to reschedule the vaccination, the canine vaccination coverage. So as you can see in this table, so there are 2 things they have indicated for pet dogs and stray dogs. If the pet dogs from previously immunized mothers, then the first inoculation at the 6th week and the first booster in the 14th week of life and pre-vaccination annually. And if the mother is not immunized, the recommendation made was at the time of presentation after opening eyes. So first booster, similar to the previous group, it is the 14th week and annual revaccination. But for stray dogs, the first inoculation, same as in the non-immunized group of puppies, but the first booster after 10 weeks with the annual revaccinations. Why they have decided without any evidence for the first booster? Because usually for pet dogs, the other vaccines are also given, not only rabies, the parvo and the triple vaccine. So because of that, so they delayed the first booster vaccination to 14th week of age. But in stray dogs, we don't give the PAVO and the DHL vaccines, only the rabies vaccine is given. So because of that, the first booster was determined, that is to be given after 10 weeks of the 10 weeks. And in order to find out the efficacy of this vaccination, revaccination schedule, we wanted to concentrate on the pattern of immunogenicity in domestic dogs. We included only the puppies and juveniles, following primary and subsequent booster vaccination against rabies in an identified municipality area. So we initiated this study in 2017. We have already recruited animals, puppies and juveniles, and we are in the process of analyzing samples for antibody titers. Now, I mentioned initially, it's important to have the dog rabies vaccination, and the vaccination against rabies, that is, there are two things that will be affected. The immunogenicity is affected. So based on the potency of vaccines and the efficacy of vaccination. Now, the potency of vaccines are not checked in the country. So it is the potency of vaccines. The test is considered as the National Institute of Health test or the mouse inoculation test that is not done in the country. And as I mentioned earlier, efficacy of vaccination could be determined by humoral immunity, as I discussed based on the two projects that I conducted, and the cell-mediated immunity. Again, there is no established method in the country to determine the cell-mediated immunity following vaccination of dogs. So as the potency is not checked, of the potency of the vaccines available is not checked in the country, I wanted to look for the potency testing of the canine anti-rabies vaccines marketed in the country, in addition to immunogenicity. So I designed a study, an experimental study using rabbits. Why I selected this rabbit as the model? Because there are no laboratory maintained dog facilities in the country. So because of that, I wanted to conduct the study under standard conditions, giving similar situations to all the animals. So because of that, the rabbit species experimental model was selected, and I am collaborating with the Animal Center of the Medical Research Institute to conduct this study, experimental study. And after doing the potency testing of the canine anti-rabies vaccines, there are about 7 different brands of vaccines available in the country, that is for animal vaccination. So because of that, I wanted to do the potency testing, and I sent the vaccine samples to our collaborating lab in France in order to conduct the potency of canine anti-rabies vaccines. And also after selecting the best vaccines, 4 different vaccines, vaccine brands, and I'm going to evaluate the immunogenicity of selected vaccines, these 4 different vaccines in a sample dog population under field conditions. Currently, we have completed more than 75% of the experimental study. We have completed the potency of canine anti-rabies vaccine testing, and we have identified 4 different vaccines, that is for the dog, the field testing, and we have initiated this field testing, but because of this pandemic situation, it got delayed, that is in 2020 and 2021. So by all these studies, my aim is to be that is to provide some information and also make recommendations to our rabies control authorities, that is to acquire or to reach the global strategic plan to end human deaths for dog-mediated rabies by 2030. And in order to achieve this global target, it is necessary for us to engage in the engagement of multiple sectors and One Health collaboration, including community education, birth control measures in dogs, awareness programs, and vaccination campaigns. During this keynote lecture, I tried to give you an idea about the immunogenicity and its importance following canine anti-rabies vaccination in order to tackle human rabies. So if we can achieve our target, then we can support the global target as well. And these are my research collaborators at national level, Medical Research Institute, and from the Ministry of Health and Colombo Municipal Council, the veterinary surgeons. And also I have these international collaborators, that is from France, WHO Reference Laboratory. So thank you very much for your patient listening. And I would like to thank once again the organizing committee, the president of Fips, and Professor Amar Kumar Chandra and Professor Kusal Das for inviting me to deliver this keynote speak that is on the identified title. Thank you so much.
Thank you very much, madam, for your illuminated lecture on the canine vaccines. And recently I've heard that the cat bite is also going to cause some deaths. That's what I've seen in the recent newspapers.
Yes, that is right. We are not considering about cats more, but there is contribution by cats as well.
So rabies infection can be done by any animal or only
mammals? Because mammals only mammals get this rabies infection, and they can transmit rabies virus to other animals and also to humans. But the rat bites causing rabies is not documented anywhere.
Thank you, madam. So is there any questions from the participants?
Yeah, just I will like to ask the questions to, not question, just certain curiosity I'm having with Dr. Mangala. First of all, I'd like to tell that to Dr. Mangala, it is an excellent talk and a very lucid talk. The thing is that what we see in the scientific domain, specifically in the keynotes and plenaries, they become the too much jugglery of the science, which actually difficult to understand the persons who are not directly involved in this type of research. But your work was so perfect because this is the common phenomena which everyone suffers. So we understood very well what exactly the steps and what exactly the situation in your country that reflected near about the similar in India. There is no difference. Even you cited the Indian newspaper cutting of the seriousness of these issues. I have one query, Mahir, here before I hand over to the other persons to speak. So I wanted to speak on that, asking question that how the puppies of dogs are being tracked for booster dose.
How the puppies?
Because, the mechanism by which the puppies are traced that they have given the first dose and they need the next dose.
Yes, I don't know whether you noticed, under domestic category only we recruited puppies. So domestic dogs means they have owners. So we asked the owners to bring their puppies and dogs that is on the identified time points. If they can't,
that I saw it.
So we go to their places in order to collect the blood samples.
Right, but the thing is that you have shown that the matter is very serious when it comes to the stray dogs, and stray dog puppies are not monitored, and stray dog you have shown that they are given the vaccinations as well as, but puppies, how they will be monitoring the stray dogs?
The stray puppies we didn't include in this study.
No, you didn't include. No, I am just asking about what should be the actually policies, because the dogs which are domestic, that can be monitored very well because they have an owner, but there are no owners specifically belong to the stray dogs, and that's the issue of the rabies comes mainly from
that's
the
right, sir.
external, not the internal domestic dogs.
Yes,
so
that's right.
any policy of the animal this committee or any of the government or any of the issue, because you work with the many of the countries in this regard, any of the things you have come to your notice that they actually have a possibility or mechanism of control over that?
Now, they are sterilizing the stray animals mostly. That is to control the both birth of puppies. And at the same time, the National Rabies Control Program, they go to different parts of the country, and also they have notices indicating that they are coming to give vaccination and sterilize their dogs. So, and also at the same time, they are giving the dog collar, and also there is a ear tattooing kind of thing that they are doing. So by those mechanisms, it is possible to identify these stray animals to monitor their vaccination status. That's how we collected blood samples.
Yes, thank you very much, Dr. Mangala. Over to Professor Rajendra.
Yeah, I think we conclude the session, and I thank very much the professor for giving a very lucid lecture to all our participants. We have many questions regarding this one, because I am also working in animal welfare programs. Myself and my wife, we both are working for particularly the stray dogs. So we do all kinds of service to the animals on the street animals. And we have so many questions regarding this one, because we are, our country or our system is doing only sterilized process, but not vaccination. So they take the dogs and then sterilize and leave it there on the streets again. But they're never bothered about the vaccination phenomena for the dogs because of the constraints of the money or constraints of the human resources, whatever it is involved in all these things. So that is not being done. And we always say that the stray dogs are biting us, and then we are getting the rabies and all these things. Unless we do that one, we cannot control the complete vaccine, the rabies, just like in North American continent. So many countries in the world, as you were shown the graph, so many countries having this kind of human deaths, but not in North American continent and some like European countries, but not in our countries just because of these factors. Anyway, so thank you very much, madam. If you have any specific comments on this one, you are welcome. Otherwise, we can conclude that.
Right. Thank you so much once again for inviting me to deliver this talk. Right. Okay. Thank you.
Thank you very much for your nice talk. And then I request the organizers to conclude the session, and then we can go for the next session. Thank you very much. Hello?
Yes, sir. Please say.
Yeah, please.
Thank you, Professor Mangla, for such an informative session describing rabies and its immunological aspect in such a brief period of time. We also thank Dr. Rajendra and Dr. Kushal Das for chairing this session excellently.
Thank you.
We will begin the next session in next 10 minutes.
Okay. Thank you.
Welcome, sir. I'm audible?
Yes, Dr. Akshay, nice to see you.
Nice to see you too, sir. Welcome to this program. We look forward to your plenary lecture in a few minutes.
Okay. And thank you so much at midnight in Los Angeles. You are now joining us. That shows your commitment and love for me and our research on yoga. Thank you so much.
It's my pleasure, sir. Welcome.
Good morning, sir. Shall we start with the session with your permission?
Yes, please. Yeah, I'm ready.
Yes, sir. I'll formally begin the session. Now we'll begin with our next session to be delivered by Dr. Selvamurthy and to be chaired by Professor Akshay Anand and Dr. Pratibha Jolly. We will request the chairpersons to now kindly take over.
I hope that the meeting has been going on in a very physiological centric manner, and this meeting cannot be complete unless we have a very important topic, that is yoga health, and none other than Dr. Selvamurthy can do the justice to this topic. I'm joined by my co-chair, as just introduced. Dr. Selvamurthy is not only a great scientist, but also very close to the armed forces, as he worked actively for DRDO for over 4 decades. He hasn't given up academics, he's still active and is the president of MIT University. They have a campus in Chhattisgarh. Dr. Selvamurthy's contributions to DRDO and neuroscience with focus to yoga inspiring. His basic of having a master in physiology and a PhD in medical sciences, faculty Delhi University, and a DSc from Bangalore back in 2006. And Dr. Selvamurthy's 40 years of work has revolved around developing defense technologies, science and innovation, nanotechnology applications for defense, and of course, applications of yoga for the armed forces. He's been the chief controller, as I mentioned, of research and development wing of DRDO. He currently serves with his extensive experience in science and innovation to the Department of Science and Technology, and is also part of several committees, including being chairman to PSC in DST, the field of life sciences in international cooperation with several countries. He's also a member of the scientific advisory to the cabinet and all other many committees of the government of India that draft policies for advancement of research in India. He has got several awards, including the National Award for SNT Innovations presented by the Honorable Prime Minister of India in 2012. That was 9 years ago, 10 years ago. And the academician received the Mirakhimov Award for contribution to high altitude medicine, something, a subject that is also very close to my heart and is a ideal environment of high altitude for yoga intervention studies. He has also won earlier in his career the ICMR Shakuntala Amirchand Award and several more. More than anything, he's a darling to the neuroscientists, not only in India, but outside India as well. He speaks with eloquence and has an absorbing personality, and we look forward to listening to him. And this is going to be a plenary lecture. We all are ears and eyes to Dr. Selvamurthy.
Thank you.
Welcome, Dr. Selvamurthy.
Thank you, Dr. Akshay. And also delighted to see very distinguished physiologists, scientists. Thanks, Professor Akshay, and whom I have known for decades now, more than 3 decades, and worked together. And thanks for your generous, very kind introduction. And also thanks to Dr. Shashibala Singh, who is the president Fips, who is now spearheading the physiological societies as president for Fips. This society is important. Before I start my lecture, I want to give a clarion call to all the physiologists, not only human physiologists, animal physiologists, comparative animal physiologists, and Physiological Society of India, APPI. All of us have to come together because physiology as a discipline is very, very important. And once we are integrated, because you can't in the biosphere separate all this. So we need to be united. That is the purpose of the federal structure, Federation of Indian Physiological Societies. So my clarion call to each and everyone, let us unite together, meet more often, work together, and also let us bring collaborative research to look at collectively for improving the quality of life on this planet. So with this clarion call, I want to start my lecture. And this lecture, I'm going to focus on the physiological perspectives of yoga, because now yoga has assumed great importance. It is a global stage. Our Honorable Prime Minister, Shri Narendra Modi ji, has taken yoga to United Nations. And now International Day of Yoga is being celebrated across the globe, almost all nations. And there are centers, they are practicing yoga. So it's time for us to understand the potentials, the prophylactic, promotive, curative potentials of yoga through the physiological, biochemical, psychological perspectives. Then let us put it on a scientific pedestal in a very strong way so that the whole global community acceptance will further improve. And all of you, I think many of you are engaged in the research in this area. So I would give a little glimpse of research which I have done when I have been in DRDO, particularly for soldiers who have to work in extremes of environments, high altitude, cold, desert, underwater, aerospace, low intensity conflict environment. So it's a very highly challenging operational environments in which our soldiers work. So how do we harness this potentials of the Indian traditional knowledge, wisdom, particularly yoga, meditation, into soldiers, and so that their performance improves for the safeguard of our sovereignty of our nation. So I'm going to give the glimpse of those experiments which we have done, physiological experiments which I have done when I have been in DRDO. Let me share some slides. Is my slides, are my slides visible? Thank you, Akshay. So I'm going to look at yoga for holistic health, and particularly from the physiological perspectives, because this forum is where we have many physiologists and biologists and medical specialists over here. So my compliments to the NIPA, which is hosting this under the leadership of Dr. Shashi Bala Singh, the president of Fips, and also all the office bearers who have given me this opportunity, the platform to share some of my thoughts, knowledge in this field, experience over a period of time, 4 decades. And this COVID-19 situation brought us a new focus on Ayush system, including yoga, Ayurveda, Unani, Siddha, homeopathy, everything together. Those people who adopted this, either they were protected from the COVID-19 problem, or the problem was less severe if it was manifested. Then it also recovery was faster. They came back to normal life pre-COVID much earlier. So this is what the scientific reports, not my reports, Ayush reports indicate, and scientific reports indicate that Ayush system, our own ancient Indian wisdom and traditional knowledge of health, really came to rescue. But then we have to understand it more scientifically, how it helped. So I'm going to give some glimpses on that. So people, these are reports available today from Morarji Desai National Institute of Yoga, Central Council for Research in Yoga and Naturopathy. And they have also given a common yoga protocol for the people to adopt during the situation, which really helped to ameliorate and prevent the problem to a very large extent in our country, in addition to our own vaccine coming in. So yoga became a very, very powerful tool, particularly the isolation, monotony, separation from family in the lockout situation. Everyone was living in isolation. So here yoga really helped to keep your physical, mental, and spiritual health, which has been reported scientifically as well. Now, salutation to our Honorable Prime Minister, Shri Narendra Modi ji, who has taken yoga now to a global level. And all of us now have to contribute, celebrate Yoga Day, practice yoga. I have been practicing yoga for the past 40 years now. Since I joined DRDO in 73, 75, I got introduced to yoga in Vishwayatan Yoga Ashram, and Dhirendra Brahmachari used to be the director. So I learned at that time there. I'm still continuing the yoga regularly. So if I am healthy, I'm not taking any medicine for diabetes, hypertension, coronary artery disease or something. And I climb stairs, 5 stairs of my university, Amity University every day. And so that's because of yoga. So if I have achieved something in life, that's because of yoga. So I would give both experiential learning as well as the experimental learning through physiological studies, which I have done. So if you have to understand physiology of yoga, you have to understand 2 concepts of yoga. One is our existence. Our existence is at 3 levels. The first level is physical, that you are living in the body. The Atma lives in the body. So the Sthula Sharir. Then you have a Sukshma Sharir around you. So you exist at subtle level as well. So that is the second level of existence, which some of them you can monitor by thermography, electromagnetic field monitoring, Kirlian photography, aura photography, and so on. Then you have a third level of existence, which is Karana Sharir, which is purposeful existence. So if I am coming today to interact with all the physiologists of Fips members and students, so there's a purpose for it. So I exist for this purpose at this moment today. So you have a Sthula Sharir, Sukshma Sharir, and Karana Sharir. So this is one concept. The second concept is even the physical existence. You exist at 5 levels: Annamaya Kosh, Pranamaya Kosh, Manomaya Kosh, Vijnanamaya Kosh, Anandamaya Kosh. This is all physiology. Annamaya Kosh, a dead body, a corpus, is also a body which has got everything what I have. Once you put prana, then the energy level flows in. So you have a second layer. Then even a coma patient has all the life, everything inside, but then he doesn't know what's happening around. So Manomaya Kosh, once you put that layer, then it adds to Manomaya Kosh, then intellectual power, then blissful layer. So this is your 5 layers of physical existence as well. Now, I would focus on my research on 3 aspects of potentials of yoga: the prophylactic, the preventive aspect; promotive, how it brings the best in you, all your dormant potentials, Kundalini Shakti awakening happens. So how does it do that? Promote all your manifestation of your potentials. Then how it can help to cure disease. So these are the 3 aspects of my physiological studies, which I have done at DRDO, which I will give a glimpse of these in this next about 20-25 minutes. You name any disease, you can attribute to any one of the 5 factors, leaving away the genetically mediated disease. One is lack of exercise. Our body, if you really look at the evolution of our physiological system, it evolved to be physically tough. Our ancestors were living in mountains, caves, jungles, facing the vagaries of the climate, running away from predatory animals, hunting for the food. So this body was meant to be physically tough, but over a period of time, it has undergone disuse atrophy. We don't use the body. So it undergoes disuse atrophy, which becomes one of the highest risk factors for many health disorders. Then the second is dichotomy between mind and body, disharmony between mind and body. For example, in the morning, all of us had breakfast. How many of us really focused on the eating process? Our mind was involved in looking at a mobile phone, some reading news or mail, and then food, physically the food was pushed inside. So there's a dichotomy between what mind does and then what body did. So mind was in the process of looking into some other aspects, and then body was throwing food. So this food will help to release the hydrochloric acid, digestive enzymes, all this will be poured in by the physical presence of food. But then unless your mind is involved, the saliva won't secrete properly, which is relatively alkaline, which is have to go and neutralize the acid formed inside the trypsin and others released into your stomach. So the first part is your mind involvement. If is not there, then peristaltic movement, digestive process, absorption process, all this will be impaired. So you will end up in hyperacidity, peptic ulcer, dyspepsia, and constipation. Such problems can occur by simple example of dichotomy between mind and body. Third factor causing disease is stress. All of us are facing stress of some kind or other in our life. So stress can become an etiological factor, causative factor, or it can become a precipitating factor. If we have a genetic predisposition, the stress can precipitate the disease. Yoga can aggravate the disease. If you already have a disease, the symptoms will be aggravated. So stress can be a causative, precipitating, or aggravating factor. Fourth is pollution. The air that we breathe, the water we drink, the food that we eat, everything is polluted. So pollution can cause disease. Fifth is infection. Fifth is infection. We have virus, fungus, bacteria, everything in our environment, toxins. So all this can cause disease. Leaving away the genetically mediated disease, you can attribute any one factor or a cumulative factors responsible for the causation of disease. Yoga can prevent all this, take care of all these 5 factors. How? Yoga is a total exercise. It exercises your body, musculoskeletal system, neuromuscular junctions are activated, receptors are rejuvenated, the massaging of the internal organs like Nauli Kriya, Kriyas, throwing away your lactic acid, pyruvic acid, toxins away. So you have Kriyas. All this is a total exercise, total physical, physiological exercise. So it takes care of the first factor, lack of exercise being a causative factor. Yoga can be practiced anywhere, anytime. So that is the beauty. You don't have to have a special environment, special appliances. So it can be done easily. So yoga it takes care of the first factor. Second is in yoga practice, if you make a small movement like this, you are instructed to be conscious of the movement. Mind does the same thing, is conscious of what is happening in your musculoskeletal system. So there is a unification between mind and body, taking care of the second factor. Supposing I drink this glass of water, I should really enjoy that water going inside, lubricating my oral system as well as the esophagus. So I should feel it. So this is yoga. Yoga is not just practice of half an hour yoga, asanas. It is a way of life. So here, unification of mind and body, even the definition of yoga means to yoke, to unite, to join together, to bring harmony between mind and body. So it takes care of the second factor. Third factor is stress. Stress management is very simple. Three steps. Normalize your perception, optimize your reaction to stress, release the stress as early as possible. This is all stress management. 3 steps in stress management. Yoga helps in all the 3 steps. Yoga is a total exercise, and also it builds the parasympathetic tone. It brings all your physiological functions, biochemical functions to the lower side of the normal range, thereby giving a greater buffer for reaction. So yogic practice is helping you in 3 ways to manage the stress. First, it normalizes your perception. That is the starting point for your reaction. So you have a philosophy. We have come with our own karmic account. What is there in my hand is to perform my action properly. And then whether I'll get accolades, return on investment, or the benefit of outcome for my whatever I have done, there are many extraneous factors. So yoga gives you that philosophy. Do your karma properly without hankering for the outcome and the results. And that will come automatically as a consequence. So this philosophy itself normalizes your perception. It optimizes your reaction because your cooling system, the parasympathetic system, is built by, is strengthened by practice of yoga. So it doesn't allow an exaggerated arousal or reaction response, but it optimizes your response, quickly restores the equilibrium back to normal. This is how yoga manages the stress. So yoga takes care of the third factor. Fourth factor is pollution. Body has been blessed with physiological processes, systems, which will take care of pollutant to a large extent. Liver, kidney, spleen, reticuloendothelial system, cilia, all this can manage the pollutants to a very large extent. But yoga will strengthen these inherent physiological detoxification mechanisms blessed in our physiology. The fifth is infection. Again, body has been given two kinds of defense mechanism, the cell-mediated immunity, the humoral immunity. So like your gamma globulins and beta globulins, and also your cell-mediated immunity, CD4, CD8, NK cell, and all this will see your soldiers in different regiments are strengthened, thereby your immunity improves. So you are not vulnerable, susceptible to many diseases. So yoga takes care of the infections as well. This is what is prophylactic effect of yoga. This is how it brings the prophylactic potentials of yoga. How yoga is promotive. I'll give actually scientific evidences to that, but now I am summing up what I'm going to speak now. It is promotive. Your physical performance improves. See, I'm now 73. At this age, I can just climb stairs easily. And I don't take any chronic medicines for diabetes or peptic ulcer, all this. So in this 73 years, I have never been once hospitalized, admitted to hospital. So this again because of yoga. So yoga, it promotes your potentials. If I have achieved something in life, I will attribute to yogic practice, which gave me the right kind of composed mind, concentration, memory, cognitive abilities, decision making. All this yoga helped me. So yoga is promotive, but I will give scientific evidence to show how yoga improves your physical performance at submaximal level, and also it improves your cognitive abilities, thermal tolerance to heat, cold, and also your psychological efficiency goes up. Then yoga is curative, particularly in diseases which are related to stress, lifestyle, psychosomatic. So I will give either yoga could be used as an adjunct therapy, or it could be used as a regular system for treating and curing the disease. I will give some case studies which we have undertaken in DRDO. So these are the benefits. I will give you the mechanisms. It improves the physical performance, psychophysiological responses. I'll show you results instead of describing here. So what we did in DRDO has the advantage of having soldiers as our experimental subjects, volunteers for the study. And there you can control many of the physiological variables. For example, I can ask for a same ethnic group, same age group, and also same lifestyle, their same routines. So if I ask them to do yoga from 6 to 7 in the morning, exactly to start at 6, exactly at 7, we can conclude, which is not possible in a civilian setup. So I had the advantage of carrying out these variables which will interfere with physiological studies could be regulated, controlled in our experiments. So I had 3 groups. One group which does the routine physical training program of the army for about 1 hour, which is their schedule. Physical exercises, games, and body flexibility exercise, muscle building exercises. That is the control group. Then I had another group where yoga was substituted for physical training. So in place of physical training, yoga was given, because in the military environment, in some like submarine, you won't be able to do physical exercise, what you will do in otherwise at the plains, or in a extreme high altitude like glaciers at 20,000 feet. You cannot be doing all the routines of the physical training. So can yoga substitute for the physical training in such conditions? The third is, can we supplement? Because today warfare is just not only your killer instinct, aggression, muscle power, endurance. It is much beyond that. It is cognitive power, psychomotor performance, decision making, and your cool mind to be kept at the time of adversities. These all are very important, which cannot be given by your conventional physical training. So can we supplement physical yoga in the morning and physical training in the evening. So we had 3 groups. I will show you some of the results between control and experimental group. So we had, these are some of the systems which you go to DPAS, you will see all this, which we use in the Defense Institute of Physiology and Allied Sciences, which we carried out, including functional MRI at INMAS and positron emission tomography. I'll show you some of these fMRI pictures and so on. So we use these physiological gadgets to measure like UO potentials, EEG, respiratory measurements, and also treadmill and bicycle ergometer. And all this, we did controlled experiments on these people, control group, experimental group. And I'll give you a little glimpse of the physiological results, which I'll show you. And instead of going into the details due to paucity of time, I will give only what is the salient physiological outcome of these slides. If you see this slide, heart rate as well as blood pressure, we measured initial, that means at the time of starting the experiment before they were inducted into the yoga. And then during 6 months of yogic practice, both control group, which was doing physical training, and the yoga training, which is shown here, yoga group, we found all the functions like heart rate, systolic, diastolic, respiratory rate, all these were coming down, indicating that there is a buildup of parasympathetic tone in the people who practice yoga. Sympathetic tone is reduced and parasympathetic tone is built over there. Then your breathing, the rate becomes low. The slide which you see here, the blue graph, the respiratory rate goes down, but the depth of breathing, the minute ventilation goes up because your tidal volume is higher. So this is what is the most efficient way of breathing. So yoga practice helps you to make your breathing slow, deep, and rhythmic. This is what we found in our study, that your breathing becomes very, very proper and economical. Then we looked at the heart rate variability spectrum, HRV, which indicated what I said, the shift from the sympathetic to parasympathetic and buildup of parasympathetic tone is shown here. The power density improvement in the higher frequency, which has been shown here, indicates that there is a shift of the autonomic equilibrium from sympathetic to parasympathetic dominance. And I looked at the different waves, delta, theta, alpha, beta bands, which you have in EEG. How does that get transformed during the yogic practice? So what I found that during the yogic practice, the buildup of alpha index, you see here, alpha index, which is between 8 to 13 hertz, that power increases, which is shown in the next slide. That you see the power here, the alpha waves, this was the power at the initial stages, but after 6 months of yoga lifestyle program, then we have found the power in alpha band tremendously increases compared to this. You see this. This is what has happened, mental tranquility. So one side, the autonomic equilibrium, you have parasympathetic tone buildup. The other side, in the central nervous system, there's a tranquility of mind, which is shown here. Then we looked at the functional MRI. What we found in the people who practice meditation, particularly Raja Yoga meditation, we found that the prefrontal cortex, right front prefrontal cortex activation was seen in many of these meditators who have done meditation for more than 10 years. We have taken Raja Yoga meditators. And so this indicates your higher nervous function, decision-making process, extrasensory perception, such kind of potential can also be enhanced by the practice of yoga and meditation. Then we measured the body flexibility at various joints in the people who started yoga after middle age, after 45, when they start yoga. There is improvement in all these joints, shoulder flexion extension, neck rotation, trunk flexion extension, all this using goniometer. We measured the angle of flexion extension. So there is a improvement in body flexibility and suppleness by practice of yoga. Then we put them on a bicycle ergometer or treadmill. We use treadmill. And then we measure their submaximal level of exercise and maximal level of exercise. Then we measured particularly the lactic acid buildup, which puts a seal of exhaustion or fatigue. This is one of the important factors for fatigue. So we were looking at the rate of buildup of lactic acid during the practice of submaximal exercise. So in this, you will see that at the submaximal level, there's a rightward shift of the curve of the lactic acid buildup. What does it indicate? That you can perform this exercise for a longer time in people who practice yoga, that there's a rightward shift, which indicates your onset of fatigue will be much later as compared to a control subject. Then we looked at the biochemical profile, like blood glucose, cholesterol, total proteins, all this. Dopamine beta hydroxylase enzyme, which is a precursor for DVH, is a precursor so for dopamine. So all this we looked at to see that how yoga, the message from this slide is that how yoga brings the biochemical functions also close to the normal range, lower side of the normal range. This is what is indicated by this slide. Then the next part we did, we put them in a cold chamber at 10 degrees with only shots on, the control group and experimental group. So we put them for 2 hours in this condition up to 10 degrees without clothing. It's a very severe stress. And then we were looking at how does the core temperature, mean skin temperature, shivering by integrated EMG, oxygen consumption, all this we measured. The message we got from this study is that yogic group of people are able to maintain a higher core temperature as compared to the physical training group. So they were maintaining a higher temperature. This could be achieved by 2 ways, either by minimizing the heat loss during cold exposure or by generating more heat to compensate for the loss. So we were looking at mean skin temperature, which will indicate whether it is achieved by heat conservation. Mean skin temperature did not show any difference between control and experimental group, but how this could be achieved is by heat production. There are 2 methods of heat production. One is by shivering thermogenesis, the other is non-shivering thermogenesis. So we looked at the integrated EMG, which indicated yoga started, the shivering started much later and was of low intensity in yogic practitioners. Practitioners in the sense the soldiers who practice yoga. And so this indicated they achieved this higher maintenance of core temperature by non-shivering metabolic thermogenesis. So even common man, like a soldier, can achieve the benefit to improve their cold tolerance if they practice yoga. Then we looked at the psychological profile. This slide shows the anxiety level goes down as compared to initial to 6 months. Depression score goes down, whereas the concentration improves, vigilance and alertness of mind improves in the yoga group. So indicating that yoga has also psychological benefit, physiological, biochemical, and psychological. Then we looked at the glucose tolerance curve. How does it shift over a period of time of in the control group, that is PT group and yoga group. So you will find the green curve, carbohydrate handling mechanism is much more efficient. So you will be protected getting into diabetes, diabetic tendencies, the people who practice yoga. This is what this slide shows. Then everyone claims yoga is good for hypertension. But our group was looking at how, in the past, and how does yoga help to control the essential hypertension, which is the major part. 90% of hypertensives are essential hypertension. So we took 40 patients, randomly divided them into 2 groups. One control group of patients were put on a tilt table, and the table was tilted 70-degree head up and 45-degree head down with the patient on. So there's a passive tilt. In the experimental group, I selected asanas which involves a postural tilt. Like for example, Ardha Halasana, Viparita Karni, Sarvangasana. All this involves a head down postural tilt, head down, leg up. And then I selected asanas which involves the head up tilt, Bhujangasana, Dhanurasana, Surya Namaskar. All this involves a head up tilt. So your control group is on the tilt table, tilted head up and head down. And in the experimental group, we selected asanas which involves a postural tilt. So the hypothesis was the baroreflex, the baroreceptor which are there in the carotid sinus, which senses the phasic variation in the blood pressure, it goes bad, goes sluggish in hypertensive patients. So is it possible to reactivate this sluggish baroreflex mechanism through yogic practice? So that was the hypothesis. So that is why control group on the tilt table, because when you tilt head down, then you have the pooling of blood in the head and neck region will stretch the baroreceptors. It will stretch the baroreceptor. And then you remove and put it in head up tilt. Then it will remove the stretch. So constantly, alternately, putting the stretch, removing the stretch, putting the stretch, removing the stress, can you reactivate this sluggish baroreflex? So this is on the control side. Then experimental group, we were involving, besides this postural tilt mechanism, you have reduced anxiety, all this, can it correct this? So we found this slide shows that actually yogic practice reactivated the sluggish baroreflex back to normal, which in turn corrected your renin-angiotensin and catecholamines, all this which is shown in this slide, that it gets corrected, thereby blood pressure comes to normal, including your alpha index of EEG, tranquility, everything is taken care of. So we found a unifying role of baroreflex, which gets corrected by yogic practice. Then we did on coronary artery disease. We took 524 cases of coronary artery disease patients where at least 70% blockade in one of the coronary vessels. So this experiment was done along with the Mount Abu, Dr. Satish Gupta and DIPAS, DIPR, together. We did this experiment. So what we found, I will not go into the details of all this very crowded slide, but we found all these factors responsible for the coronary artery disease, where we put diet, which is low-fat, high-fiber diet, Raja Yoga meditation, and also we have put also the regular aerobic exercise, which in turn brought this, the coronary artery patients, we demonstrated regression using coronary angiogram. So we measured also the melatonin, serotonin, dopamine, and all the stress hormones in addition to the coronary angiogram. Angiogram showed, see, in the control group, this is the control angiogram, the patient, you see the 52% blockade has become almost 72. There is an increase in the blockade over a period of 2 years we followed them. And they are on conventional medical management. So here in the lifestyle intervention where yoga was the main, Raja Yoga was the main component, you find the reduction from 89% blockade, it comes to 41%. So this is what the lifestyle, particularly the yoga practice, can help. Then we also found in these practitioners, all the negative emotions, anxiety, anger, depressions, self-consciousness, and impulsiveness. So these are all measured by the psychological questionnaires. So we found not only physiological benefit, but the psychological benefit as well. So how does this work, this yoga? It achieves the balance. So now coming to the mechanism, physiological mechanism, yogic practice bring all your body functions close to the lower side of the normal range. The range of every physiological functions have a range of normalcy. So yogic practice, whether heart rate being instead of 78, it comes to about 60. So your heart every minute takes 18 beats less in the yoga practitioner. So the wear and tear will be less. So this is what yoga does. So all the physiological biochemical functions come to the lower side of the normal range. This is because of parasympathetic tone. So during stress, you have a greater buffer for your reactivity. If you are on the top of the normal range curve, and you will shoot up, whereas if you are in the bottom of the normal range, you have a greater buffer of reactivity that will be optimizing your reaction to stress. This is what we found the mechanism. And so your wear and tear in your vital organs will also be much less. It is conservation. Yoga is conservation. The second is we also found it produces mental tranquility and it improves your physical and cognitive ability, promote you. And also it helps to cure the disease. So the message is we should, based on these studies and many studies across the globe, yoga should come in schools because that is the formative age of one's the child. You need to give that holistic education, which mind, body, soul education there at the school level. So this is one clarion call I want to give it to all the physiologists and the people who are attending. Let us bring that. Let us create a new world order where everybody is healthy, happy, peaceful, harmonious. So this can come through yoga as one of the important component of practice. So let us start in hospitals. All the caregivers, doctors, paramedics, the nursing assistants, everybody should know. They should promote this, and they should practice themselves first. They should be healthy, protected, and they will also have to give the knowledge to not only the patients, but also the caregivers and the family who accompanies this. So let us establish, and many hospitals in India have started yoga centers, which can use as adjunct to create a positive health. Then we should also bring it in corporates who face nowadays with all this working with computers, a lot of stress, they undergo challenges. So let us bring it in corporates, also similar thing. And we in Amity University, since I'm there, we have started the Amity Institute of Indian Systems of Medicine, where yoga courses we have started, BSc Honors in Yoga, MSc in Yoga, PhD in Yoga. We have a herbal gardens we have established 15 acres where the important medicinal herbs have done. We have started wellness program, and similarly happiness quotient to increase of our students. Then we have established in New York campus, we have a very big campus, 175 acres in Amity University campus in the Long Islands of New York, where we have put a vertical on Indian systems, the traditional knowledge, and sustainability is another vertical. So this kind of systems, Amity Institute of the Herbal Garden is being inaugurated by the our Ayush Minister, Shripad Nayak. This is our New York campus in the Long Islands, where yoga and Ayurvedic biology, we are going to start a course in Ayurvedic biology. And he is the founder president, Dr. Ashok Chauhan, who now we have 11 universities in India, 17 campuses abroad, and 1,85,000 students, and 13,000 faculties. So he is the founder. And what the message I want to give is that we are promoting traditional knowledge and wisdom in all these campuses, that yoga, Ayurveda, all this we are teaching for the holistic development to churn out the future global citizens who will be endowed with knowledge, including spiritual knowledge, skills, including soft skills and good behavior, values and resilience to face challenges, and ultimately to be happy and successful in life. So this is what is the final message. Yoga can do that, the last slide. And the clarion call to everyone, let us promote, popularize yoga across the globe for creating that new world order which I was talking about. Yoga can do that. There are so many yoga centers across the globe now, with International Day of Yoga being celebrated across the globe. Let us connect with them. And let us practice ourselves first. You know, it is not just to preach. Before you preach, you practice it yourself. So let us create that, and also create ICT materials, communication through electronic media, social media. So let us create a wave and the movement of yoga, which will bring a very happy world. Thank you very much for this opportunity, for sharing some of my thoughts and experience in the field, particularly the physiological perspectives, being a physiologist myself. And thank you so much, Dr. Shashi, for this opportunity and accommodating my request to shift my lecture. Because yesterday it was later and we had a sleep day celebration, World Sleep Day celebration yesterday. So there was a big talk in the same time. So I requested Shashi to shift it. And so we had a sleep medicine specialist talking on that. So thank you very much, Dr. Akshay, for chairing this.
Thank you.
Thank you so much. Now,
Thank you. That was Dr. Selvamurthy.
I can answer some questions if there is any comment, suggestion.
That was Dr. Selvamurthy speaking from his own experiential and yoga practice. And you can see that he doesn't look 72. And not only has he spoken from his experience, but also from the experimental evidence showing how mind-body balance can reduce the stress, several psychosomatic disorders. And he showed beautiful imaging benefits to hypertensive patients. And the best part is that his experimental data is very, very rigorous, coming from high compliance, evident from the soldiers who will be very disciplined. And therefore, this particular data is so very different from other reported data by the very fact that it has the quality ingrained due to the subjects involved and the groupings involved. And now here, the way you have taken it to the Amity is a testimony that your own experience now flows into so many, at least the postgraduates and the higher education that MET runs. You have given us an agenda to implement in the schools and corporates. And in fact, as I am joined from LA, coming here for American Psychosomatic Society, we're having yoga being done every day in the conference. So as you said, not only in the New York campus, but even in the Bay Area here. If Dr. Shashi allows, we can have a few questions, or as per the plenary tradition, we can close it now. If there are pressing questions, they can be asked now.
Then first of all, I thank Professor Selva-Murthy for his very nice lecture and also lucid lecture on yoga. I'm very much interested on that one. My simple question here is that, is there possibility to make it compulsory for all the students in our country? Unfortunately, many of these, because I am working as a vice chancellor and then college development being earlier, I found that the many colleges and schools, they don't have even a playground, unfortunately, just like the shops. So, compulsory.
Dr. Rajendra, you are not audible.
Oh.
Yeah, I got your question that when there is a lot of limitations in our educational systems, which is true, but fortunately, yogic practice, you can do it even in the classroom. It doesn't.
That is true.
Yeah, so it is very, very simple, and you need only the living place itself you can do. Bring that culture, and there are many centers where we can, if there is a will, there is a way, we can do it certainly. I need that will. We need that will among everyone to do it.
Point is that though it is a kind of having willpower, it should be compulsory, because our schools or colleges, they are not going to implement unless you make it compulsory. Because I have seen that in Singapore.
Yeah, I agree, Dr. Rajendra. That's why the national education policy today, it is to develop holistic human being, not just the material knowledge. That is why we, in our system, if you see the NAP 2020, we are bringing traditional knowledge. We are bringing back the moral classes, ethics, values to be taught in our educational system, not churning out robots and also machines out of the educational institution. We want the holistic human being to be churned out. So this will come only through that type of education. And this new National Education Policy 2020, which our government has pronounced, if you implement it properly, this will actually churn out those future global citizens. Because 1 in 4 of every citizen across the globe, in the next 20 years, you will see they would have passed through Indian educational system, the portals of our Indian education system. So we have a big responsibility as a nation to churn out those future global citizens.
Yeah, one more question, if you permit me. You said that you are going to practice yoga in the early stages, that is fine. But if a person is going to be there having so much of workload and everything, he may not practice yoga in the early stages. And after 50, he realizes that he wants to practice yoga. By the time his muscles are going to stiffen and his bones are going to, vertebrae are going to fuse, he gets sciatica, and then all kinds of the orthopedic problems. He's going to help if he's going to practice yoga at the time after fusing of all the vertebrae.
Right. So there are common yoga protocol that is across the population, which is one. The second is packages. If you are aged, you have certain limitations. You have certain exercises are contraindicated. Certain exercise need to be rigorously followed. So there are different packages for different conditions. Suppose you have a cervical problem, maybe Sarvangasana, Sirsasana, all these are you should not do. So you have different packages. That is why you need to first, normal healthy people, you have the common yoga protocol. WHO there is an app developed, approved by WHO on for this yoga packages. So hypertensives, these are the sets of asanas. Suppose your age is beyond this 50 years, as you rightly said, that what are the packages which you can adopt? And there are simple breathing exercises which you can do at any age. Bastrika, Ujjayi, and also Anolam Vilom. All this can be practiced at even 60, 70, 80, you can start. So it's a way of life. It is just not practice of a few asanas, pranayam, and meditation is yoga. Yoga has to be a way of living life. So this is what we should encourage. You can start even at 50, 60, there is no problem. But you have certain restrictions, limitation. Your body suppleness would have declined by that period. But then we have other exercises which can be done in yoga, and you can adopt other yama, niyama, pratyahar, dharna, dhyana, samadhi. All this is component of yoga. So you can adopt at any age. Yoga can be started.
Thank you. Thank you.
Thank you, Dr. Rajendra. And now we're coming to a close because of the scarcity of time. Thank you very much once again, Dr. Selvamurthy, for exciting, inspiring, and enthusiastic talk. And the questions made it even more enlightening. And as you rightly said, if the schools take time, even later in the life, we can take the benefit from it. Thanks once again. Thanks for joining us.
Thank you. Thanks to everyone.
Thank you, Dr. Pratima, who has also joined us. She was also the chairperson. Thanks. Would you like to say something, Dr. Pratima, ma'am?
Sir, it's been very enlightening, and my apologies. I did join before time, but the session had already begun, and I'm so glad because we've gathered here to hear you. But much more than that, I think the radiance that you exude is very motivating. And there can be no better example than, seeing that as a practitioner and as a scholar and as a researcher, wearing so many, different roles so effortlessly, you motivated us today. So without much ado, my salutations and thank you very much.
Thank you, Dr. Pratibha.
Thank you.
Thank you, sir. Thank you, sir. And thank you, Akshay. It is mid of the night for you. You're joining us from LA. Thanks for joining us. Thank you.
Thank you. Thank you.
Namaskar.
Thank you, Shachi.
Thank you. Namaskar.
Thank you, everyone. Now I would like to call upon Professor Kusal Das and Professor A.K. Chandra to kindly take over for our next session, that is the Physiological Society of India, PSI Oration. Over to you, sir.
Yeah, thank you very much. Thank you very much, Honorable Director of NIPER and President of Fips and organizing committee members. And just now, we are hearing a distinguished speaker like Dr. W. Selvamurthy's amazing speech on yoga and his practices for healthy life. Now, along with me, actually, the President of the Physiological Society of India, Professor Amar K. Chandra, is here. So sir is actually my teacher also. So he will be here. And General Secretary, Dr. Rajan Haldar of the Physiological Society of India, because these two orations will be followed by PSI Symposium. So one of the speakers has certain issues. So that thing, I think I request to Dr. Rajan Haldar or Professor Amar K. Chandra to address that one and bring that one first. And please tell the sequence of program where invited speakers and oration awardees will be available. Over to Dr. Rajan or Dr. Professor Amar Chandra.
Yes. Yes, myself and Professor Kusal Das are chairing the session of the Physiological Society of India. Before going to that, I thanks to the President of the Federation of Indian Physiological Societies and the organizing team, particularly Dr. Khatra and others, for inviting me as a chairperson in this session. In this context, I like to say that Professor Kusal Das is an eminent physiologist of India. He is holding the chair professor of physiology in BLD University, He is associated with many activities. He is the Vice President of Physiological Society of India, and now he is holding the chair of the South Asian Association of Physiologists. It is a very important and pioneering post. And before going to the discussion, I'd like to say something about the Federation of Indian Physiological Societies. The Indian Federation of Physiological Societies of India has been originated by some pioneer physiologists of the All India Institute of Medical Sciences and the other constituent society. It has been established in about 1990, and it has 4 constituent or member societies. The societies are the Physiological Society of India. Its headquarters is located in Kolkata, and particularly at Calcutta University. As another constituent society is the Association of Physiologists and Pharmacological Society, and its headquarters is in New Delhi, All India Institute of Medical Sciences. And the other 2 important societies are the Society of Animal Physiology and also the Comparative Animal Physiological Society, whose headquarters are located in the different places of the country. And the purpose of the federation, as Professor Dr. Silva Murthy has clearly mentioned, that the purpose of the federation is to unite all the physiological eminent physiologists, young physiologists, students, physiologists, to bring under an umbrella. And for that purpose, Federation of the Indian Physiological Society has been originated. Since then, I am also associated with the Federation of Indian Physiological Societies as Honorary General Secretary. So we are organizing the Fips conference at interval of 2 to 3 years, where we invite many eminent physiologists from the country and also from the abroad. Our function is not only restricted with our society, but to bring the physiologists from the other societies. So it is especially always Physiological Society of India take important part in the functioning of the Federation of Indian Physiological Societies. And it is the session, in the first session, that will be chaired by myself and Professor Kushal Kumar Das, co-chair. And it was our function to organize the Fluorescent lectures of the Physiological Societies of India. In this context, I like to mention that Physiological Society of India has a number of Fluorescents, about 13 Fluorescents, and these Fluorescent lectures are delivered in the annual conferences of the Physiological Society of India, in Indian Science Congress, and sometimes also in the Federation of the Indian Physiological Society.
Sir, sorry to interrupt. Sir, we are actually running late by 15
so,
minutes.
okay. Because regarding the federation, nothing has been mentioned earlier, so I am introducing. So, with these few words, first of all, may I request to one of the speakers, that is Dr. Subhashish Sahu. First lecture will be delivered, as our General Secretary mentioned, that if Devashish Sahu be available, then Devashish Sahu will start his lecture. Otherwise, we can start with Subhashish Sahu. I request.
No, sir, just I like to tell that Professor Nino Ramirez, he is in Washington. It is night 1 p.m. midnight. So actually, Dr. Sahu is having some issues. Let Subhashish speak this invited speech for 20 minutes, and then it will be handed over to Professor Nino Ramirez, and then Dr. Naivedya Chattopadhyay. That will be good for us, sir.
Exactly.
Because,
thank you.
Regarding Dr. Subhashish Sahu, he is an eminent scientist. He is PhD and fellow of the Association of Biomedical Scientists. He is presently the associate professor and head department of physiology, in charge ergonomics and occupational physiology laboratory. He is from the University of Kulani, Nadia, West Bengal. Regarding his professional experience, I like to mention that Faculty in graduate, postgraduate, PhD courses work in physiology with specialization in ergonomics and occupational physiology more than 20 years. Actively involved. Professor Dr. Sahu is actively involved in research and consultancy in the field of ergonomics and occupational physiology since 1991. He has completed more than 20 research projects, including 4 multinational projects on chronobiology, ergonomics, respiratory physiology, and Fuji analysis. A resource person, he acted as a resource person, members in different professional developmental courses and international bodies. He is also associated with the National Institute of Design and also with the Presidency University of West Bengal. He is the consultant and coordinator in different ergonomics project and workshop. He is expert panel member of occupational health, which is an important part of physiology and safety, Indian Chamber of Commerce. His research publication is more than 100. He published many books. He also published his publication in proceedings is about 8. In addition to that, he has published many abstracts. He guided about 12 PhD students and recognition. Awarded national scholarship during 1989 to 1990 from the Government of India in order of merit in graduate examination. Next, obtained Young Scientist Award of the Physiological Society of India in 1996. He is also a fellow of the Indian Association of the Biomedical Sciences. With these few words, I request our young speaker, Dr. Subhashish Sahu, to speak on well-being during lockdown and new normal lifestyle in ergonomics perspective. Dr. Sahu, please.
Thank you, sir. I think the slide is visible.
Yeah, you make it in the full screen and keep the time exactly 20 minutes.
Okay. Thank you, all the organizers and the respected chairpersons, Kusholda and Professor, to allow me to speak earlier in spite of the other are waiting. So I make my speech very short and more non-technical because many things we know, but we don't follow. Like too many information, if we give at the same time, we cannot perceive. So what our observation during this COVID time, different ergonomic perspective, we are working from home and from the student to the corporate, all the different working population. So here, the main thing is that due to COVID-19 pandemic, work from home is a new solution. And obviously, it will be continued for some more days. And if we see the statistics, from 27% work from home, they practice in 2019, but it is increased up to 51%, although almost we are coming back to the normalcy, but the work from home will be continued. So here, the key challenges when we are working from home or lockdown is mainly the work schedule, because the fixed work schedule will be hampered and people have to work beyond the schedule. And posture, that is another important thing. We have to glue to the chair, like in this conference, it is in the online mode. So those are the speaker or the chairperson, they have to be sit for a long time in the same posture, and they have the screen exposure for the long time. So that is another challenge. Changes in the livelihood, different working population is also there, and obviously some have shifted from their native working job or there's a specialized working job to the other, and obviously we hampered our sleep-wake cycle and the biological clock. So this new normal, we have that means we have to maintain the social distance. So we have to avoid the crowded workplace, or as long as means as far as possible work from home or the hybrid mode or online mode, some lectures and conferences and the classes also. So we have certain publications, those are interested, we can discuss. But main except of this publication, I try to summarize very few because time is short. I'm not going to all the mainly the three issues we have found that physiological, psychological, and behavioral are the main three domain of issues concerned when you are working from the home or in the lockdown. So ultimately what happened, this COVID-19 pandemic and lockdown or work from home, there will be depressive symptomology, there will be depression, there is increased mental stress. You will see reported different report. We also found in different group of people from the students, corporate worker, in there is depressive mental health problem. There will be health comorbidities. There is increase in the health comorbidities, and strikingly there is increase in the somatic pain due to bad posture, other factor, and there will be exposure to the screen time for long time, and that will lead to sleep disturbance, sleep quality hampered, and ultimately there will be a later bedtime and wake up time. So ultimately there will be disruption of the all the parameters in the circadian rhythm, which will in long run will affect the health or physiology of our or homeostasis of our body. So the main consequences, there will be inadequate sleep, irregular sleep pattern, there will be insomnia, irregular food intake pattern. When we are in the home, so we generally have keep munching, so there will be food pattern will be change, and ultimately there will be less physical exercise or physical activity, though there will be increase in the obesity. Obviously, previously Professor Selvamurthy has rightly pointed out, yoga will be a good practice in this situation. And obviously, there will be indigestion and ocular problem, visual fatigue, double vision due to inadequate lighting, long time screen exposure, and musculoskeletal disorder is the main sequence. And if we see the different sleepiness scale in different sphere of different profession, from urban, corporate, student, healthcare, police personnel, and rural people, will see that there will be problem in from disturbance in sleep in all sphere of all type of people when they are in the lockdown phase or work from home phase. Although police personnel and healthcare worker, they have the excessive stress, so that stress leads to there will be problem in the health, but means sleep. But the other people, those are working from the home, there will be problem with this health issues. And if here one example of this screen time exposure, like there will be marked increase in the cell phone, desktop, and obviously those have the entertainment channels, means television exposure is also increased. And in the students also we'll see, because they previous means few days back also they have all the education in the in means of online, so they have the increase in the cell phone and television for a long time. They have to expose to this screen time, and that will be hampered their circadian rhythm. And here we can see the prevalence of the pain, and here we can see as we have to glue to our chair, and most of the chair or the workstation which is available in the home is not proper or ergonomically designed, because in the office they have the similar setup, but in home, when the three generation of people are working together to get three types of furniture, proper furniture, and three types of gadget, is very difficult for the people to get. So they have to compromise the sitting and working posture and space constant. So a lot of issues that will lead to awkward posture, and we have to work for the long time. And we'll see this improper lighting, wrong distance between the eye and monitor, fluorescent light, and prolonged period of work. So ultimately that lead to irregular or poor eating habit, irregular sleep, lack of sleep, some posture maintained for the prolonged period of time, and less exercise. And here we can see this psychological consequences, inability to concentrate, boredom, tension, fatigue, anxiety, and depression, that markedly increased in all. And here we can see due to some other thing, maybe due to anxiety or not proper visiting to the doctor, what are the other comorbidities like blood pressure, sugar, gastrointestinal problem also increased after lockdown compared to the before lockdown. So what we can do when we are working from maintain, we have to previous job schedule, we have to, that is one of the important. And we need adequate amount of sleep, and we have to maintain the regular sleep-wake cycle and take at least micro break and some stretching exercise. And there is one rule is there, 20-20. When we are working with the computer screen, every 20 minutes we have to look at 20-meter distance for 20 seconds. So that is one of way to reduce the screen exposure, and we have to maintain the food intake pattern properly. And here we have suggested some micro breaks, which will be helpful. We have to stretch sometime, and is the workstation from work from home less ergonomically sound. Your workstation is more, and here some suggestion is given, like we should not dangling our leg. So some leg support is given, some lumbar support is given, and if we can have some detachable keyboard, that will be much better, so that some wrist support and elbow support will be helpful. And there is one rule is that 90-90-90 rules. We have to keep our knee and elbow and lumbar in the 90-degree position. So that will be much better from the natural posture. And that's the main findings what we want to share. And if there is question, I am happy to answer. Thank you.
Thank you. Thank you very much, Dr. Shahu. Thank you very much for excellent presentation in a very brief and very nicely you have presented in the stipulated time. So I think that it is my pleasure to ask Professor Amarchandra. Sir, you just ask anything you want to say, comment on him, and then we should shift to the oration immediately because the speaker is in actually at midnight.
Thank
Sir,
you.
please.
Thank you, Dr. Subhashish Sahu, for your nice presentation. During the period, he published certain papers on COVID-19 people. And I have gone through the papers. These are very excellent papers. He in his study, he mentioned that there are several changes taken place during the COVID period. For example, their physiological, psychological, and behavioral aspects has been changed. In addition to that, their socioeconomic status has also changed. He described that during the time, the major manifestations are depression, sleep, and other diseases, mainly pain, and so on. And he also recommended certain measures, including yoga, to overcome all this. So I have nothing to say. The time is short. I thank Dr. Subhashish Sahu for his nice presentation within a very short period. So we can go to the oration lectures in the next phase. Thank you, Dr. Subhashish Sahu.
Thank you, sir. Thank you, sir.
Yes, I think that we should invite now Professor John Marino Ramirez. Professor Ramirez? Professor Ramirez?
Hello.
Hello.
Professor Das, it's Nino Ramirez here.
Yeah, nice to see you. Very early morning. It's a good morning to you now. Yeah.
It is a very good morning. Thank you so much.
Yes.
Thank you.
So we invite you, and I request Professor Amarchandra sir to tell his oration and immediately. Professor Nino, it is a midnight, so there is no question answer session for your oration. So you have to deliver the talk and try to keep it in 25 minutes so that we can 5 minutes for your introduction by Professor Amarchandra. Dr. Rajan Haldari, our General Secretary, is also here.
We are sorry for requesting Professor John Marino for inviting him, particularly in this time. In this regard, I like to mention, I have already mentioned that Physiological Society of India has a number of orations, and the most prestigious oration is Professor Subodh Chandra Mahalanabi's memorial oration. Who was Subodh Chandra Mahalanabi? Professor Subodh Chandra Mahalanabi initiated the studies of physiology as a basic science under the Faculty of Science in the University of Calcutta in the year 1901. At present, physiology is taught at undergraduate and postgraduate levels, not only in Calcutta University, but also in many other universities all over West Bengal and also in Tripura. And many physiologists who have qualified themselves, they are in very good position to perpetuate the memory of late Professor Mahalanabi. The Physiological Society of India instituted the oration. The first oration lecture was delivered by his direct student, Professor P.B. Sarkar, in 1971. It is about our oration, and on the other aspect, we have in this year, the Physiological Society of India has nominated John Marino Ramesh, PhD, for this prestigious oration. He was born in Lima, Peru, and moved to Germany at the age of 6 years. He studied at the University of Rogersburg, Germany, did his postdoctoral training at the University of Alberta, Canada, before obtaining his first faculty position at the University of Göttingen, Germany. In 1996, he moved to the United States, where he assured a faculty position and eventually became the chair of organizational biology and anatomy at the University of Chicago since 2007. He is a professor of neurological surgery and adjunct professor in the Department of Pediatrics, Physiology, and Biophysics and Physiology at the University of Washington School of Medicine. He is the director of the Center for Integrative Brain Research at the Seattle Children's Research Institute since 2008. In this role, he directs brain research that covers a whole area from psychiatric disorder, brain malformation to epilepsy. He is the editor-in-chief for the Journal of Neurophysiology. Dr. Ramesh now runs a laboratory that studies neural mechanism involved in the generation of respiratory rhythm, neocortical activity, and epilepsy. His research bridges animal and human research and has led to insights into the neural mechanism underlying erratic breathing in Rett syndrome, familial syndrome, congenital hyperventilation syndrome, pediatric epilepsy, sleep apnea, and so on. His work has been continuously funded by multiple national Institute of Health (NIH) grants since 1996. And in this occasion, I like to say that for this prestigious oration, a citation certificate from the Physiological Society of India and a medal is also provided. But now we are in offline mode, so it is difficult. This is the certificate, and we have also a memento. So we are also honored to get Professor John Marino in this platform to listen his valuable speech. Now I request Professor John Marino Ramesh for delivering his lecture. This is the certificate. These are the medals, and it is the most. I also mentioned that this is the most prestigious oration of the Physiological Society of India. With these few words, I like to request Professor John Marino Ramesh to deliver his lecture.
Professor Chandra, I wanted to thank you so much for this incredibly kind introduction, and I can't thank the Indian Society for Physiology enough for this incredible honor. And I want to thank also Professor Kusal Das for nominating me. And I cannot say, I mean, this is an incredible honor. And I must say, it is like midnight here or 1 o'clock, but I am excited as can be. So it is a wonderful situation. Now I want to share the screen, and I hope everything works. PowerPoint, and this, and use slideshow. Okay, can everybody see the slides?
Yes, please.
If so, then I will start.
Yes, go ahead.
Wonderful. Okay. I want to talk today about brain, breathing, and the heart, and in particular, the importance of rhythmicity. And but before I come to the talk, I want to honor Professor Mahalanobis, who has been the founding president of the Physiological Society of India. He was an elected member of the Royal Society of Edinburgh, and professor of the Department of Physiology in Kolkata. And it has been said that he has a great influence on the discipline of physiology, which based on his enthusiasm flourished tremendously in numerous schools and colleges all over India. And you can get a glimpse into his thinking and into his genius when you read his papers on a salmon in fresh water. And this is a very fascinating physiological problem because these fish, they live all their life in the ocean and they come to spawn into the freshwater. And that at the moment they enter the freshwater, it triggers an amazing physiological reconfiguration. And it basically initiates a very quick aging of these animals. And all their muscles and fat will be changed, and in order for a rapid growth of genitalia that he characterized. Now, this model that he started continues to be an important model to this day. This is a beautiful study by Maldonado and Norris, where they show that in the brain, in the cerebellum, you see amyloid precursor proteins that are building up in this very short time of aging. And this is a very characteristic finding for Alzheimer. And basically this model, this animal model, can serve as an incredible good model to study the aging process in a very short time. And what this shows is that Professor Mahalanobis understood the importance of physiology as a discipline to understand fundamental mechanisms of life and nature, which then gives us insights into human health and disease. And along these lines, I want to also address a fundamental problem and start with a fundamental problem. And this is the role of the brain in generating time. And this is something that we're really not totally aware, but we live with this all the time. So everybody is familiar with scenes like this. You hear music, you see someone dancing, and you see cars moving along, you smell a rose. And these natural scenes are very natural for us, and we think it's totally clear to understand what's happening. But when we think about the brain, it's actually a miracle because colors, movements, sounds, and the smells, they're all processed at very different times and also in very different regions of the brain. So the visual part will be dissociated here in this area, and the sound of the car will be processed here. Then the interpretation of an attacking elephant will be processed further, and the smell of the rose will be processed again in a very different time. So basically what the brain has to do is the brain has to disassemble the real world into many different components that are then distributed in many different regions of the brain and with different times. And once this happens, the brain has to create its own world inside and reassemble all these components to generate a coherent impression and thought. So now the brain has to know that this red color here belongs to this person and it's moving with the same rhythm that this person is playing here. And so basically this is a creation of time that is not existing in the brain because basically everything comes in at different times. So a big role is in the brain to generate simultaneity. So the brain has to know, for example, in this situation, when you drive at night, that this red moving object belongs to this part, and that this moving object belongs here and goes in the opposite direction. And so you have to interpret the moving parts, even though they come in different times, as a simultaneous event. And only when you can do this, then you can navigate on a street like this, where you know, okay, this object is moving with this speed, this object is moving with this speed, and this person is standing. So you can navigate around this because the brain has to generate the time associated with this. And in order to do this, rhythmicity is absolutely critical. And in fact, while you're listening to me, your brain will generate like a 30 hertz rhythm. But when you go into the brain, what you see is that there are many, many neurons active, and you can hear them everywhere in your brain. No matter where you look, your brain will be active. And these units are really not synchronized, but they're still generating rhythmicity. you can see in these single units, this bursting activity, even though it's not synchronized, but it's generated within these nerve cells. And what the brain has to do is, in order to make a sense out of an object, it has to synchronize temporarily different regions of the brain. For example, this is work done by Mizumori and Baker, where they looked at a mouse that had to make a decision. And what they find is that during this decision-making process, the hippocampus, the prefrontal cortex, and the lateral habenula now suddenly synchronize to form a coherent process that makes a decision that brings together the memory of this labyrinth, the lateral habenula, which is a motivation, and the prefrontal cortex that plans this whole movement. And once the mouse has done this movement, these units becomes desynchronized again. So basically, one of the fundamental problems of the brain is to synchronize and desynchronize all these rhythmic activities in order to generate neuronal functions. And when you look in the brain, you can see that the brain generates rhythmic activity everywhere. You have the neocortex, you have different kinds of rhythms, slow rhythm, fast rhythm, theta rhythm, alpha rhythms. You have the rhythms in the hippocampus, the amygdala, striatum, etc. And all these rhythms are working together, are interacting. For example, this is an example where during feared learning, the hippocampus and the amygdala are rhythmically active together. Now, even though these rhythms are interacting very closely together, the brain really consists of numerous microcircuits. So every part of the brain has a microcircuit that is capable of generating intrinsically rhythmic activity. So the visual cortex, where your visual information comes in, can generate intrinsic rhythmic activity, as does the motor cortex, the somatosensory cortex, etc. And so what you can do is you can take a piece of cortex out of the brain and put it in a dish, and this piece of cortex will start to generate rhythmic activity. And in this case, this rhythmic activity is actually representing a sleep rhythm. Now, in the normal brain, of course, this cortex will not generate the rhythm alone. It will coordinate this rhythm with other areas. For example, the cortex will be rhythmically active during sleep with the hippocampus. And during this time, this is when the memory consolidation happens, where your memory that you formed during the day is consolidated in the different parts of the brain and then stored for the rest of your life. So this process of memory consolidation during sleep is very, very important. And understanding how the brain generates these rhythms and coordinates them is clinically extremely important. And this is, for example, in this case, a model of Alzheimer's disease. And what you can see here is that now in this Alzheimer model, the neocortex is not rhythmically active faced with the hippocampus. So the hippocampus cannot consolidate a memory, and this mouse will not be able to form a memory. So it's not only the anatomy that I showed you in the salmon example, but also the physiology that plays a big role in memory consolidation. Now, the important conclusion is that most neural networks in your brain are intrinsically able to generate rhythmic activity. You find rhythmic activity everywhere in the brain, but in order to generate a brain function, you have to integrate between all these different networks. And this becomes, for example, clinically relevant in the case of a coma. So let's say you have an injury that disturbs all these interactions, then you reveal this intrinsic activity of the brain, but now this brain activity is unresponsive to any sensory inputs, and basically this person is unconscious and cannot generate a brain function. So for the neuroscientist, an important task is now to understand these critical circuit interactions that are important for the functional integration. And what I want to do in my talk today is really just focus on one of many interactions that are critical for maintaining the brain's metabolic state. And I want to focus on breathing. Breathing is a very complex, perhaps the most complex behavior, because it's highly integrated with many, many different functions. So when I talk to you, then the vocalization is a breathing behavior that is highly coordinated with my cognitive abilities to structure a sentence, etc. When I do exercise, breathing has to be coordinated with the exercise. Breathing can be a form of emotion. So this is a sigh of relief. And in fact, when someone cries, so laughing are all kind of breathing behaviors that associate with an emotion. Then breathing has to be, of course, coordinated with air defense mechanisms like coughing, and then also swallowing. And then, of course, everybody is now aware during COVID, breathing became a major problem in this pandemic. Now, especially in India, and we just heard a beautiful talk about yoga, it has been known for many, many centuries that breathing is also important to change your cognitive state. And indeed, when you go into the prefrontal cortex, which is important for higher brain function, then you can see the prefrontal cortex is rhythmically active in phase with inspiration. So when you say I'm inspired, then really your prefrontal cortex is inspired by the rhythmic activity. Breathing is also an important arousal mechanism. So 95% of the time when you wake up at night, then you wake up with a sigh, because this large inspiratory effort will activate your noradrenergic neurons that then activate your brain. Now, all this starts in a small area in the brainstem, which is called the pre-Bretzinger complex. It's a small area that was discovered in 1991. And this area is essential for breathing. So if you, in an animal model, knock this area out with a toxin or the viral vector, then the animal stops, and showing that this is an essential area. However, the Bretzinger complex generates only one phase of breathing, which is inspiration. And this is shown here. The pre-Bretzinger complex activates the diaphragm, which then leads to the inhalation of air. Now, the inspiration is followed by another phase, which is called post-inspiration. This is the time when I talk. So I take a breath and then I talk during this post-inspiratory phase. And this post-inspiratory phase is really driven by the mechanical recall forces of the lung that really exhale air very quickly. But I want to avoid this very quick exhalation. So I put a brake on it by activating laryngeal muscles and the diaphragm matrices until I run out of air. Then I do an inspiration, and then I start again with a post-inspiration. Now, if you're stressed, like jogging, for example, then you get into something called an active expiration, where you activate your intercostal muscle. You notice like this heavy breathing when you're jogging, but under normal condition, you breathe between inspiration and post-inspiration. Now, these two breathing phases are generated by different parts of the brain. So the pre-Bretzinger complex, marked by the so-called DBX1 nerve cells, is generating inspiration, whereas the post-inspiration is generated by a neural network that we discovered in 2016. These are glutamatergic cholinergic neurons that are active and generating this post-inspiratory phase. And you can isolate these two areas of the brain by making a cut through the medulla, and then you can isolate these two areas, and they're still continuing to generate the breathing rhythm, the inspiration and the post-inspiration. And since we know exactly which neurons these are, we can study their interaction. So if you stimulate the inspiratory neuron, you inhibit the neurons in the pico area. And if you stimulate the pico neurons, you activate a post-inspiration and you inhibit breathing, the inspiration. And you can do this in a slice, but you can do this also in a whole animal. So basically, every breath is composed of these different centers that generate your different phases of breathing. However, you not only have to closely coordinate these different centers for breathing, but you have to also coordinate with the heart in order to provide enough oxygen that you need to maintain this persistent activity in the brain. And when you take a breath, what happens is that your heart rate goes up, and when you exhale, your heart rate goes down. And this is a arrhythmia that is shown as an example of a healthy cardiorespiratory coupling. It's called the respiratory sinus arrhythmia. And there are many themes to this coupling. And one of them is, for example, the diving response or the breath holding. So when you take a breath hold, then what you can see is that your heart rate drops and stays down as long as you hold the breath. Now, the breath hold is perfectionized in seals. So these are animals that can dive for more than an hour, and they can dive 1,000 meters deep. And during their dive, they go down with their heart rate to almost zero. So they can block their heart rate throughout this dive. And this animal model can show you something more. And it shows you that during this breath hold, you not only coordinate the breathing and the heart, but you coordinate the entire body. And again, this has been known by the yoga for a long time, that by breathing, you can control your mind, but you can also control your body. Indeed, when you look at this diving response of these seals, you can see that there's hypermetabolism happening in the lungs, in the diaphragm, the ventricle, the kidney, everywhere, except of the brain. And so because you create a hypermetabolism in all your organs, you can do now a vasoconstriction and now concentrate your blood only to perfuse the brain in order to be alert, for example, during this diving. Unfortunately, this cardiorespiratory coupling is disturbed in many disorders like dysautonomia. And one of these disorders is Rett syndrome. So this is a child that suffers from Rett syndrome. And when you look at her breathing, you can see she has here a cardiorespiratory coupling. During each breath, the heart rate goes up, the heart rate goes up. And then she takes this breath hold. It starts with a normal diving response. The heart rate goes down. But now what you can see is you get a heart rate increase, a tachycardia, which extends even though breathing resumes again. So this is an uncoupling of the breathing and the heart, an uncoupling that is not physiologically advantageous. And in fact, what happens now is during this time, the child will suffer from an hypoxic event. Now, the child will not generate only one of those breath holds, but it will generate many of those breath holds in a row while the child is awake. And we call the situation intermittent hypoxia. And intermittent hypoxia is a characteristic feature of many disorders of dysautonomia. You see this, for example, in obstructive sleep apnea, in familial dysautonomia, in epilepsy, in apnea of prematurity. All of these behavior or these diseases are associated with intermittent hypoxia. And these diseases are also associated with an increased heart rate and a decreased heart rate variability. You see this here in Rett syndrome. The same thing happens in familial dysautonomia and in sleep apnea. All of these disorders are also associated with sudden death. So you have sudden death in Rett syndrome, sudden death in familial dysautonomia, sudden death in epilepsy, and also you have sudden death in obstructive sleep apneas. So the question is, what are the mechanisms that underlie this cardiorespiratory coupling and the uncoupling? And there we come back again to this breathing center, to the Pribötzinger complex. And the Pribötzinger complex sits here in the medulla right beside the nucleus ambiguus, which gives rise to the cardiovagal neurons. So this is the source of the parasympathetic nerve. And basically what you see is that this Pribötzinger complex inhibits these cardiovagal neurons. And since these cardiovagal neurons are inhibiting the heart gets disinhibited and the heart rate goes up. And this interaction is happening all throughout your life and regulates basically the coupling between the heart and the breathing. And to show that this area is really essential for this, what we can do is genetically engineer these cardiovagal neurons to make them light activatable. So we basically put a genetic light switch in there. And then if you put laser light into the whole animal, what happens is when you stimulate these cardiovagal neurons, the heart rate drops dramatically, showing that this area indeed has a huge influence on the heart. So what we can now say is that each time you inhale, your cardiovagal neurons, the parasympathetic system is inhibited and your heart rate increases. And now that we identify these neurons, you can ask the question, what happens if you apply chronic intermittent hypoxia to the system? And what happens is you get an upregulation of HIF-1 alpha. This is the pro-oxidant system. And at the same time, however, you also create oxidative stress because these neurons are releasing hydrogen peroxide. And this hydrogen peroxide leads to a lipid peroxidation, which means that after intermittent hypoxia, you have both an oxidative stress, but also an hypoxic stress. And now you can ask the question, what is hydrogen peroxide doing to this system? And when you record from these cardiovagal neurons and you apply hydrogen peroxide, you see that these neurons now become hyperpolarized, they become silent. And as a result of this, the heart rate goes up. And because these neurons are silent, you're also losing this heart rate variability, which is exactly what you see in these disorders, an increased heart rate and a decreased heart rate variability. And interestingly, this intermittent hypoxia affects also the breathing network itself. So when you record from these neurons in the Pribötzinger complex, they become less excitable to compare to the control. And when they become less excitable, what happens is they don't synchronize very well. Normally, during each breath, these neurons have to synchronize to generate your inspiratory activity. But now they're not so excited anymore, and you get failure to synchronize. And so the output is very variable, and the amplitude fluctuates quite dramatically. And that becomes a huge problem because the Pribötzinger complex also activates your tongue muscle, the hypoglossus. The hypoglossus, again, sits very close to the Pribötzinger complex, and these neurons project here and activate the tongue each time you take a breath. And this prevents that the tongue is blocking your upper airway. However, if you have intermittent hypoxia, what happens now is there is no complete transmission to the hypoglossus. The tongue will be blocking your upper airway, but since the respiratory rhythm continues, you create a negative pressure, which then leads to a pharyngeal collapse and to an obstruction. And this is exactly what happened in this child here. You can see the respiratory activity continues, but the hypoglossus is now blocking the airflow. And so you're creating this intermittent hypoxia due to the obstructive sleep apnea. Now, interesting, this effect is all driven by reactive oxygen species. So if you apply reactive oxygen species scavenger, this irregularities and also the transmission to the hypoglossus is restored. So what I showed you now is that the central networks that control breathing, that control the airways, and that control the heart are all sitting together, and they're all dissociated by intermittent hypoxia via reactive oxygen species. And this raises now the very important question, why oxidative stress if you have an intermittent hypoxia? And here I want to tell you something about the balance between HIF1 alpha and HIF2. And in 2019, Greg Semenza received the Nobel Prize for his discovery of HIF1 alpha, which is the pro-oxidant system. But HIF1 alpha is the pro-oxidant system that is living in balance with HIF2 alpha. And HIF2 alpha, this is work done by Nanduri Prabhakar at the University of Chicago. And he also received the same award a few years ago for his discovery of the balance of this HIF2 alpha with HIF1 alpha. Because if you're exposed to chronic hypoxia in high altitude, these systems are in balance and the reactive oxygen species is in balance and you don't get oxidative stress. However, in intermittent hypoxia, you get an upregulation of HIF1 alpha, but you get an upregulation of reactive oxygen species, you get damage and oxidative stress, which then leads to what I just showed you, to the dissociation. Now, what I told you is basically a general principle, because not only intermittent hypoxia will produce reactive oxygen species, but also heavy metals like lead poisoning can lead to ROS. Infections, pollutants all lead to ROS and all lead to changes in your cardiorespiratory coupling and also to sudden death. And I want to give you some example for the biotic stress. And this is from a person that posted this in the internet. That person got COVID-19, and you can see that within days, the cardiorespiratory coupling fails, and there is a decrease in the heart rate variability. And this is an example from my colleague, Dr. Wainwright, who is treating here a critically ill sepsis patient. You can see this dramatic heart rate variability. And then at 6 p.m., this child shows a drop in heart rate variability, a sudden drop. And then basically at 6 a.m., 12 hours later, the patient suffers from cardiac arrest. and then 24 hours later, the child dies. And so basically 12 hours before the cardiac arrest, you get this warning where these networks are dissociated. So what I showed you in my talk is that basically every thought you take is assembled and they're dynamically assembled from different microcircuits. So the hippocampus, the substantia nigra, etc., all these areas are rhythmically active, but they're synchronizing in order to bring it together. The same is true for a breath. Every breath is assembled from different microcircuits. So you act an inspiratory circuit, you have an expiratory circuit, and they form your breath dynamically. And then each of your breath is then also coordinated with the cardiovascular system. I showed you the example on the parasympathetic system, but there's of course also coordinating with the sympathetic system. And during hypoxic stress, you get an imbalance between the parasympathetic and the sympathetic system. And it's coordinated with the brain and in fact, the whole body, as I showed you also in the SEAL experiments. And of course, the people that do yoga know that it's not only the muscle system that is coordinated, but also your digestion and the human immune system, etc. And I want to refer to this wonderful talk that we heard just before by Professor Selva Mutri that I think gave you many examples of this coordination. Then this rhythmic orchestration is now differentially altered in disease by chronic intermittent hypoxia. And all these changes and then are driven by reactive oxygen species, which is an example for many disorders of dysautonomia that can be caused by heavy metals, biotic stress, air pollutants, and intermittent hypoxia. Now I want to thank all the listeners for this talk. I want to thank my lab, and I want to thank the Indian Society for this incredible honor to receive this oration. I also want to thank my colleague Nanduri Prabhakar and his wife Jay Nanduri, where here we celebrate a grant together with Greg Semanza after his Nobel Prize win. And I'm very grateful. Thank you so much, everybody. And I will stop sharing now.
Thank you. Thank you, Professor John Merino, for your excellent lecture. I will hand over the microphone to Professor Kushal Das, who will speak about your observation. But one thing is that after the oration lecture, there is no questioning session. But I like to say that the respect that you have shown to Professor S.C. Mahalanobis is a wonderful one. You showed his excellent studies. Even you quoted the references of his work on salmon fish and so on. So now I request Dr. Kushal Das to say something about this excellent lecture that has been delivered by Professor John Merino. We are proud that we have you in this occasion. Professor Kushal Das.
Yeah.
Thank you.
Nino, it is amazing always whenever I meet you virtually or practically, physically, anywhere in the world. And you always thrilled me in different way. And it's a thank to you that at midnight or late early morning, you are actually with us. Anyway, hope that it's a weekend, so you will not feel this much of distress. And today I just like to say nothing to say about your works, and everybody listened. Yes, a real person. But the oration which you have actually received, it is received by John Eccles, Nobel laureate. Also, same oration has been received by Professor, Professor David Whiteries and many other pups, including Shushan Lehman, whom you and me, both of us were very close to her. So, and Nanduri Prabhakar, by whose reference you have mentioned. So many stalwarts, including Dr. Shashi Bala Singh, who is here in this as a great scientist, a legendary woman scientist, and a person of his own stature, Professor Dr. Shashi Bala Singh, as a director, NIPAD and Fips Congress. She is also, Madam is also here. So I think that we always try to give it to the deserving people, and you are one of the deserving, most deserving, and society is honored, as our honorable president has mentioned. I just like to say that introduce you with our honorary general secretary, Dr. Rajan Haldar, who actually continuously communicate with you regarding all. So there is no question answered, so it can be terminated here and you will be going to bed also. But I just like to introduce Dr. Rajan Nanda. Dr. Rajan, one word from your end. You are General Secretary of the PSI.
Thank you, sir. Am I audible?
Yes, yes.
Yeah. Thank you, sir, for this nice introduction. We are really, it is our real honor that Professor Gian Marino has delivered a lecture in a very lucid way, excellent lecture I ever heard. So I am very much thankful to all the participants, all of you, and the Madam Professor Sheen. She's a really very nice person. So with this very few words, because it is a very short of time, so I request to continue with the next speaker. So thank you all.
Yeah, Professor.
Thank you, Dr. Marino.
Nino, good night.
Thank you all. Thank you all. It's such an honor, and I think physiology in India is alive, and you guys knew so much more before the Western people knew about all the interaction between breathing. So you cannot imagine how big of an honor this is. So thank you so much.
Thank you. God bless you.
Thank you, sir. Thank you very much. Thank you.
Thank you very much, Nino. You can go to bed now. Bye. And convey my regard to Erika. And hello, I request President Dr. Professor Amar Chandra sir, you take over and invite the next speaker.
I hope it is the oration session. So the Raghottam Rao oration that will be delivered by Dr. Noibidya Chattopadhyay. Regarding Raghottam Rao oration, it is to mention that Raghottam Rao was an eminent professor of physiology in the Mysore Medical College, Indian Mysore Medical College. He is so much popular that his students gathered the fund and provided the Physiological Society of India to introduce a oration in the name of Dr. Raghottam Rao. He is an excellent teacher. He is very much reputed in South India, and for this year, for this oration, Professor Raghottam Rao oration, the nominee is Dr. Noibidya Chattopadhyay. I like to say a few words about Dr. Noibidya Chattopadhyay. Dr. Noibidya Chattopadhyay did his undergraduate and postgraduate degree, BSc, MSc degree from the University of Calcutta. And after that, he has done his PhD, particularly on endocrinology from the Sanjay Gandhi Postgraduate Institute of Medical Sciences, Lucknow. It is a reputed institute, and Dr. Chattopadhyay has utilized the institute properly for extensive work on endocrinology. He has taken postdoctoral studies in Harvard Medical School. After that, for his continuous interest in research, he has been associated as assistant professor of medicine at the Harvard Medical School. It is a reputed institute. Everybody, all of us are well aware about that. Now, he is the head of endocrinology and deputy director, CSIR Central Drug Research Institute. It is another reputed institute of our country. He is the chief scientist, CSIR Central Drug Research Institute, and professor of biological sciences, Academy of Scientific and Innovative Research. He is also the director of the Center of Excellence in Research of Anabolic Skeletal Targets in Health and Illness. His research interest on bone biology and metabolic bone diseases. He is the editorial advisor or board member of the American Journal of Physiology, particularly in the endocrinology and metabolic section of the American Journal of Physiology, Cell Physiology. In his credit, he has published 226 articles in peer-reviewed journal. His H index is an excellent one. It is rare, particularly in the case of the Indians. It is 65, 8 patents, and out of 3 technologies has been developed, or the industry has been developed by Dr. Noibidya Chattopadhyay. One technology commercialized is also in his credit. With this few words, I request If Dr. Kushal Das like to say something, he can say in this occasion. With these few words, I request Dr. Noibudya Chattopadhyay to give his interesting lecture. We are waiting for this.
Yeah, thank you very much, sir. Dr. Chattopadhyay is definitely a great scientist, no doubt about that. And it is a deserving person who got this award, no doubt about that. PSI feels itself honored. And now I request Dr. Chattopadhyay to please go ahead with your presentation. We are more eager to hear you, hear your science. Please go ahead.
Thank you very much. First of all, is my slide visible? Can you see my slides?
Please upload.
I have uploaded the slide.
It has not come.
It has not come yet.
No.
I have
shared. Just share it. Just share this.
No, actually, I thought that it is uploaded.
No, when beginning I saw it. Beginning your slide was there before actually Dr. Shahu speak. Now you take it out and again re-enter. Rajan, can you guide Dr. Rajan Haldar, our General Secretary, Honorary General Secretary?
Yes, sir.
Rajan, you can guide.
Actually, his slide was shown here, but as I shared the original presentation, the certificate submittal, that's why I think it was overruled, and
okay,
I think
let me try
he has to share it again.
Hi, just come. Yes, fantastic.
Okay, okay, great.
Go ahead.
Great. Now it is in the projection mode. Now, thank you very much, Professor Chandro, for giving this generous and kind introduction.
Yeah, please go with the full screen. Go with the full screen. Presentation.
I have made it a full screen.
But it is not coming. It is not a full screen.
Okay, let me try again. Is it coming full screen now? No, not yet?
No. You have any problem?
Well, this is the full screen.
No, but it is not coming here. I think Professor Chandra, sir, you and Dr. Rajan, are you seeing it?
No, we are just seeing the front page.
Yeah, that is the PowerPoint slide.
But are you seeing the full screen?
No, not full screen.
Is it the full
No. It is
on the left that should say use slideshow. In the left of your screen, is there something that says use slideshow, and then it would go full screen?
Yeah, I'm going there as a slideshow.
And in the meantime, I like to mention that Dr. Noibudya Chattopadhyay will be awarded with a citation. In addition to that, a memento will be provided to Dr. Noibudya Chattopadhyay for this oration. We have missed to say this. And after the session, there is no question answering part. So, Dr. Chattopadhyay, please deliver your lecture.
Oh, well.
Have you sent this slide to General Secretary?
Yes, I did.
So may I
try it one more time?
Okay.
No, it has not come.
Is it a full screen now?
No.
Okay. Please
Dr. Rajan, Dr. Rajan?
Side.
Yes, sir. Sir, I'm trying.
Yeah.
Yes, now it has come.
Okay. So, good afternoon. Without wasting any more time, let me come to the topic. I will talk about adiponectin signaling regulates skeletal physiology. If I have to summarize my work in one sentence, I will say just this, that adiponectin is a skinny hormone. It is a pivotal hormone in energy metabolism. And why it is skinny hormone is because it in energy metabolism, it is pro-catabolic and anti-anabolic. But what we found here is that adiponectin is, when it comes to bone, is pro-anabolic and anti-catabolic. But for the reasons of time constraint, I will talk solely on pro-anabolic effect of adiponectin in bone. Next slide. Which would be about standard mandatory conflict of interest. Next slide, please. The next slide is not coming.
No, no, it is not coming. Yeah, it has come.
It has come, but there is a long pause between the two slides. Okay. So this is the. It has. So this conflict of interest mandatory. It has no bearing on the study I'm going to present. Next slide, please. So these would be the four major things you will know from this talk. First of all, you would know what is bone remodeling and current anti-osteoporosis therapies. What is adiponectin? What are the adiponectin signalings? Why are they relevant to bones? And our search for small molecule adiponectin receptor agonist. Next slide, please. So a bone remodeling is a constant process happening at least to 1 million sites in adult weight-bearing skeleton. It has these four major stages, although sometimes people divide activation and resorption, so it becomes 5. But generally speaking, there are 4 major stages. So from a quiescent bone surface, which suppose has undergone some micro damage, suffered some micro damage, that will then be remodeled. And the first step in the remodeling is the activation of osteoclast. These are the giant multinucleated osteoclasts that will sit on the bone surface which is damaged and would resorb the bone, the damaged bone. And next, just keep clicking. Please keep clicking. So then after activation, there would be resorption followed by the next stage, which is reversal. Yeah, please stop here. There would be reversal. And in the reversal stage, which is not much known about the reversal stage, but what happens is that the resorption pit is populated by pre-osteoblast or osteoprogenitor cells. Then those cells then grow and differentiate, and then they start to lay down osteoid, which is the unmineralized matrix. And then in the final stage is the bone formation and mineralization stage, where the mineralized bone is formed. Now what you see is that resorption stage takes 2 to 3 weeks, but the formation takes 3 to 4 months. And moreover, this 3 to 4 months is the lower side, I am saying, when there is the completion of mineralization of the osteoid, which is the unmineralized bone, may take almost a year for human. So the anti-osteoporosis therapies applied at the stage of activation resorption are called anti-resorptives. And one more click, please, and you will see that the anabolics act at the stage of bone formation. Next slide, please. Yeah, next slide. So these are the broad, no, previous slide, please. These are the 4 broad anti-osteoporosis therapies. Estrogens, or the estrogen class, comprise of hormone replacement therapy or selective estrogen receptor modulators, which used to be very much in clinical application late 80s, early 90s, but then bisphosphonate or anti-catabolic, that has come since early 90s, and that is actually the first line of anti-osteoporosis therapy. They act at the anti-resorptive stage. One more came, anti-rankle antibody denosumab in 2008. It is a monoclonal antibody-based therapy that is also anti-catabolic. Anabolics are two, PTH 1 to 34 and PTH-RP 1 to 36. Both of them target type 1 PTH receptor on osteoblast. And these are anabolic, that means they promote bone formation. And as late as in 2019, anti-sclerostin antibody, a Wnt inhibitor, which is osteocyte specific, and that has a anti-osteoblastic effect. That means it inhibits bone formation. That sclerostin's antibody is has been used as therapy in, it got approval in 2019. So that is a so-called dual action. That means it promotes bone formation and at the same time inhibits bone resorption. But that is still questionable whether or not it is dual action or not. Next slide, please. Now coming to adiponectin and its receptors. So adiponectin, interesting thing is that it's as its name indicates, that it is a hormone produced chiefly from the major producer is adipocytes, particularly the white adipocytes throughout the body. But it is also produced from other organs, including skeletal muscle. Now, adiponectin is the most preponderant or abundant hormone in the blood. Its level can be as high as 25 microgram per ml. So you are measuring hormone at the microgram per ml level. So, and it is basically a 240 to 250 amino acid glycoprotein. It is a glycoprotein. And if you see this variable domain up on the left hand side, upper left, this cartoon showing the adiponectin protein. So the variable domain is the one which allows adiponectin to make oligomers. Then there is a collagen domain that is similar to or homologous with C1q complement. And then there is this globular domain that is the largest part of adiponectin, or 50% of adiponectin is the globular domain. And this globular domain from the multimeric adiponectin can be cleaved by leukocyte elastase, and it can form trimers which are held together by hydrophobicity. Tremendous hydrophobicity will keep them together. And overall, adiponectin will have these three different oligomers: trimers, which are the low molecular weight, LMW, or medium molecular weight, MMW, and high molecular weight, or HMW, which can have 6 or more oligomerization. In general, globular adiponectin is adiponectin receptor 1 activator, and high molecular weight adiponectin is adiponectin receptor 2 activator. Now, adiponectin receptor 1 and so adiponectin has these two broad category of receptors, adipo-R1 and adipo-R2. R1 is principally present in skeletal muscle, and R2 is in liver. Now, both of them, if you look at these structures, the cartoon structure I have provided, are 7 transmembrane, but they don't interact with any GPCR. And other difference between the GPCR and adiponectin receptor is that it has the C-terminal extracellular and N-terminal intracellular domain. Next slide, please. Now, in terms of signaling by adiponectin receptors, the major signaling studied has been related to glucose utilization and glucose uptake and fatty acid oxidation. That is because adiponectin was discovered as a hormone that helps in spending energy and getting rid of excess energy. So if you see it's ADIPO-R1, there is an adapter APPL1, and it activates liver kinase D1, which in turn activates AMPK, which is a cellular energy sensor, as we well know. And then AMPK can subsequently upregulate the mitochondrial biogenesis factor PGC1 alpha. At the same time, it will inhibit mTOR, which will inhibit protein synthesis, and also it can promote autophagy. And on the ADIPO-R2 side, which is primarily the signaling components occurring in liver, it stimulates PPR alpha and then activates uncoupling protein, so that the browning, as a result of which the browning of fat occurs, and it also stimulates the production of catalase 1 and SOD1. Next slide, please. So why did we think that ADIPO-R1 will have any relationship to bone? It was all about energy metabolism. These are the two major findings which led us to investigate its role in bone. One is association studies, human studies, that ADIPO-R1 polymorphism in Korean postmenopausal women linked to lower femoral neck BMD. And then another study where ADIPO-R1, when overexpressed in transgenic adult mice, displayed higher BMD. Next slide, please. So what we did is that we took this globular adiponectin, and we did an assay, which is a standard assay that we do using rat calvarial osteoblasts. These are primary cultures. These are pre-osteoblasts derived from calvarium. And when treated with globular adiponectin at doses starting from 1 to 20 microgram per ml, there was significant increase or dose-dependent increase in ALP activity, which is a surrogate of osteoblast differentiation. And then we took the bone marrow stromal cells and induced mineralization, in vitro mineralization, and presence of globular adiponectin at 10 microgram per ml increased the mineralized nodules, and these nodules, the calcium was extracted out of the nodule, and there was a significant increase in calcium content in the nodule, indicating that it promotes mineralization, which is the ultimate indicator of osteoblast differentiation. Next. One click, please. Yeah. So then we incubated, please hold on. Then we incubated this primary osteoblast in presence of globular adiponectin plus dorsomorphin, which is an AMPK inhibitor. We used AKT inhibitor, votmanin, P38 inhibitor, and SIRT1 inhibitor, EX527. And what we observed that it is only dorsomorphin, AMPK inhibitor, which completely abolished the osteoblast differentiation effect of globular adiponectin, but others were partial, and SIRT1 had absolutely no effect. Then we incubated these osteoblasts with globular adiponectin, and there was a time-dependent and rapid phosphorylation starting from 5 minutes, reaching peak at 45 minutes of phosphorylation, and at 45 minutes the induction of phosphorylation was more than double. Next click, please. Then we also noticed another interesting thing, that globular adiponectin in osteoblast is increasing the expression of adiponectin receptor 1. That means the ligand is increasing the receptor expression. And the presence of dorsomorphin completely blocks the effect, which means that there is an indication of a feed-forward situation. Next click, please. Then the downstream of phospho-MPK is PGC1 alpha, the mitochondrial biogenesis factor. And what we noticed is that globular adiponectin increases the expression of PGC1 alpha maximally at 48 hours, and presence of dorsomorphin again blocks that effect. Next click, please. So in order to connect PGC1 alpha with osteoblast differentiation, we used silencing of PGC1 alpha. And then what we saw is that induction of osteoblast differentiation by globular adiponectin in presence of SI-PGC1 alpha is obliterated, as shown on the right bottom panel. Next slide, please. Okay. Then we studied, since PGC1 alpha is enhanced and it is a mitochondrial biogenesis factor, we studied the effect of globular adiponectin on oxidative phosphorylation activity in osteoblast. And this is a extracellular flux analyzer data on live osteoblast, and we found that glycolysis was not affected by globular adiponectin, but all three mitochondrial respiration were enhanced. Basal mitochondrial rate, maximum mitochondrial rate, and ATP production was nearly doubled in osteoblast in the presence of globular adiponectin. Next click. Then we measured the mitochondrial DNA copy number, which is indicator of mitochondrial mass that was increased, and then using MitoTracker on the right hand panel, we find that globular adiponectin increases the mitochondrial mass, and also it enhances the depolarization. And next click, please. Next click. Yeah, and then we use the PGC1 alpha siRNA experiment again to show that globular adiponectin in the induced ATP production can be blocked by silencing PGC1 alpha. Next click. And similarly, now what are the scheme of events have happened? That globular adiponectin upregulated AdipoR1, followed by induction of PGC1 alpha production, and PGC1 alpha is increasing the mitochondrial biogenesis reflected by increased ATP production, and increased ATP production can be blocked by PGC1 alpha silencing. And then we did the final experiment of osteoblast differentiation, that when we used rotenone, GAD plus R, if you see on the right hand ALP activity data. So rotenone is a mitochondrial complex 1 inhibitor. It completely blocked globular adiponectin induced ALP activity, whereas 2-deoxyglucose, which is a glycolysis inhibitor, had no effect. So that means that it is only the upregulation of mitochondrial respiration, globular adiponectin promotes osteoblast differentiation. Next slide, please. Okay. Then we used a osteoporotic model, which is obtained by bilateral ovarectomy, and in that osteoporotic model, we took the femur bone and found that in ovarectomized rats, the middle three, which is indicated by V, means vehicle, AdipoR1 and PGC1 alpha are both downregulated compared to sham, which are ovary intact. And globular adiponectin at 100 microgram per kg restores it, which has been plotted on the right hand panel. Next click. And we confirmed this finding in another way, that we took newborn rat pups and injected them with globular adiponectin or vehicle for 5 days in succession, 5 doses, and then we took the calvarium, which is rich in pre-osteoblast, and then we studied expression of AdipoR1, PGC1 alpha, and RANX2. It is a osteoblast transcription factor. All three significantly enhanced by globular adiponectin, which suggests that these, whatever we observed in vitro data up until this previous till the end of the till the last slide, we are seeing the same phenomena happening in vivo. Next. And then we also found that the mitochondrial mass in calvarium has also gone up by globular adiponectin. Next. So we wanted to see the osteogenic effect in vivo. We have shown it in vitro, but now we would like to show in vivo. And the benchmark of osteogenic activity is shown by surface leveling by calcium. There are various bone-seeking fluorescent dyes. So if you inject this dye with a time space of 7 to 10 days, and then you make sections of bone, and then you can see the double leveling. Wherever you see the double leveling, here you will see that there are double leveled surfaces. Those surfaces indicate the bone formation during this period of interval in which the dye was injected. And from there, mineral surface, mineral apposition rate, and bone formation rates are calculated. And what we find is that compared to the clinically used anabolic drug, which is PTH 1-34, it was on a par. Globular adiponectin was on a par with mineralizing surface by bone surface, and at least it is bringing the level to the ovary intact control level, all three parameters, which suggests that it is clearly a osteoanabolic hormone. Next click. And then we studied the serum osteoanabolic biomarker, which is a procollagen 1 N-terminal peptide. It is derived from collagen 1 from osteoblast at the stage of deposition of osteoid, which also comes into the serum and is a surrogate of very valid accepted surrogate of bone formation. And globular adiponectin can completely reverse the PINP downregulation that happens in OVX plus vehicle group. Next slide, please. Then we studied what happens to the spine. It is the trabecular bone, which is eroded in OVX plus vehicle. Just look at the left panel, first two panels, sham vehicle plus OVX plus vehicle. You see the erosion occurring in OVX plus vehicle, and globular adiponectin treatment along with the standard of care such as PTH, alendronate, and estrogen, all recovering it. And next click, and you will see that the volumetric BMD that has been plotted and bone volume that has been plotted. These are the microcity data, and these quantitation clearly show that the loss of BMD and bone volume in overectomized animal has been completely reversed. Next click. And then we did compression test for bone strength, and the bone strength indicated by maximum load, energy, and stiffness. All three parameters were decreased in overectomized animals, and globular adiponectin was able to completely restore those parameters, which suggests that the bone mass as well as strength both are restored by globular adiponectin. Next. So these data were published in one paper. Next. Now, you must be wondering that why not use globular adiponectin as a therapy for osteoporosis? The problem is that you cannot really you cannot scale it up. Globular adiponectin, we had to express, we have to make the expression vector, and then we have to in vitro translate it, and then we have to multimerize it, and that is the way we had made it as a reagent. It was a major hassle we had to do before doing this experiment. So it cannot really be scaled up for bringing it to the clinic. So we were looking at possibility of small molecule adiponectin receptor. And then this paper came to our notice, and it says that identification of adiponectin receptor agonist utilizing a fluorescence polarization based high throughput assay. Next slide. Next click. Now in the table there are 9, and okay, this group has screened in that assay system. They screened a big natural product library, And these are all natural compound, naturally occurring, or the phyto compounds that has either adipo-R1 or adipo-R2 activity. Next click. And when we saw that, one compound attracted our attention, and that is taxifoliol. Next click. And this is taxifoliol, which very similar looking compound we already worked 2 years back. Next slide, please. This is the compound we already worked on. Next click. So this is called GTDF. It is a GTDF is a short form of the huge IUPAC name. Basically, it is a quercetin analog with a 6C glucose. You can see that there is a glucose moiety attached at 6C position. And we already had found then that it induces osteoblast mineralization. Next click. And it inhibits osteoblast apoptosis if you induce the apoptosis by serum deprivation. Next click. And in overactomized animal, it completely restored the trabecular osteopenia, GTDF at 5 microgram per kg. Next click, equivalent to PTH and at least better than alendronate. So when that happened, in 2013, when we observed that, notice that paper, next, we, next slide, please. We performed a phospho-MPK simple Western blotting using C2C12 myocyte because adipo-R1 is high in myocyte. And what we found is that at 1 minute, it stimulates phosphorylation of phospho-MPK, and effect starts to wane by 30 minutes. And P38, which is also a downstream of adipo-R1, is rapidly phosphorylated. Then, next click. What we did is that we took adipo-R1 and adipo-R2, we transfected it, we made a stable transfected cell lines in CHO cells, CHO cells, Chinese hamster ovarian cell, which does not express these receptors. We made a stable cell line with adipo-R1 and adipo-R2, and then we radio-labeled GTDF, radioiodinated GTDF, and did a radioreceptor assay, the classical radioreceptor assay using the membrane fraction. And next click, that is what we found doing this assay, is that it binds to adipo-R1 GTDF with a KD of 4.9 nanomolar per liter and Bmax of 1400 femtomole per milligram protein. But with adipo-R2, you notice that KD is 326 nanomole per liter. So it is 70 times more selective to adipo-R1 over adipo-R2. Next. We actually in that study, in that previous study, in that previous paper, we not only showed that it is a adipo-R1 agonist, but at the same time, we studied its in vivo effect in energy metabolism in DBDB animals, and we showed that it completely restores the metabolic dysfunction. But then in the same animals, we find that they have poor bone. And because the diabetic bones are also compromised bones. And the presence of GTDF completely restores both femur and tibia bone, equivalent to metformin, DB plus met, and was better than DB plus pioglitazone. Next. So this is the last slide. After this, what we did is that we took up a screening assay using the phospho-MPK activation with our natural product library, and there it is going on. But so far, I'll give you just updated what is the current status. This is our observation that genistein, camphorol, apigenin, they have no adipo-R agonistic activity. Isovitexin, which is a C-glycosylated apigenin, is a strong adipo-R1 and R2 agonist. GTDF, I have already shown, is a strong adipo-R1 agonist. Resveratrol, which is present in which is a stilbenoid, present in red wine, is an ADIPO-R1 agonist. That is the reason why there is a French paradox that French people drink red wine along with high-fat food, but yet they do not put on weight, is most probably because of resveratrol's ADIPO-R1 agonist activity. And epigalactocatechin gallate present in tea, especially green tea, it is a catechin, is a ADIPO-R1 agonist. These agonistic activities have been confirmed also in skeletal muscle as well as bone cells as well as in vivo. Next. So the summary is that adiponectin has osteoanabolic effect when it comes to bone. The osteogenic activity of adiponectin requires mitochondrial biogenesis. Phytochemicals are a rich source of adiponectin receptor agonists. So people should, whatever phytochemicals they have in their lab, should first of all, in order to find out its proximal target, should screen whether or not it is an adiponectin receptor agonist or not. There could be high chance, depending upon the kind of structures I have shown, could be in those lines. And C-glycosylated compounds are potential adiponectin receptor agonist. Final slide, next. Yeah, I must acknowledge Sham, Subhashish and Konika. They are the major force behind all the data I have shared here. And of course, generous funding from DST and CSIR. Thank you. Thank you. I didn't cover this thing, so you don't have to.
Thank you. Thank you, Dr. Chattopadhyay, for your nice presentation. Mostly, I am also concerned with endocrinology. We are well aware about the adiponectin action on metabolism, but you have emphasized the action of adiponectin on bone. You discussed the different aspects of adiponectin, starting from basic, that is adiponectin structure, its receptor, how it works is associated with the mitochondria, how it promotes mitochondrial function, and so on. Basically, he also discussed about the signaling pathway of adiponectin. Basically, his approach is that osteoporosis is a common phenomenon. It is a common disease. Its prevention is quite less, particularly in the females during their menopausal period. It is a severe disease. So the basic approach, he has done extensive basic research. In addition to that, his approach is towards the anti-osteoporotic therapy. She discussed almost all the points using almost starting from cell biology to different aspects using animal models and other. He has done an excellent work, but he tried to explain the complicated things through his nice presentation, nice slide. In this young age, he has done extensive work. And I feel that Physiological Society of India has done justice awarding you for its original lecture. Personally, as my endocrinologist, I wish your all success. I request Dr. Kushal Das if he wants to say something, or Rajan Haldar. Dr. Rajan Haldar.
Thank you so much,
Dr. Chattopadhyay. Thank you very much. And we are really honored to confer Professor K. Raghutam Rao Memorial Award 2021. You deserve it and you proved it by your work. And thank you very much for everything. You have accepted our honor and be here. And I also thanks to organizing committee chairpersons, Dr. Shashibala Singh Madam, who is the director of NIPAR and Fips president, that giving me a chance to be chairing in the session in this moment, along with Professor Chandra. I request that now Dr. Rajan Haldar, the Honorary General Secretary of the Physiological Society of India, and Professor Amar K. Chandra will chair the remaining programs of the Society's Symposium. Thank you very much to everyone. Thank you very much.
Thank you, Novidya.
Das and Professor A.K. Chandra for the Physiological Society of India orations. We would now start with the Symposium 2, Physiological Research in Health and Diseases. I would request the chairpersons, Professor A.K. Chandra and Professor Rajan Haldar, to carry forward the symposium.
Thank you.
No.
So, may I start, sir?
So next, Dr. Debashish Bandyopadhyay. I hope so. Or
Sir, you may call Professor Dr. Hemanta Kole.
okay, no problem.
Okay. Actually, he just requested. He has a urgent meeting. So, our next speaker, our speaker in this session, the first speaker in this session is Dr. Hemanta Kole. He is working as a scientist A and a senior deputy director of the National Institute of Cholera and Enteric Disease. This is an ICMR institute, Government of India. So actually, after completion of his master degree in physiology from the Department of Physiology, University of Calcutta, Dr. Kole joined in the National Institute of Cholera and Enteric Diseases, NICED, for his PhD degree under the guidance of Dr. Nair. And in 1996, he joined as the associate professor in the Department of Physiology, College of Medical Sciences, Nepal, where he devoted entire heartily in teaching and medical students till 2000. And in the meantime, Dr. Kole got the opportunity for postdoctoral research at Department of Physiology, Rutgers, the State University of New Jersey, USA. After completion of 1 year in the Rutgers University, Dr. Kole moved to Boston, and where he joined in gastroenterology section at Harvard Medical School as a research associate, and worked there on molecular mechanism of Barrett's esophagus and to identify therapeutic target of adenocarcinoma under the leadership of Professor R.K. Goyal, who was an eminent professor, a Mallinckrodt Professor of Medicine, and also a renowned gastroenterologist. Professor Kole has 11 patents and has published about 150 original articles in various national and international journals. He has completed 11 projects and 6 projects still running. With these few words, I request Dr. Kole to deliver our talk on the next generation OMR VS based enteric bacterial vaccine development by the way of multidimensional approaches. Please, Dr. Kole.
Thank you very much, Professor.
And one more request.
Can you hear me?
Yes, we can hear you. One more request. Please restrict your talk within 20 minutes.
Sure.
Okay.
So thank you very much, Professor Rajan Haldar, giving me a good introduction about me. And thank you very much to the Fips members to give me the opportunity. And special thanks to Physiological Society of India, especially Professor Chandra and others. So this actually work I started when I was a student of NICED. So it is the long way, but I'll try my best to go for as possible by short. So this way I'll be talking about the choice of vaccine assays, multi-dimensional immunogen approach, next generation OMB based vaccine. So we do have the very good antigen, antibacterial antigens, but we don't have the good assay system. That's why I as I'm a physiologist, first I developed the animal model for assay. So the enteric bacterial infection cause of diarrhea throughout the world, especially developing country, but among them the hospitalized based, we have surveillance, we have seen. So cholera as well as the enteric disease are with us. So it is going on. And so if you, when I was joined 1992 for PhD, so now 2022, still you can see how is the patient is taking admission in the ID hospital, and how is the diarrhea is going on, and how is the death every year. So there is lots of the different bacterial isolates in ID hospital and child BCOI child hospitals, so organisms. So it is not possible to make a vaccine for the all bacteria, but bacteria. So my idea is that so why we'll go for the Shigella vaccine, Salmonella vaccine for 111? Why not make it a common, means the combination vaccine, one shot vaccine and short immunization period. So in enteric bacterial pathogens, if we go for that, so we can see the cholera every year, 150,000 deaths, ETA 500,000 deaths, typhoid 600,000 deaths, rotavirus 600,000 deaths, Shigella 800,000 deaths every year is going on. But this is the but I will try to maybe I'm working on all the enteric organism against vaccine development, but I will hear. So most of the times I will give you the Shigella vaccine as well as shigellosis. So if you go if you see here, so we don't have the choice of drug. For most of the organisms are multi-drug resistance. So only cetirizine is choice of drug, but that drug is not oral drug, but you have to give the through the intravenous. So sanitation is the prevention for that the diarrheal organism. So the sanitation is developed.
Hello. मैम जब आप सिंपोजियम शुरू करेंगे ना, और तब उसी टाइम आप बोल दीजिएगा कि 15 मिनट्स कि हर स्पीकर को के लिए 15 मिनट्स and all the questions will be taken up at the end.
Dr. Jane, can you mute you?
Yeah. So sanitation is not possible because of developing in India.
आवाज कट रही है थोड़ी. Hello.
Rehydration therapy is not possible because of the it is the invasive diarrhea, and the antibiotics is, as I told you, that this is the global emergence of multi-drug resistance. So vaccine only the possible to control the diarrheal disease. But 50 years, the scientists and academicians are trying to develop the vaccine, but it is not possible. So 100 years ago, Japanese scientist Kiyoshi Shiga, they actually discovered this Shigella, but still we don't have the vaccine. So shigellosis is rarely occurs in animal, but you can do the surgical manipulation. As I am a physiologist, physiological manipulation, surgical manipulation, it is possible to make a shigellosis in animal model. So why I'm talking about this, as I'm a physiologist, when I joined here in NICED, so asked me to develop the good assay system for a vaccine assay in animal model. So I have developed this model by physiological manipulation, surgical manipulation, and immunological manipulation. And so we know that the organisms are host specific and organ specific. What is host specific? The guinea pig is the host specific Shigella to the guinea pig, whereas the Vibrio cholerae, Shigella, E. coli, host specific is the rabbit, but universal specific the E. coli, Vibrio, Shigella of mice. But if you go to the organ specific, so the stomach is the Helicobacter pylori. Corona is over here, but Didonum, Jejunum, Ileum, Cecum, E. coli, Salmonella, Vibrio, Campylobacter. Shigella only colonize in the colon and rectum. So accordingly, I have developed the one assay system in animal model. So I directly introduce the organism to the rectum as well as in colon. As a result, I got the very good animal model to assay the vaccine assay against this shigellosis. But this actually I started long back oral through the oral live conjugated transconjugated the Shigella vaccine, but it is the live organism with the help of Dr. Deepak Sen and Dr. Kumar. But with the collaboration of Dr. Mitobe, also we have developed the live conjugated vaccine. But those vaccines, the live conjugated vaccines are not a natural vaccine. So it is a manipulated vaccine, and that can revert after long immunization. So it will be dangerous to us because the multi-drug resistance may occur. So with the Dr. Munoj Chakraborty, when I was a student, and then I with him, and then started to work with the heat kill vaccine, but the single vaccine. But Dr. Jivinar was my professor. He asked me the limitation of the single serotype vaccine is impossible. Only homologous protection is possible, but minimum six serotypes is need to protect the other. Actually, the Shigella is total 50 serotypes. You have to make it the universal vaccine. So it is not possible to make a single vaccine. That's why we need minimum 6 vaccine. What is that? We have taken the serogroup A, B, C, and D. Among them, one organism taken because this is the epidemic strain, predominant in the endemic area, especially in West Bengal, and predominant in developing country, especially to the Japan and USA. And by the process, we have selected 6 strain and different combination or genotypic as well as phenotypic combination, and then started work with the collaboration of Okayama University. And then, so we have successfully, we have published so many papers, and then, but I am not happy with this. Only the homologous protection is possible, not the heterologous. Heterologous is 0%, sometimes it is 0%. So I have seen that when we are working with the heat kill as well as live organism, OMPA1 protein is a conserved protein, is available most of the organism. And then my student Priyadarshini Mukherjee, and he formulated a OMPA subunit vaccine. This subunit vaccine is really physiological process. I have taken how it is. So the ketosine adherence with the endocyte and release in this secrete this secretory IgA. So in this process, so we have done it, and this one also got the patent After that, we are not happy with the subunit vaccine. It is not given the 100% protection. And then we started with the ghost cell vaccine. What is that ghost cell? So we treated with sodium hydroxide and then inclusion body taken off from the organism, and then use as a antigen, and that also have not given me the promising result. But I come back into the OMB based vaccine. The Sweet Mighty have developed the bivalent non-typhoidal salmonella, and it is protect to the most of the typhoid organism. And then while we are working with, we have seen that most of the organism are multi-drug resistance is coming from the chicken, because they are using the combination drug, and that not possible to cope up all these. And then so that's why we started to work with the, if it is possible, to the livestock vaccination. So and then that way we can figure out the infections to the human being. And then we also started the diarrheagenic Escherichia coli. Why? Because to use the to make it the combination vaccine with the Escherichia coli, diarrheagenic Escherichia coli. There is a 5 to 7 organisms, EPEC, ETEC, and EAIC. We make the combination vaccines with the OMB base. And then we had a problem with the typhoidal salmonella, and then we combination with the typhoid and paratyphoid vaccine, and this was patented. And then this vaccine is techno inventions taken for the commercialization. And after that, actually, this is we developed the Shigella vaccines. The OMB based Shigella vaccines. This is the combination of Shigella, Shigella dysentery, Shigella vaccinari, Shigella boydi, and Shigella soni. And then this is the very easy method of OMB isolation. So 8 to 10 hours of growth, and then supernatant by ultrafiltrations by millipore, and then that was plated down by the by ultracentrifugation, and then that the OMB was collected. That OMB we have used as a antigen. So we immunized the 0, 7, and 28 day, and then immunized to the female mice, and male female. We got the pups and challenged with the wild type of organism in different days interval. We have seen that the neonatal gut, mainly the milk is are the main for the protections, the mother milk. Why? Because secretory IgA actually help as a anti-colonization, and we have seen here 90 to 100% protection against the wild type of organism. Outer membrane vesicles of the Shigella boydi type 4 induce the passive protection immunity. We have published in Fips microbiology, and then the multi-serotype outer membrane vesicles of Shigella, they confer the passive protection to the neonatal mice and against to the shigellosis. So, and also we have seen the OMB Shigella active various pro-inflammatory markers, and it also regulated the mixed Th1, Th2 cellular response. And then, so we have developed the, normally the OMB is secreted very, very less. So we actually, due to the low yield of production of Shigella OMBs, and we solved the problem. So we knocked out the 12-pal system and secrete the more OMB, and then we use for immunogen, and we have seen that. Yes, please. Then wild type of OMB, the protein content is 50, whereas the toll deleted protein is 80, is increasing the protein as well as the LPS content. And then this was patented is internationally, and then we published in vaccine. And then we are trying to develop the more, what is the mechanism of the protection of the which responsible the antigen. So the summary is like that way. We have we can conclude that choice of vaccine assay is the best for the guinea pig model, a multi-dimensional immunogen approach. So we have seen the multi-setting OMB is the best. The next generation vaccine with toll deleted OMB based antigen is the best antigen. So this one actually the formulation actually we move with the Hillman laboratory, and then this one is going to commercialize, and the MSD, the Hillman laboratory will be manufacturing this low-cost product. Phase 1 and phase 2 proof of concept will be in Africa 2022. So the Shigella vaccine candidate timeline will be the 23. It will be the finished by the process. So there is lots of contributions. Most of the student, most are my student, and also my mentor here. Thank you very much. So I think finish in time.
Thank you, Dr. Kole, for your presentation. We are well aware that cholera, rather diarrhea. Diarrhea is a very common disease among the population of the Southeast Asian region and also globally. So many people are trying their level best in the different parts of the globe to prevent it. But Dr. Kole has taken such important initiative because he has taken multidisciplinary approach to prevent the disease. There are lots of approaches for the prevention of this disease, but Dr. Kole's approach was to develop vaccine against it. What will be the composition? What are the composition of it? How it will act? He has discussed elaborately. In addition to that, for the first time in his institute, he installed animal model. Not only he restricted in the major common areas of the GI tract, but he also used other parts, for example, colon, rectum, and also like that. He also showed his respect towards his superiors, and his works is quite excellent. And last but not least, I like to say that Professor B.N. Kole, a former professor of the University of Calcutta, was one of the founder members of the Federation of Indian Physiological Societies. Today, we got Dr. Hemanta Kole, a close relative of Professor B.N. Kole. He has presented such a nice lecture. His approach is to develop vaccine, and how far I have gone through the through his slides, and how far my knowledge is concerned, within a short period, his team will be able to develop vaccine. So I am seeing no question from chat. If anybody has any question, he can raise, or I request Dr. Rajan Haldar to say something about this lecture. If he has any questions, or are there any questions? Thank you. Thank you, Hemanto, for your excellent
Thank you very
lecture.
much, sir.
Thank you, sir. Thank you, Dr. Kole. So it's now open. I think I cannot see any question in the chat box or question answer. So I think if audience have any question, they may ask. By the way, it's a nice talk on the multi-dimensional or combinational vaccine development. It really is an extraordinary approach. So I have one question, may not be related to this. So actually, so far I know that too many COVID patients admitted in your institute. So did you ever try to develop any vaccine regarding the COVID-19 or any coronavirus?
So actually, our institute is by name. You can understand that it is the National Institute of Cholera and Enteric Diseases. But actually, we do have the department for virology. They are working on the virus, but we don't do any the vaccine research of corona. But we do only the diarrheal research only. But we have the department for detection. We have the for assay different assays of COVID, as well as the PCR, RT-PCR is going on. But we don't do the vaccine against the COVID. Yes.
Okay. Thank you. And just one more question is my curiosity. When the human trial will be possible regarding your vaccine, what you have developed, you are developing in your laboratory?
Say again, please.
What about the human trial? What about the vaccines you are developing in your laboratory right now?
This is actually the mainly the diarrheal disease happen to children only 5 years and below 10 years, and very rare to the upper age, but it is happen. And then so those are actually the Shigella, E. coli, and Vibrio. Vibrio to the upper age, but Shigella and E. coli. So we are actually trying to develop for them only, and ORS can help in this situation because of the Shigella is the invasive diarrhea.
Actually, Dr. Kule, I'm curious to know the human trial. When
human trial is we do have lots of the human trial in NICED. We do have the special department also. We do have, but yes. So diarrheal disease as well as the cholera and salmonella, typhoidal is going on.
Okay, thank you. So
thank you, Dr. Kole.
So we may move to our next speaker, sir. So
we just 1 minute. We are well aware that how difficult it is to develop vaccine.
Yes.
Your approach is excellent. I hope in near future, as a basic physiologist, you have started your career, and now you are at the end of your research. So I wish you all success. If anybody have any question, they can ask it.
Thank you very much, sir.
It's an excellent presentation.
And now I request Dr. Devas. Now I request Professor Devasish Bandyopadhyay for delivering the next lecture on behalf of the Physiological Society of India in the Fips platform. Regarding Dr. Bandyopadhyay, I like to say that he is an eminent biochemistry from physiology. He is presently the Professor of Physiology, University of Calcutta. Dr. Devashish Bandyopadhyay is presently Professor at the Department of Physiology, University of Calcutta. He served this department as the head for 2 full times. Before joining the University of Calcutta, he was the founder head of the Department of Biotechnology, Assam University, Silchar, Assam, India, followed by head, Center for Biotechnology, Vishwabharati University, Shantiniketan, Bulpur. He did his PhD work at CSIR Indian Institute of Chemical Biology, Calcutta, and his postdoctoral work was at the University of Texas Medical Branch at Galveston, Texas, USA. Professor Bandyopadhyay has been working on melatonin. His great interest is for melatonin. He has been working for melatonin for a long time. Melatonin at Galveston has been melatonin since last few decades and has made significant research contribution on melatonin in the domains of enzymology, oxidative stress, and free radical biology, mitochondrial ischemia, gastric ulceration, which developed. He has also developed new drugs and antioxidant of synthetic or neural origin. He has national and international collaboration and has published more than 125 research publications on his in his credit. Professor Bandyopadhyay is a regular reviewer of numerous peer-reviewed journals. He is one of the editors of the journal Cardiovascular Regenerative Medicine and Melatonin Research, published from USA. Additionally, Professor Bandyopadhyay is a member of the governing body and research advisory committee of some prestigious national research institute. Moreover, Professor Bandyopadhyay is a recipient of prestigious Porimal Vikas Sen Memorial Oration Award from the Physiological Society of India. I know Professor Bandyopadhyay. I see Professor Bandyopadhyay with our own eyes. He is a great biochemist, he is a good scientist, and he has produced many PhDs. And his great interest is for melatonin for therapeutic use. Today he will deliver the lecture on this. And if Dr. Rajan Haldar want to say something about Professor Devashish Bandyopadhyay, I request Dr. Haldar for doing the same. Please, Dr. Haldar.
Thank you. I will not consume any time. So whatever Dr. Bandyopadhyay is like a guide in my department. I respect him very, very much. He's a very nice person and a very good scientist, I know. Everyone knows he works on cardiac system and the melatonin for a long time. So I only request Dr. Professor Bandyopadhyay to restrict his talk within 20 minutes. So please, sir, please, you may proceed.
Good afternoon. Good afternoon, everybody. Can you hear me and see the slides?
You are quite audible.
Yes, sir. Yes, sir. We can hear you, and your slide is absolutely visible.
Okay. Good afternoon, everybody. I must first thank Professor Chandra and Dr. Haldar for nicely introducing me, very nicely introducing me. And also, I like to thank Professor Chandra and Physiological Society of India and also Dr. Haldar to nominate me as a speaker in the platform of Fips. And finally, I would like to express my gratitude to President Madam of Fips, who has provided us with the opportunity, not only to the society, but also to us. So as you can see, for several decades, we have been working on melatonin. Today's topic of discussion, as you see, melatonin, a promising therapeutic molecule for cardioprotection. So myocardial infarction, myocardial ischemia is a problem of human health globally. and people are looking for a lot of solutions. So let us have some discussion. Slide change হচ্ছে না। So, ischemic heart disease and acute myocardial infarction are currently major health threats and have reached unprecedented levels in the urban as well as rural society. This is increasing day by day. In the 21st century, cardiovascular diseases are one of the most important public health issues. According to an estimation by WHO, 17.9 million people died due to cardiovascular diseases, which is 32% of all global deaths in 2019. And alone in India, in 2017, CVD caused 2.64 million deaths and IHD 1.4 million deaths. And if you count the cases between male and females, they are very close to each other. So, be it cardiac hypertrophy or myocardial ischemia or any other cardiovascular situation, reactive oxygen species are involved. They are toxic molecules which are continuously generated in living organisms due to pathophysiological processes. Antioxidant mechanisms are required to maintain redox state by quenching and neutralizing ROS. So, disturbed balance due to excessive ROS damages different cellular components including proteins, lipids and nucleic acids. Such condition is referred to as oxidative stress. It is almost known to every person pursuing biological science today. Mitigation of such oxidative stress induced myocardial injury leads to improved cardiac performance. And 5% of the ground state oxygen is in reality is converted to various reactive free radicals, reactive oxygen species. But it is not that we are alone. We have with our antioxidant system, the defense mechanisms include enzymatic as well as non-enzymatic components. And overall, the antioxidant reserves can be overwhelmed, obviously, during the states of oxidative stress, as is the case in ischemic heart disease and heart failure. So a number of drugs used clinically to reduce the likelihood of developing cardiac disease inflict collateral damage. Thus, while they may be helpful for a specific condition, at the same time, they may subvert molecular physiology and cellular function to the extent that they eventually compromise the overall well-being of the organism. So cumulative data suggest that these damaging effects are mediated by free radicals and related reactants. So antioxidant properties of some therapeutic agents, as I have mentioned here, like angiotensin converting enzymes are very popular nowadays. Carvedilol, metoprolol, quinidine, stobadine, amlodipine may be relevant to their cardiovascular benefits, but prolonged use may exhibit pro-oxidant activity. So what people feel that there is a necessity for a therapeutic agent which possesses a versatile antioxidant activity, apart from having anti-ischemic and anti-hypertensive properties with no pro-oxidant activity. Melatonin seems to be a promising candidate. So now let us have a look into what is melatonin and what are the informations that support its cardioprotective nature. Melatonin, which is a tryptophan derivative, was first isolated from the bovine pineal gland and identified as N-acetyl 5-methoxytryptamine by Lerner and co-workers et al. In 1958. Since then, melatonin has been found to be present in almost all vertebrates, including human. Melatonin is found in bacteria, unicellular organisms, fungi, and plants. That means it is present everywhere. It seems that melatonin may have evolved in all evolutionary life forms from the simplest bacteria to humans. What is the main message? That it is a highly conserved natural molecules, and from whatever source it is isolated, the structures are same. And melatonin, as it is a biological molecule, it has a synthetic machinery within the pineal gland located within our brain. its levels are high in night and low in daytime, and its levels also decline with the advancement of age. Some medical benefits that have been indicated in many thousands of papers include treatment. It can be used as a treatment regimen for insomnia, as a preventive jet lag medicine, antioxidant, immune function booster, cancer chemotherapy, and people have reported that melatonin can delay the aging process. In one such experiments published in Nature, they have elevated the lifespan. They have increased the lifespan by 25% in that model. So that is very, very important that melatonin is a versatile molecule. It is an amphiphilic antioxidant, and that means it has no morphophysiological barrier. It can enter into any compartment of the cell, and N-acetyl and 5-methoxy groups are mainly responsible for its free radical scavenging activity. So it is a versatile antioxidant. I have listed so many of the different types of organic or inorganic free radicals that can be scavenged by melatonin, and it has further been reported that melatonin can quench the redox active iron and copper. This discovery was made in around late 1980s. And you can see a number of disease situations or problematic conditions where melatonin at pharmacological concentrations have been shown to produce good results, not only to prevent the disease, but also in the rectification of the disease condition. And very recently, it has been shown that melatonin has the ability to provide the protection against oxidative stress in type 2 diabetes, because type 2 diabetes exhibits in patients a lot of complications, that cannot be, you cannot go on giving medicines one by one. You have to check the progression of the disease. So the journey of melatonin as a radical scavenging antioxidant started in 1993 with the TAN's discoveries that when hydroxyl radicals are generated following exposure of the reaction mixture to UV light, it scavenges hydroxyl radical whose rate constant, is 10 to the power 9 per second, is very fast. So we have interest in molecules like isoproterenol, which is a chemical stressor, a synthetic catecholamine, and where it produces changes in the myocardium in animal models, which can mimic the human heart immediately following infarction or the gradually progressing myocardial ischemia. And melatonin, which we know very well that it is an ancient and conserved ubiquitous antioxidant molecule, that has been studied as a cardioprotective antioxidant both through in vivo and in vitro studies. So based on these informations, we have carried out a series of experiments to explore the protective effect of melatonin against isoproterenol bitartrate-induced rat myocardial injury. Isoproterenol bitartrate is a specific salt of isoproterenol that can directly go into the cardiac muscle or cardiomyocyte. And try to elucidate the underlying mechanism of protection offered by melatonin against such damage. So question before us at that time when we began the research was whether a hydroxyl radical is associated with myocardial injury. And we measured quantitatively the hydroxyl radical generated in the stressed myocardium, which was found to be protected almost completely, which was found to be inhibited almost completely by 10 milligram per kg body weight dose in rat myocardium. But if hydroxyl radical is generated, then can we demonstrate or could we demonstrate the formation of superoxide anion free radical in vivo condition? So we have demonstrated it and published these results in Journal of Pineal Research. But following that, we thought that we must concentrate our attention to the energy metabolism of rat myocardium. And also, we also observed that even if the biochemical changes are protected by a minimum dose of melatonin, but the histological changes would not be protected, as we judged it from the expression level of alpha-actinin, which is a structural protein of rat myocardium. So we planned experiments. We divided animals into several groups. What we did, that we treated the animals with isoproterenol and protected them with melatonin, removed isoproterenol, continued the animals to get protected with melatonin for 2 and 4 more days following isoproterenol injection, and tried to see whether melatonin can also be helpful in the recovery from myocardial injury. So this, if you look at these histological slides presented of the rat myocardium, you can see that you cannot find any difference between this one and that one. This is the control slide. This is the recovered slide. So this is the isoproterenol, the 2-day and 4-day. So what and we compared these with the expression level of alpha-actinin, which we have shown to be almost structurally protected. That means melatonin not only is helpful in providing protection to the rat myocardium, but it can also help in recovery of the rat myocardium following injury. But that data has also been supported by the expression of the collagen level that we have checked with confocal microscopy. But the question remains that whether the heart rate improves or the cardiac output improves following such type of treatment, the blood pressure improves. So at that point of time, that was around 2012 or 2000, I think 9 or 10. That Dr. Bandyopadhyay has, Dr. Arun Bandyopadhyay, who is now currently the director of IICD, has provided me with this equipment. Later on, we have procured with the UGC funding to our laboratory also. But at that time, we have measured the hemodynamic parameters and found also that melatonin is helpful in the myocardial recovery. So, but what our biochemical observation was that in such type of oxidative stressful situation, in energy metabolism was considerably depressed in rat myocardium, and which is reflected in the results. If you see the activities of pyruvate dehydrogenase, isocyclic dehydrogenase, alpha-ketoglutarate dehydrogenase, succinate dehydrogenase, all are inhibited and all are protected. That means a decreased ATP generation is the outcome. So we thought that these results are now optimized to get published, and we published these results in Journal of Penial Research again. But the research continued, and we tried to understand, because from rat myocardium you cannot extract much amount of mitochondria. So we switched our attention to goat heart, because previously we have published several papers which indicated clearly that goat myocardium contains large amount of mitochondria. Although goat is not that much active animal, but they have higher amount of mitochondria compared to other mammalian species. So we have isolated mitochondria, purified them, and with these purified mitochondria, we have studied concentration-dependent studies, both with isoproterenol and melatonin in vitro. This is, the slide showing that the mitochondria are all right, both metabolically and microanatomically, and finally found a concentration and time-dependent. That means when we use these mitochondria for our purpose of experiments, whether the mitochondria remain alive, whether they are trying to fight it out, is reflected by the elevated level of lipid peroxidation, which melatonin protects dose dependently, and a time dependency also is maintained. This means that the mitochondria remain alive, and what we are reporting are reporting on the basis of working with the live mitochondria. So, then again, we continued our study to stress status, measure the stress status of the mitochondria. And particularly, if you can look at the graph of glutathione peroxidase versus manganese SOD, which is the principal antioxidant enzyme of within the mitochondria, manganese-dependent enzyme of mitochondria, you can see a perfect situation of hydrogen peroxide accumulation, which is supported by the E redox measurement, which also melatonin protects. So we have studied the protein oxidation and found also melatonin protecting the oxidation of protein against the stress. But our objective was to identify the mechanism of the inhibition of energy metabolizing enzymes and how melatonin protects these enzymes. We found that it is isoproterenol competitively inhibits the energy metabolizing enzymes. And this is not the case with only pyruvate dehydrogenase. It is the first enzyme toward ATP formation. But if you can see through several slides, this is isocitrate dehydrogenase. Then, this is isocitrate dehydrogenase. This is, alpha ketoglutarate dehydrogenase. And this is, succinate dehydrogenase, the terminal enzyme for, the ATP generation. All are inhibited. The pattern of inhibition remains the same. And, melatonin removes such inhibition. These we have studied both with the crude enzyme, purified mitochondria, as well as with the pure enzyme, and got the same results. That means what we have observed with the crude preparation is also the observation with the purified preparation. So again, we focused our attention on the respiratory chain enzyme activities, and particularly interesting result is that a depolarized mitochondria is a healthy mitochondria. Depolarized mitochondria is an unhealthy mitochondria, and a polarized. That means we have measured the ratio between the polarized versus depolarized mitochondria, and to see whether melatonin could protect this shift of polarization. And we found that melatonin is capable of maintaining the mitochondrial polarity. So we studied the mitochondrial morphological surface morphology study through scanning electron microscopy and bright field microscopy, and got the same result that isoproterenol causes. That means if you generate oxidative stress in the mitochondria gets damaged. And if you co-incubate them with melatonin, they can, the mitochondria, you get the protected mitochondria. So these results, this was 2015, we have published again in Journal of Pineal Research. But after that, we thought that there should be a clear-cut dose response or concentration dependent study, because, the question was, is it only a one dose affecting, or is it a multiple dose affair? So we have studied the serum enzymes in rat model and found that yes, it is a dose dependent protection by melatonin, and only melatonin does not affect rat heart. That is the reason that people all throughout the world now know that melatonin is a non-toxic molecule basically. So this is lipid peroxide, biomarkers of oxidative stress, and all are dose dependently protected. This is, glutathione peroxidase versus glutathione reductase, and then MNSOD versus catalase, and all are dose dependently protected by melatonin. Similarly, this slide is very important. If you look at this, that we have studied almost all the enzymes of the Krebs cycle. Pyruvate dehydrogenase is the starting one. Then, aconitate, isocitrate dehydrogenase, alpha ketoglutarate dehydrogenase, succinate dehydrogenase, fumarase, malodehydrogenase, and citrate synthase. All are dose dependently protected by melatonin. That means melatonin can not only protect the ATP formation mechanism, but also it helps in the, as we have shown in the earlier slides, that it can help, it can be helpful in the recovery process also. So the respiratory chain enzymes demonstrated the same level of activity and protection by melatonin, but the question was whether it can protect the infarction size. So this, you can see the infarction size here. This is the quantification of the infarction size with TTC staining, and melatonin almost reduces the infarct size to the control level. Only you can mark it only at the 10 milligram per kg body weight level in vivo experiment, okay, in rat model. So that is very, very important. That even if someone, takes 20 milligram or, 50 milligram melatonin per day, it is expected clinically that, the heart will remain protected from ischemic injury. So these are the micromorphological studies. This is this one is the iron hematoxylin eosin staining. Here you can see the damages, the neutrophils accumulated, but in the protected slide, the heart, the slides looks normal. This is Alcian blue staining, where you can see the typical collagen accumulation, which is protected from such type of accumulation. Again, showing that melatonin is capable of fully capable of providing protection at the minimal doses. Don't think about taking higher doses, or it is effective even at the dose of 10 milligram per kg body weight. So again, we have isolated mitochondria, tested for their purification, tested for their damage, and we found that the mitochondrial morphology is protected almost completely by 10 milligram, 10 microgram per ml incubation mixture. This is again the mitochondrial morphology studied through scanning electron microscopy, and quantification shows that almost the surface morphology is completely protected by the melatonin. This is, the polarized versus depolarized mitochondrial, aggregation, and this again shows this experiment was carried out through the FACS equipment, and not only the reactive oxygen species are controlled, the accumulation or concentration of reactive oxygen species was controlled, but also the oxidative damage of the mitochondrial rat mitochondria was also highly significantly protected by melatonin. Similar is the case with the unstained mitochondria, and the protein oxidation scenario also getting protected by melatonin. Similarly, as everyone knows that ischemic myocardium reflects an inflammatory condition also. So our question was, can we find some changes in the inflammatory markers which cause genesis of the myocardial damage, or creates enough free radicals within the myocardial tissue or body as a whole? So we measured TNF-alpha, IL-beta 6 and 10, and found that in all the cases, melatonin can protect the changes or alterations in the level of the inflammatory markers. So this is a very crucial slide that we observed that melatonin helps in mitochondrial biogenesis. In the face of oxidative stress, when that myocardium gets damaged, the mitochondrial morphology gets damaged, and its biogenesis was reduced to a minimum. But if melatonin is there, if the animals were protected by melatonin, we found the activation of PGC1 alpha, HSP70, and SORT1 and SORT3. So it is clearly working through PGC1 alpha, SORT1, SORT3 pathway, whose activation clearly indicates the biogenesis of mitochondria. So that is a very good outcome of the research. And but the question still remains that can we go into the minute details of the mechanism of action of how melatonin protects against whether it is only antioxidant activity or whether it is only the alterations of the antioxidant systems, or there are some other mechanisms working. So we have performed several studies, one of which I have shown here, which shows that melatonin can bind with isoproterenol on one hand, and the vulnerable sites of the antioxidant proteins on the other. That means it has a two-pronged activity. And this was, a very important activity that led us to believe and to communicate several papers to demonstrate a third mechanism of melatonin's action. And before publishing this data, you can see here is a thermodynamic binding, favorable binding, saturable binding, one-site binding, which shows catalase isoproterenol melatonin binding clearly shows that it has two-pronged protection. It can bind with the vulnerable sites, thereby not allowing the oxidants to cause damage to the vulnerable sites, sensitive sites. On the other hand, it can bind isoproteienols, so much so that existing concentrations of isoproteienol within the reaction mixture or within the cardiomyocytes cannot generate enough amount of free radicals or other reactive metabolites or intermediates to cause damage to the proteins, lipids, and nucleic acids of the cardiomyocytes. So these we have published very recently in Helion, which is coming up as a very good journal published from Elsevier. And but what is the platform of that thinking? The platform of that thinking was our earlier research, where we have clearly established a third mechanism from India, that this discovery is from India, that and the world over it has been recognized that the copper in copper ascorbate model, which is also a very internationally recognized stress model, chemical stress model, that we have studied the binding of catalase with copper, favorable binding with catalase and ascorbate, copper ascorbate as a whole, and thermodynamic changes showed us that the binding is possible, binding is happening. So we again studied the catalase copper melatonin binding, which is a saturable binding, one-side binding, catalase ascorbate melatonin, catalase copper ascorbate melatonin binding. So it's a sequential binding. That means the binding is thermodynamically feasible and it is happening. So, but the final question that we asked, that can melatonin bind with catalase? So here you can see it's the one-side saturable binding. The saturation point is very far. So we have only demonstrated the linear part of this reaction sequence. So this shows that melatonin not only is capable of binding the oxidant molecule or the combination of oxidant molecules at one hand, but it also has the ability to bind with the vulnerable sites or sensitive sites of the protein molecule. Or here the protein of interest is obviously the antioxidant enzyme catalase. So these results we have published in the century-old journal Life Sciences, and this is the overall, the scheme of how now the theme that we have with us, that melatonin protects the myocardium against oxidative stress, and it promotes the mitochondrial biogenesis through SIRT1, PGC1, alpha SIRT3 pathway with alteration of the GSH-GSHD ratio, and it inhibits pro-inflammatory genesis of pro-inflammatory cytokines, and anti-inflammatory cytokines are promoted, along with the improvement in the activity of the Krebs cycle. So what is the total outcome? That total outcome is the mitochondrial cardiomyocyte cell death and the mitochondrial cell death and necrosis are prevented from or protected. Mitochondria are protected from undergoing cell death and necrosis. So what we can conclude? The ability of melatonin to provide protection against oxidative stress induced myocardial injury is gradually getting well established. Melatonin significantly protects against the isoproterenol bitartrate mediated competitive inhibition of mitochondrial enzymes. The binding of melatonin to the toxicants on one hand and to the vulnerable sites of important proteins like catalase provide new clue to its third type of mechanism of protection. These results raise a great possibility of melatonin being considered for human use or for use in humans alone or as an adjunct therapy in different cardiovascular situations associated with myocardial tissue injury. So as an acknowledgement, it is, the hard work of the students who work day and night in my laboratory. My laboratory remains open right from Monday to Sunday. And almost during the sleep time, the laboratory remains closed. And I must deeply appreciate the help and cooperation from my research collaborator during those years, Professor Dr. Arun Bandyopadhyay, who is continuing as a director of CSIR IICB Kolkata, where from I got graduated. And the funding agencies, obviously CSIR and UGC's different research schemes awarded to the university, for which I became a part in for many years. And that's all. Thank you very much for your patience here.
Thank you, Professor Bandyopadhyay, for your nice presentation. Melatonin belongs to the property of endocrinology. But in the eyes of a biochemist, a core biochemist, Dr. Bandyopadhyay started his professional career on melatonin. Initially, his interest was on the antioxidant activity of melatonin, but in course of time, he studied the effect of melatonin in several systems, including gastric ulcer and so on. And he got promising result. He published all the papers, all those. In this deliberation, Dr. Bandyopadhyay tried to establish the effect of melatonin in cardiac ischemia. For the purpose, he used almost all the biochemical techniques, histological technique, molecular biology, cellular techniques, and so on. So he tried to establish, and he also mentioned the specific dose for which melatonin will be beneficial for human health, particularly human health. His work, he has done extensive work on this aspect, and I hope in future he will establish himself, because melatonin is his target molecule. Melatonin is the target molecule of Debashish Bandyopadhyay, and I wish you all success. And I request Dr. Rajan Haldar and our General Secretary of the Physiological Society of India to say something. And if any questions, I am seeing the chart is blank. So if anybody of you have any question, you can raise it. Okay, Dr. Bandyopadhyay, for your nice presentation.
Most welcome. Most welcome.
Wish you all success.
Most welcome.
Wish you all success.
Thank you. Thank you so much.
Thank you, sir, and thank you, Professor Bandyopadhyay, for your nice presentation. It was really a good session. I enjoyed your lecture. I had many questions while you were speaking, but at the end, almost all questions are answered. So really, it is very nice. And one thing I'd like to mention. When I talk to sir regarding any kind of stress or anything, he suggests me take melatonin. Rajan, you please take melatonin every day. I take every day. It's a very good medicine.
Yes.
So thank you, and it's a good suggestion. Melatonin is available in the market in
Yes.
tablet form.
I consume 20 milligram melatonin per day.
Yeah. Yes.
During the COVID time.
So I request the audience, if you have any queries in this regard. Professor Bandabadi is here. In the chat box, I don't find any question. So thank you, Professor Bandabadi, for your nice presentation.
Be safe.
We may move to our next speaker. So,
Dr. Haldar, may I request Professor Devidas Ghosh as the next speaker?
Okay, sir.
Okay. So Devidas Ghosh is present. Yes, he's present. I hope so.
Yes.
Okay. Thank you. This session will be chaired by myself and Dr. Rajan Haldar, the General Secretary of the Physiological Society of India.
Yes.
Before going to this, it is customary to say few words, though these are very less, but we have nothing alternative for time constant that I have to complete it within a short period. The Professor Devidas, he is the professor Professor of Biomedical Laboratory Science and Management. He is professor and UGC Research Awardee and Indo-Tanzania Bilateral Fellow. He has completed his BSc, MSc, PhD, even prior to that, MPhil from the University of Calcutta. He has 30 years teaching experience. He has completed 17 projects, was completed, and the funds that he have received from UGC, ICMR, DST, Government of India, NCRT, CIS, AYUS, etc. He has international collaboration with Indo-Tanzania Bilateral Research Project. The research project ongoing are 17. Ongoing research projects are 17. It is difficult to believe that professor like Devidas Ghosh is running 17 projects. He project from UGC, DST, Government of India, and so on. His total research paper is about 147, international journal 30, national journal 52. His age index is 28, which is quite good in the eyes of the scientist. He got the following awards: PBCN Gold Medal Research Award from the Physiological Society of India in 1991, UGC Research Award 2005, Sikha Ratna Award from International Friendship Society 2009, Chitralekha Memorial Oration Lecture from the Physiological Society of India in 2012. He is also the Fellow of Academy of Science and Technology, West Bengal. Patent published, he has a number of patents. I am not going through it. He has in total a number of patents. He awarded, under his able guidance, 36 students have done their PhD. Till now, 8 students have been working who are registered under his guidance. From Google search, it reveals that his age index is 28, I-10 index 78, and citation index is 3,778. So, in brief, all these are about Professor Devidas Ghosh. Initially, he joined in the Department of Physiology, Vidyasagar University, but it is a matter of great honor to say that by his devotion, by his sacrifice, by his dedication, he developed another department wherein he is the professor. That department is Biomedical Laboratory Science and Management. He is quite associated with the activities of the Physiological Societies of India. And with this, I request our General Secretary, Dr. Rajan Haldar, to say a few words on Professor Devidas Ghosh.
Thank you, sir. Thank you. Actually, my first appointment was in the Department of Physiology, Vidyasagar University, where I found Professor Ghosh as my colleague. And just I'd like to mention that he's so efficient. He can manage so many work at a time, and is really very efficient. And within few months, when I was there, he developed the Department of Biomedical Laboratory Science, where he just shifted as a professor. And that was not good for us as a physiology department, because and a very eminent professor just left the department. But it was a nice introduction of a new subject. He's the first one who developed in this Eastern India the biomedical laboratory science. So that's why I thank Professor Ghosh, and being the colleague, I found him very helpful and very energetic in every time, any time. So with these few words, I would not like to consume more time. I'd request Professor Ghosh to please continue and deliver your lecture, and kindly restrict your talk within 20 minutes. Please, sir, you may proceed.
Okay. So good afternoon, all of you. And I also offering my heartiest gratitude and thanks to the Physiological Society of India, especially Professor Amol Kumar Chandru and Secretary Dr. Rajan Haldar. The slides are visible. Are you? Hello? Slides are visible.
Yes, sir. Yes, sir.
Okay.
Slides are visible,
Thank
but not in full screen. Kindly make it full screen.
Full screen. Full screen. Okay, thank you. Now the today topic is novel antidiabetic phytomolecule of leaves of Camellia sinensis, genomic and proteomic approaches. That total work has been funded by NTRF.
Yes, I'm sorry to interrupt you, sir. Slide is still not in a full screen.
Not full screen.
Sir, one thing you can do, just stop the sharing, and when you share your entire screen, and then go to this, not to this particular window. Just share the entire screen.
Share. Is it okay?
Yes, sir. Yes, sir.
Yes.
It's absolutely okay, sir.
Yes, yes. So today my topic is novel antidiabetic phytomolecule of leaves of Camellia sinensis, genomic and proteomic approaches. This total work was funded by NTRF, National Tea Research Foundation, and actually my lab is also working on the natural products from the different phytomolecules. And main work that is going on here, mainly that is the anti-diabetic drug development, as well as the male contraceptive development. Now, regarding the diabetes mellitus, I like to say that it is a lifestyle disorders, and at present it is not as a disease, it is a syndrome. And we also know that there are 3 P's mainly, there is a polyuria, polydipsia, and polyphagia. And there are so many causes of the diabetes mellitus. There is a genetical cause, though it was not previously known to us, but at present it has been noted that some mitochondrial genes are also responsible for this transmission of this disease. So many environmental factors are also associated for the high incidence and the prevalence of that diabetes mellitus. And presently, lifestyle and food style, that is the unhealthy lifestyle and unhealthy food style in the 20th and the 21st century, these are the most important causes for the high incidence of diabetes mellitus in our nation. And another one we also know that the autoimmunity for the diabetes, that is the antibody against the insulin receptor as well as the different protein against the beta cell. So these are the autoimmunity aspects. But lifestyle and food style, these are the major cause at present. And if you study the incidence rate of the diabetes mellitus in our country, then in the school-going children, it has been noted that is about 12 to 13%, the incidence rate, which was in 18th and 19th century about 2 to 3%. So it has been increased by 5 to 6 times, and that is the unhealthy food style, unhealthy lifestyle. So our motto was that with the help of our food habits, if we can able to search out some nutraceuticals which have some anti-diabetic activity, if we consume such nutraceutical through our daily food items, then is there any chance for such protection? As the tea is the important beverage and is the general beverage to all in our country. So it is another interest of our work that is there any anti-diabetic phytomolecules in that tea leaves, that is the green tea as well as the black tea, and thereby we can able to prevent the different environmental factors or the oxidative stress which are responsible for the high incidence rate of the diabetes. If we study the literature review, I'm not going details about that due to the time limitation. It also noted that there are so many causes of the diabetes, and it is also associated with the diminution of the several carbohydrate metabolic enzymes. There is also oxidative stress injury in the different metabolic organs like the liver, like the kidney, etc., etc. And there is also low level of the insulin as well as the C peptides. So on the basis of such literature review, if we study that high incidence rate of that diabetes, on that basis, we like to find out that is there any natural products or phytomolecules or nutraceuticals which are also present in the common beverage, that is the tea, which may be considered as the parallel treatment, or you may say that it is also a sole therapeutic agent for the recovery from the diabetes as well as from the protection of this diabetes. So why herbal medicine is the most important? 20 to 40% of the old population suffering from diabetes mellitus, and present anti-diabetic drugs are of high cost, toxic, and there are so many side effects. And after some years, there is also adaptation of that drug. Resistance is also drug is also noted. Now, World Health Organization also proposed that 25% of the modern medicine have descended from plants. Many synthetic drugs are synthetic analogs built on if that anti-diabetic activity can be raised further or not. 70% of the modern medicine in India are also derived from natural products. 80% population in developing countries rely on plant drug and primary health care, and supplemented traditional drugs so that resistance, adaptation of the drug may be delayed. So these are the major driving forces to design our research work in this field. If we study the tea plant, that is the Camellia sinensis, there are also so many types of tea. Mainly there are 4 types of tea. I am not giving details about that. And we are very much interested to use these leaves of this Camellia sinensis for the prevention of the diabetes. Though there are so many reports about that therapeutic effect of these leaves of that Camellia sinensis, that it has protect cardiovascular disease. It also prevent cancer as well as the microbial diseases. It also protect neurodegenerative diseases and prevent HIV infection. But there is very few information about the anti-diabetic activity of the Camellia sinensis. We also published few papers about this anti-diabetic activity of Camellia sinensis. And there is some limitation about the publication of this paper in this line, because my third patent is also in the line under the India government. So we are unable to publish further about the publication using the pure molecule which we have isolated from that leaves of this plant, which is totally separated from the established nutraceuticals from that leaf known as catechin, epigallocatechin, gallate, etc. But our molecule is totally separate from that phytomolecules, which is a new phytomolecules from that pharmacopoeia searching. And this is also our actually in process for such patenting. So literature review which also indicates that several polyphenols present in the tea, which also has an important effect for the diabetes management. And there is also report that green tea have some anti-diabetic activity, though all this work is also on the extract, not the pure molecule. That also decrease the glucose, that also decrease the antioxidant enzyme activity like catalase, superoxide dismutase, oral glucose tolerance are also decreased. And we also reported that anti-diabetic and antioxidant activity of Camellia sinensis using the extract as well as the fraction. But though we have also submitted our patent file in that pure molecule, but we are unable to publish about that pure molecule before the registration of this patent. So our aims and objective is that to find out the most effective solvent extract as well as the fraction, and standardize optimum therapeutic dose, effective duration of treatment, and visual study of selected effective solvent fraction of the Camellia sinensis for diabetes-induced hypotesticular management as well as the diabetes management. To find out the bioactive fraction of Camellia sinensis in diabetes-induced germ cell apoptosis, including the defined metabolic deterioration which is noted in that diabetic condition. And we also focus that the beta cell status, what is the insulin level, what is the glycated hemoglobin level, what is the C-peptide level, etc., etc. If we study the experimental design, then we like to say that the whole work has been conducted on streptozotocin-induced diabetic model, that is the type 1. And we also conduct the bioactivity guided selection of the most active tea extract. Fraction preparation, ethyl acetate fraction preparation, chloroform, etc., etc. And we also noted it with the help of PLC, HPLC, NMR, that what is the active molecule which is responsible for that management of this diabetes. First, we also conduct our work using the aqueous extract, and then hydromethylene extract, then methylene extract on the basis of the polarity as per Indian pharmacopoeia. And we also noted that ethyl acetate fraction of the hydromethylene extract is the most effective in this purpose. So we also use the pure form or the ethyl acetate fraction from the hydromethylene extract by lyophilization, and we also use this for this anti-diabetic activity assessment. The different sensors that we have also considered for this testing, that is the fasting blood glucose level, glycated hemoglobin, serum insulin, there is the rat insulin, C-peptides, and insulin receptors also. Enzymatic parameter, there is the carbohydrate metabolic enzymes, antioxidant enzymes, end product of the lipid peroxidation, we have also measured it. Genomic sensors, there is the BAX and BCL2, there is the anti-apoptotic, pro-apoptotic sensors in the hepatic cells, because these hepatic cells are also the one of the progenitor cells, that is the stem cells for that beta cell generation. There is the hepatic stem cell generation for beta cells. There are also extra hepatic stem cells for beta cell generation. For this study, we also give emphasis on that liver cells. And we also like to find out that what is the apoptotic status of the hepatic cells in the diabetic condition, as well as after the treatment of this pure molecule, which have been we obtained from that ethyl acetate fraction of the hydromethylene extract, That why it can, whether it can able to protect this apoptosis of these hepatic cells, and thereby it can able to help for the processing of the stem cell generation of the beta cell. We also measure the hexokinase 1 gene expression, GLUT4 gene expression in the target cells. We also measure the BAX quantity and the BCL biowestern blot, HEX1, hexokinase 1, GLUT4, etc. We also measure the histologic analysis of the pancreas and beta cell population in different experimental model by flow cytometry. We also measure the toxicity and quantification of the biomolecules, active biomolecules, first by semi-quantity by TLC, HPLC, and then we also measure it through NMR for mass spectra also for structure analysis. Now, from this study, it has been noted that the ethyl acetate fraction of this hydromethanol extract that has a remarkable activity in case of blood sugar management. In the streptozotocin model, that blood sugar has been remain in high after 28 days, which is about 322 mg per dl. But after ethyl acetate fraction treatment of this hydromethanol extract, the sugar level, blood sugar level has been decreased drastically. Okay. Similarly, if we study the glycemic profile that the serum insulin, if we study the insulin receptor, if we study the glycated hemoglobin, and if we study the C-peptide, that C-peptide is the most important sensor for the beta cell status. Insulin at present is not considered as a sensor. Plasma insulin is not considered as an important or sensitive sensor for beta cell status as per WHO, because there is an enzyme insulinase which is present in liver that can be able to degrade the insulin. But at the time of secretion of the insulin from the beta cell, there is a relationship between the secretion of C-peptide and the serum insulin from that beta cell at the ratio of 1:1. Because at the time of conversion from proinsulin to insulin, one molecule of C-peptide and one molecule of insulin is produced. Though the insulinase, which is a hepatic enzyme, is responsible for the degradation of the insulin, but for the degradation of the C-peptide, there is still now no enzyme has been invented in mammalian system. So the C-peptide is considered as the most important sensor for beta cell status. And it has been noted that C-peptide in the diabetic state, that has been decreased drastically. But after the supplementation of that pure molecule, the C-peptide level has been increased significantly, not up to the control, but near about to the control. It is not up to the control. Similarly, if we measure the hexokinase enzyme, which is the starter enzyme of the glycolytic pathway, which has been decreased by the diabetic condition, that also recovered to some extent by that phytomolecule. Similarly, the liver as well as the skeletal glucose 6-phosphatase, which are also elevated in diabetic condition, that also decreased at a significant level by that phytomolecule. So the hexokinase enzyme that are also decreased both in liver and the skeletal muscle in diabetic condition have been recovered at a significant level, and the glucose 6-phosphatase have been that are also increased in the diabetic condition are also corrected at a significant level by that phytomolecule. Similarly, if we study the antioxidant profile, that is the catalase activity as well as the superoxide dismutase activity, that are also decreased drastically, both in liver as well as the kidney in the diabetic condition. Because you know that diabetic is the most important oxidative stress induction in the different metabolic organs. But these phytomolecules of this Camellia sinensis can able to protect this catalase and the superoxide dismutase. And we also noted that actually there is a nutrient gene interaction. That means this phytomolecule, this nutrient, can able to switch on the particular gene, catalase gene, as well as the superoxide dismutase gene for its expression. And due to such genomic activity of this phytomolecule, we also hypothesize that this recovery is also to some extent permanent or the long term, not the temporary. If it is a non-genomic action, then this recovery is a temporary process. But if it is if there is any genomic activity, then it has some long-term effect, or you may say the permanent effect. Long-term effect is also very much good. That means daily intake of this phytomolecule is not needed. suppose 1 or 2 at the interval of 3 days or at the interval of the 7 days, that is sufficient for the maintaining of the activity of these antioxidant enzymes. So if it is not and that is non-genomic activity, if it is a genomic activity, then the intermittent treatment, it also focuses the intermittent treatment. That means daily treatment is not needed for this purpose. Similarly, if we study the quantification of the lipid end product of the lipid peroxidation, like the thiobarbituric acid reactive substance, TBARS, or conjugated diene, which are the end products of this lipid peroxidation, which are also elevated in the diabetic condition in liver. Both the TBRS and the CD, both are increased. But in case of the pure molecule treatment, it has been noted that that quantity of the TBRS as well as the quantity of the conjugated diene, both have been decreased significantly. Similarly, if we study that genomic profile, that is a nutrient-gene interaction. Previously, we have no idea about that activity of the nutrient on gene action. But from the research work which is going on in the global basis in this line, that there are so many nutrients that can able to modulate the particular gene expression modification. Some nutrient can able to switch on and some nutrient can able to switch off the particular gene. And on that, most important of the science has been developed, which is known as nutrigenomics. And we also follow that idea in our study, that whether this molecule has any effect on that gene expression, especially that the BAX gene expression, which is the pro-apoptotic gene. Pro-apoptotic gene. In diabetic condition, which has been expressed at a high rate, but the expression of the BAX gene in the liver, hepatic BAX gene expression was controlled, or that means decreased or recovered at a significant level by that phytomolecule. It has a significant effect, but not up to the control. So this study indicates that if we potentiate it, or if we use as a parallel treatment with some other standard drug, then we can able to use it as a parallel drug. And what is the significance of this parallel drug? That means the resistance of this standard drug, resistance of this gold standard, or you may say that is the traditional drug, can be delayed. And as a result, the lifespan of that diabetic patient can be enhanced. Similarly, another one, BCL2 gene, which is also the anti-apoptotic gene, that also decreased in case of the diabetic condition, and it has been elevated at a significant level by that phytomolecule. Similarly, we also measure the gene expression of the hepatic hexokinase 1 gene, that was decreased in the diabetic. Similarly, hepatic GLUT4 gene expression was also decreased in case of the diabetic condition, and both were recovered at a significant level, near about 40% of the control level after that phytomolecule treatment. Similarly, the toxicity study also noted that hepatic GOT and GPT, which were increased significantly in case of the diabetic condition, are also recovered to some extent by that phytomolecule. Now, this is the interesting study about the genesis of the beta cells. Previously, we have idea that beta cells are not regenerated. That means the beta cells from the stem cell. Is there any chance for the high rate of the elevation of this beta cell generation from the stem cell? It has been noted that there are some phytomolecules which can able to gear up that generation of this beta cell from the stem cell. And for this purpose, we also perform that flow cytometry, that the improvement of the beta cell population by this camellia sinensis. In case of the diabetic condition, the beta cell is normal, that is a 17.6%, that first block. And in the second block, that is in diabetic condition, the beta cell population becomes and in case of the though it is far less than the control, but the significant elevation has been noted by that phytomolecule. Similarly, from that Western blot study, we also measured that is the BAX protein There is a BCL2 protein, and these also follow the same result about that genomic expression. If we study the histology of that pancreas, then it has been noted that in case of the diabetic, the pancreatic beta cell, that is the islet cell size was decreased. And in case of the that is the phytomolecule treated group, the islet size were also recovered at a significant level. Though from this diametric, that is the quantitative study, if we measure that area of that islets, it was not identical with the control. It is about recovered. It recovered about 60 to 70% of this control value. And these are the different phytomolecules present here. This is the TLC. I'm not going in details about that. This is the HPLC, and in that fraction, we also noted that two molecules. We also isolated them to these two molecules, and then we separate these two molecules by subfractionation. This is another one peak, and this is another peak. So we also obtain the two molecules, two specific molecules, which have some anti-diabetic activity. And then we also perform that NMR, C13 NMR of these two molecules. And we also elucidate their structure as well as their molecular weight, their thermal retention, etc., etc. I am not focusing here because this is also some ethics about the patent filing. So this is the NMR study of these two molecules. So on that basis, I came to conclude that these two molecules present in ethyl acetate fractions of the methylonic extract of the green tea leaves may be the effective phytomolecules for the recovery of the diabetes and its related complications. In this aspect, the hypothesis is that ethyl acetate fraction, which also contain these two phytomolecules, may regulate the beta cell generation from the stem cell in connection to the recovery of the diabetic complication. Another one is that this phytomolecule is also reduced oxidative stress, and as a result, the diabetic complications are also corrected. And third one is that the insulin production is also increased, and thereby we can able to rectify the diabetic complication. So these are a publication about the extract as well as the fraction, not on the pure molecule. And I am also offering acknowledgement NTRF Government of India for financial support of this work, Bose Institute of Kolkata for such NMR study, and I am also offering my heartiest congratulations and gratitude to my Honorable Vice Chancellor, as well as the Registrar and other faculty members of our department as well as our university. This is one patent about this natural product on anti-diabetic molecule, and that I obtained in about 2011. I also submitted in 2008 and I obtained in 2011. This is the first patent, and this is the second patent that I have also submitted in 2015 and I also obtained in 2019. And this third patent that is also in actually in pipeline, that is about a few months ago. I do not know that when it will come. So we are actually in limitation about the publication about this pure molecule for this anti-diabetic activity. So this is all about the phytomolecule which I have already isolated from these leaves of this Camellia sinensis. So this is all about that work. If you have any question, I like to give the answer. Thank you all.
Thank you, Professor Ghosh, for your excellent presentation. So the session is now open for discussion. So I request the audience, because there is one chat, I request if they have any questions. And after that, I will conclude the session, particularly this session. If you have any question, please ask.
Yes,
if there is no question, may I ask one question? That is the among the people, most of the people consume tea, but their consumption rate varies, frequency also varies.
Yes,
Whether the prevalence of diabetes that you have studied is less among the tea user, tea drinkers. One question.
Yes.
Second question, they use the tea in the form of in water soluble form. In lieu of that, if they use the tea in ethanolic extract, they will be more benefited.
Okay, so it is a very good question, but actually the steps that we also followed for this preparation of the tea is actually not scientific for the obtaining of this effective phytomolecule here. First one, that we also boil the tea, and in such temperature the effective phytomolecule is not actually persist. So at the preparation of the tea, we must maintain the temperature not above 90 degrees centigrade. Our phytomolecule are mostly damaged, but that means its bioactivity is also destroyed when this temperature is above 90 degrees centigrade. This is the number one. And number two, that in aqueous extract, that molecule is not actually coming in huge form. So this motto is that we like to isolate this molecule from these leaves and to prepare a parallel drug, or you may say a sole drug for this antidiabetic purpose. Okay. So in the ordinary preparation of the tea, that molecule is not coming properly because due to the use of the water, because it is not aqueous extract, it is not purely polar in nature, because water is a polar solvent. So as it is a non-polar in type, so it is not coming properly through this polar solvent, number one. And number two, at the time of the preparation of the tea, as the temperature is more than 90 degrees centigrade, it is 100 degrees centigrade, as we also apply the tea on the boil water. So the bioactivity of this molecule is destroyed to some extent.
Thank you.
But it is a very good question.
Now I request Dr. Howler to say a few words about Dr. Devidas Ghosh.
Yes, sir. We are running very short of time, sir. So I only one thing I would like to ask. It's a really wonderful talk. You explain in a very excellent way about the genomics and proteomics of a very novel antibiotic, anti-diabetic phytochemicals from the tea extract or the tea leaf. So basically, I also consume the green tea regularly, but I found that I feel very uneasy. Then I measured my blood sugar level, and it found to be very low, below around 60 milligram per dl. Then I stopped consuming the green tea regularly. I drink it in a very once in a day or two maximum. So what's the reason, sir, that it reduces the sugar? Is it the green tea or any other factors that may reduce the blood sugar level to some extreme level?
Yes, green tea, actually the different phytomolecules present in the green tea. We also compare the green tea as well as the black tea. Though this effective molecule is present maximally in the green tea, but it is also present in the black tea also. Okay. So our motto is to identify that phytomolecule which is solely responsible for that diabetes management from the black tea and the green tea, and what is their percentage. Okay, and then we like to use it as an antiviral drug along with the standard drug, so that its adaptation as well as the drug resistance can be delayed.
Thank you, sir. So we have a next speaker, sir. Thank you very much for your nice presentation. We may call upon our next speaker, Professor Pubali Dhar. Is Professor Dhar, are you here?
Yes, I'm here.
So it's my great honor to introduce Professor Dhar. Actually, he is currently serving as a professor and principal investigator at the Laboratory of Food Science and Technology. This is a Food and Nutrition Division of the University of Calcutta. And he is also an associate faculty of Center for Research in Nanoscience and Nanotechnology. This is commonly known as the CRNN. And her research team is primarily engaged in exploring different aspects of functional food and nanolipid technology, having an index of 16, I-10 index of 25, and more than 50 publications in international peer-reviewed high-impact journals. with over 880 citations and substantial teaching experience of more than 20 years at both graduate and postgraduate level. She has demonstrated her research and teaching acumen quite conspicuously and consistently. Her educational background in physiology and lipid science makes her one of the few experts who have contributed significantly in the development of novel nutraceuticals. She has supervised 12 PhD theses. Basically, 12 students has awarded under her guidance, and over 8 students are in the pipeline and in the semester and working under her guidance.
Rajan,
She has, yeah.
Rajan, can you make it short? Because of time.
No, actually, you are so experienced. Actually, it needs a long time to introduce you.
Visible? Is it visible?
Yes, you are visible. You are visible. Your slides. It's coming. Yeah. Is it visible? Yeah.
But it is not in slideshow mode, I think.
No, yeah. It's not in slideshow mode. Make it full screen. So she has got many. Okay, it's now fine. So with these few words, I request Professor Dhar to please continue, and also I request Professor Omar K. Chandra to say a few words for Professor Dhar. Sir,
Shall I start, Rajan?
I request Professor Omar K. Chandra if he want to say anything. Professor Chandra?
Yes, please.
Yes, sir.
Dr. Puvali is a young faculty in the capacity of professor in the Department of Food and Nutrition of the University of Calcutta.
Yes.
He is a very good worker. Recently, I have gone through one of his lectures. It is of the same trend. I hope he has been nominated by the Physiological Society for delivering the lecture in Fips forum. I hope she will do justice. I wish her all success. I request Professor Wali Dhar to deliver her lecture.
Just for Professor Dhar, we have time up to 4:30, so we are running late. Kindly, please.
I'm trying my best.
Yeah. Thank you.
I'd like to thank the organizers, the NICMAR Hyderabad and the PSI and them for giving me this chance to present my work in this Fips International E-Conference. Thank you, Professor Chandra and Professor Haldar and Professor Das also. I find him in the audience. Now, hope we will return to the offline mode very soon. I'm showing these data from the thesis work of Dr. Tanmoy Kumar De and Dr. Debojyoti Pal, and I also acknowledge ICMR, CSR, and CRNN, the Nano Center in Calcutta University, and my friend Dr. Hemanto Kole at NICET. So my topic is optimizing nano formulation strategies for nutraceutical delivery. Beside the known nutrients, there are a wide variety of non-nutritive phytochemicals and functional foods. Just now we heard about Camellia sinensis and nutrient molecules, nutraceutical molecules. They are not essential for maintaining the normal cell metabolism and function, but they are not recommended. They don't have any recommended levels in our dietary guidelines. Despite this, many phytochemicals and functional foods have been shown to have beneficial effects and especially on immune functions. And the research on prominent intervention agents, the dietary lipids, the omega-3 fatty acids, the micronutrients, and the functional foods from probiotics to tea compounds for their immunological effects. But the delivery mechanism of these nutraceuticals needs optimization. So our work is with the delivery mechanisms. Now, one word, the soft matter. It's a it includes food. And as I am working with food, soft matter, what is this soft matter? It is a complex fluid and two properties. Number one is complexity and the second one is flexibility. These are very important issues when we are dealing with some soft matter like food. And the cell membrane or the cell cytoplasm, they are also part of the soft matter. And the soft matter are important in wide variety of technological applications because of the wide range of material and the systems that can be classified as soft matter. The soft matter science is an interdisciplinary science, and in which there is functions of physicists, chemists, and material science, and biologists, and nanotechnologists, engineering science. So it's a very important field, and it is growing. Now the nano food, and from the forum of nano food, it has been described as that nanotechnological techniques or tools that are used during cultivation, processing, and packaging of the food. So the idea of nano food is to have food products in the market, improved safety, enhanced nutrition and flavor, and cost effectiveness. So nanotechnology has already brought drastic changes in the food industry by bringing changes in food cultivation, food spoilage, and in all the fields of food science. And so encapsulation with this nanotechnology, the nutrient encapsulation, nutraceutical encapsulation is a very important area of research. So researchers have recognized, established numerous nutraceuticals, as we have heard from Professor Ghosh. Since the interest in nutraceutical components and functional foods have emerged about 2 to 3 decades, from 1980s onwards. And the term nanoceutical, it comprises the nanoparticles or the nutrients in nanoform. So it's the conversion of nutra to nano. It's a rational development for scientific knowledge and technology-driven enhancement. So these are some of the lipid nanostructures that can be produced from nutraceuticals, and the nano encapsulation methods can easily incorporate supplements for optimal delivery to target areas. The function of different food as well as dietary products has developed radically in recent years, and it is not merely a vital source of nourishment and growth to contribute for the health and the well-being of the humans, but protect them from various diseases. That is very important. And the nutrients, when encapsulated in nanocarriers, they are resistant to severe denaturing chemicals, proteases, other enzymes present in the environment. They give stability and the physical fluctuations like the temperature, the pH, the heat, and when they are encapsulated in certain tailor-made nanocarriers, they can be formulated. So nanoceutical is a healthier food, or the healthier term, that is growing up and with greater bioavailability, effectiveness, superiority in the same price. Now, I'm working with nano emulsions, now working with nano gels also, but first we started our work with nano emulsions, and the emulsions are of 3 types: the oil in water emulsions, the water in oil emulsions, and some bicontinuous emulsions. As I don't have any time, I am just going through the slides. These micro emulsions, and what's the difference between micro emulsions and nano emulsions? The micro emulsions are of the same size, that is less than 200 nanometers. Nano emulsions are also of less than 200 nanometers. But the difference is that the thermodynamics, the nanoemulsions are kinetically stable while the microemulsions are thermodynamically stable. It is the most important difference. And this difference is due to the emulsifiers that are used in microemulsions. The ratio of surfactant to oil is greater than 1. Whereas in nanoemulsion, it is less than 1. So this is the main difference between nano and microemulsions. So there are for the unstability, these are the gravitational aggregations and the droplet aggregations. We must have a stable emulsion system. That is very important. And creaming, sedimentation, flocculation, coalescence, and phase inversions, these are the various ways in which the stability of the emulsions are hampered. Now, this slide shows that the food emulsion science is an interdisciplinary science, and there are amalgamation of human sciences, sensory sciences, psychological sciences, the technologies and the technological aspects, and the engineering sciences. So all of them can work in this area. And now in food nano, it's very important. And the first one aspect is the emulsifier. We can use different emulsifiers, and the emulsifiers, what they do, they increase the electrostatic repulsion between the particles, and it reduces the interfacial tension between the droplets and the continuous phase. So emulsifier choice is a very important one. So there are surfactants, there are flexible biopolymers, there are globular biopolymers. We have worked for the oil and water emulsions. We have worked with small surfactant molecules. We have worked with flexible biopolymers, that is peptides, from some sesame proteins. And we are working with globular biopolymers from mustard proteins, and we are also working with phospholipids as emulsifiers. Now these emulsifiers, they have synthetic and the natural emulsifiers, and within the natural emulsifiers we have worked with phospholipids, and we have also worked with some synthetic emulsifiers. Now, to the fabrication part, we find that there are high energy technologies and low energy technologies. I'm not going into the detail about the high energy technologies. We have worked with high pressure homogenizer in the CRNN. We know that Calcutta University bought that machine, and but now we are using low energy approaches. It is a very interesting approach of producing nano formulations, and in which we just want to vaporize the solvent in such a manner that the particles, the larger particles, they break down into smaller nanoparticles due to the cavitation force. And if we can blend these technologies using phase inversion, and we get a very good particle size of the nanomaterials. Now, why we are using these technologies? These micro and the nano encapsulation strategies are highly useful in food applications, and the selective ingredient or the component can be protected from ultimate degradation or unwanted interactions with the environment, cover the bad or the foul smell, taste, and other sensory characteristics, and indirectly facilitate the processing of the components by improving their dispersibility and the solubility, prolong or regulate the release or need or location. That is very important. That is why the drug nanotechnology is also evolving, because the from cancer drugs to different types of drugs, we need targeted delivery. We need to deliver them in small amounts, so that in small amount they can work better than the conventional use of drugs. So that area is growing in different scientific researches. The science of the report suggests that the development of the new drugs alone was not sufficient to ensure a noteworthy improvement in therapeutic efficacy due to the lack of a suitable carrier system and novel drug delivery strategies. We know that in COVID-19 also the delivery systems that were we need more delivery systems, more advanced delivery systems to deliver them directly into the lungs, the vaccines or the drugs that can be delivered directly into the lungs. So that is very important. So the factors are biocompatibility, ability of targeting, drug properties, route of administration, mechanism of drug release, duration of delivery, nature of the delivery vehicle, and stability of the formulation. So these are all the factors that has to be taken into account for producing the formulation, and so that the system can run in its maximum optimum condition. So there are nanostructures for infectious diseases, nanostructures for cancer treatment, nanostructures for diabetes, and nanostructures for cardiovascular diseases. So for the characterization, the nanoparticle tracking analysis, it's a wonderful result we get, that each of the particles we can detect we can track each particle, we can get the raw data of each particle of the nanoparticles, and the Brownian motion that can be you can get an idea about how the particles are moving. And we can also use transmission electron microscopy, the dynamic light scattering microscopy. This transmission electron microscopic structure is of polyunsaturated fatty acids, the nanoparticles, nanoemulsions developed with fish oil. Now, another thing is that what's the hydrodynamic, why we are using DLS, also using TEM, because the DLS, it gives the hydrodynamic diameter, that is each particle, it is covered with a liquid layer, and we are getting that total diameter. But when we are getting the result of the TEM, we are getting the diameter of the particle. So stability of the nanoemulsion is also very important issue, and the Brownian movement, the low rate of sedimentation due to small particle size, gravitational force will be lower. As particles become smaller, the attractive force of van der Waals will be smaller. The zeta potential, the higher the zeta potential, more electrostatic repulsive forces resulted in reducing the coalescence or the coagulation of the emulsion droplets, and the high kinetic stability. So all these are very important, and we must look into these. As the nanoformulations goes into the gastrointestinal tract, it confronts the different pH of the stomach, the mouth, the intestine, and the different enzymes. So the stability issue is very important issue. And there are physiological barriers, and that must be crossed by the nanoparticles, the gastrointestinal barrier, different pH, and this is the polyunsaturated fatty acid or the fish oil nanoparticles that we developed, and we used the emulsifier SPAN 80 and Twin 20, and these are co-emulsifiers and less than 100 nanometers in diameter. We measured the physical stability, the rheology, the oxidative stability for 8 weeks, and why we have done this emulsions, because of the so that they can, the epithelial barrier, the non-invasive barrier, the par-oral, the nasal, the tropical, the transmucosal barriers, these barriers, these physiological barriers must the emulsion, these nano emulsions, they can go into go through them. So that is very important. Let us skip this slide. We have worked with nano delivery system, the par-oral, the in vitro digestibility, the in vivo bioavailability, ex vivo bioavailability, and in situ digestibility system. This is an in vitro model where all the enzymes, all the gastric juice and the intestinal juice, they were simulated, and the effect was studied. Now, but this in vivo bioavailability model, it was helped by Dr. Cole, and in this model, we gave the emulsion through a cannula into the intestine, and after 10 minutes and 30 minutes, we took the emulsion out and we analyzed those emulsions system. There is a correlation between the absorption of lipid absorption and the total volume of absorption of the emulsion. And this is an ex vivo model where we cut the intestine into small halves and into small sections, and they were everted, and they were dipped into the emulsion, and the absorption and the sac, that is the filled in sac, we took that emulsion from the sac and we analyzed those materials. So it's an everted sac model that was done, that was used to study the delivery system. This is the ex vivo bioavailability model, and in this you find that the nano emulsions in the duodenum, in the ileum, it is the highest one, and the absorption is highest one in lipid absorption. Now, this is the real-time data, the cellular absorption in situ model, and we find that the nano emulsion, it is much within the cells. They have the bioavailability is much more in nano emulsions. So all these data, we find that these are due to what's the mechanism behind them? That is the endocytosis that occurs with nanoparticles less than 200 nanometers is clathrin coated, with the help of clathrin mechanism. So it's much faster mechanism, and 200 to 1000 nanometers, it is cavially mediated, while the larger particles, they are phagocytosed. So that the three mechanisms are different with the size of the particles of the food. We have also worked with conjugated linolenic acid. So it's an alpha illeostearic acid, and we developed the nano formulations, and we used ascorbic palmitoyl ascorbate as emulsifier, which has some protective role. And we also have found that LPS induced oxidative stress, and I'm not describing them. We have published several papers in Food Research International, colloid surface P interface, and in and in Journal of Food Science and Technology, which is an Indian journal, for colloids and surfaces A. And the last two are from Food Chemistry and Nanomedicine. So I thank. Yeah, these are summaries of what I have already told. You have to look into the hydrophilic lipophilic balance. That is very important. When you are using emulsifiers, you have to check whether this balance is within 10, and that is important. I'm just skipping them. Thank you. I think, Rajan, I have completed within 20 minutes.
Yes, thank you very much. So, Professor Chandra, would you like to say a few words? Professor Chandra, sir, are you here? So, okay, Professor.
Okay. Now I'm all right. Thank you, Professor Dhar, for his excellent lecture. Now the session is open for discussion. If anybody has any questions, then they ask Madam.
Thank you.
Okay. If there is no question, then with the permission of the co-chair, I like to conclude the session. And after my conclusion, Dr. Rajan Hadar will say something. In this session, there were 8 presenters.
Seven presenters, sir.
8 presenters. Among them, one was absent because of his higher academic activities under the government of West Bengal. So we are sorry for his, quite sorry for his absence. In this presentation, all spoke on different aspects. Among them, 5 were university faculties and 2 were from the core research institute. The first lecture, due to some constraint, we have given the opportunity on his request, Dr. Subhashish Haldar to deliver his first lecture. In the lecture was based on the physiological, psychological, and other problems the people faced during the days of COVID-19. According to him, the people suffered a lot, including various problems, pain, diseases, and so on. Simultaneously, he suggested the preventive measures. After that, there are 2 orations from the Physiological Society of India, and the first oration was the very prestigious oration, was Professor S.C. Mahalanobis Memorial Oration that has been delivered by an outstanding scientist, Professor John Merino, who spoke on brain, breathing, and heart, how they activate their coordinated activity. He emphasized the importance of the Indian yoga in the regulation of such activities. And besides that, he presented the lecture in such a way by citing citing the dedication of Professor S.C. Mahalanobis and the importance in the later phase in the development of the subject physiology and its promotion in the later phase. The third lecture, that was also also oration lecture, that is Professor Arrhythmia Rao oration lecture. It is also a prestigious oration lecture that has been delivered by Dr. Noibidya Chattopadhyay, and he spoke on the importance of adiponectin on the molecular mechanism in the prevention of osteoporosis. His lecture was very thought-provoking, interesting, and he used most of the sophisticated method to establish his observation. After that, from the Research Institute of ICMR, Dr. Hemanto Pole delivered his lecture. He discussed about, because considering the importance of diarrheal diseases in the Southeast Asian region, his approach was to develop a vaccine against the prevention of diarrheal diseases. It was a nice one, and he developed certain models, animal models for the first time. He also used human systems for establishing his studies. And the next one was of Dr. Devashish Bandyopadhyay from the University of Calcutta. He spoke on the possible therapeutic role of melatonin in the prevention of cardiac ischemia. For the purpose, he used sophisticated biochemical techniques to establish the same. It was a nice presentation. And then the lecture was delivered, then the invited lecture was delivered by the Devidas Ghosh from the Faculty of Biomedical Sciences, Vidyasagar University. He spoke on the role of Camellia sinensis, that is tea, in the prevention of diabetes. He also isolated the compound from Camellia sinensis, and he is trying to establish patent from it. Earlier he has patent. It was very much thought-provoking. And the last one, now we can remember, it was the lecture of Wali Dhar. In brief, he showed different approaches using nanoparticles for the drug delivery in the prevention of different diseases. The session was a wonderful one. Most of them, or all of them, were basic physiologists, and they showed their experience in the Fips platform on behalf of the Physiological Society of India. With these few words, I like to conclude. And prior to that, I request Dr. Rajan Haldar to say something about it.
Thank you, sir. We're really short of time, so time was exceeding. So just first of all, I'd like to congratulate the Fips team for organizing this 9th Fips conference 2022. And on behalf of the Physiological Society of India, I thank all the speakers and all the audience. I show my heartiest gratitude and regards to Professor Shashibala Singh, the organizing chairperson and the president of Fips. And I also thankful and show my gratitude to Professor Amar K. Chando, the secretary of Fips, and Professor Kushal Das, and the organizing secretary, Dr. Dharmendra K. Khatri, the wonderful person. I have communicated with him regarding many issues, and he solved very nicely. So overall, without consuming time, I am really thankful. The Physiological Society of India congratulate the Fips team for such a wonderful conference. It would be better if the conference would be in an offline mode, but however, hope in the next 10th Fips conference will be in the offline mode, and we can meet physically to everyone. So thank you very much.
Thank you.
Okay, sir.
Thank you, Dr. Haldar,
yes,
and Professor Kushal Das for chairing the session in the earlier part. Thank you. Thank you.
Thank you so much, Professor A.K. Chandra and Professor Rajan Haldar and all the speakers. We will now begin our Symposium 3, Environment and Nutrition in Neuromodulation. I would request Dr. Suman Jain and Dr. K.P. Koshar to start the symposium.
A very good afternoon to all. Professor Dr. Shashibala Singh and dignitaries on the dais and members of the organizing team. It is our great pleasure to start today the session 3 symposium. And the title of our symposium is The Role of Environment and Nutrition in Neuromodulation. Our first speaker is Dr. Preeti Hegde. Just to introduce her, she has pursued teaching in the field of physiology at several institutions since 2009. She is an alumna of NIMHANS under Professor Dr. Lakshmi, who is a great friend and a great neurophysiologist. And she has had many papers and award-winning presentations. She is a member of Indian Association of Neuroscience, life member, as well as of APPI. And she has participated in brain awareness projects. She is a very good researcher, and I now invite her. But before I invite her, I would like to introduce my co-chairperson, Professor Suman Jain, who is Professor of Physiology and a very, very active neurophysiologist. And just now we were having the session on nanonutraceuticals, and I shall also be talking a bit about that. But she has started the development of the neuromodulation and nanomedicine lab, and she's doing great work in experimental neurophysiology. She has many awards and excellent publications, and also Ames Research Award for Excellence in Publication. So I invite Dr. Suman Jain to co-chair, and we will start the proceedings rolling. Our third and fourth speakers are Professor Vandana Jain, who is Chief of the Division of Pediatric Endocrinology, and as the theme of the symposium is Nature Towards a Healthy Life, and she has been working for child development from in utero to young babies and following them through till adolescence, and working on endocrinological aspects like metabolic syndrome, diabetes, obesity, and non-alcoholic fatty liver disease. She has had advanced training in medical education from abroad, and she's also had a fellowship from the University of Michigan, where she worked with Professor Ramesh Menon and to do the what we call genomic markers of non-communicable diseases, obesity, and metabolic syndrome in young children. My next speaker is Dr. Anil, who is very young. Both Preeti and Dr. Anil are very young researchers, very brilliant people, and Dr. Anil has had his training abroad after he has done his BSc and MSc, and he has done PhD in Germany, and he has worked greatly on the synaptic processes, especially bassoon molecules, and I shall introduce them one by one. So if Dr. Suman Jain, are you there? Can we start the proceedings?
Yes, ma'am. Good afternoon, ma'am, and good afternoon, everyone. Welcome to this symposium. I would request, just before we start the symposium, I will request all the speakers to please time it to 15 minutes. Since we have 5 speakers and we have been given approximately 90 minutes. So we'll try to finish within 15 to 60 minutes. And I'll give a slight hint when the 15 minutes is over so that we are on time. And now I request Preeti, please, floor is yours.
Yes. Welcome, Preeti. Thanks for agreeing to join. You can please start your presentation. Go ahead.
Thank you, ma'am, for the kind introduction. And I thank the organizing committee or the organizers for giving this opportunity to share my findings. So having said that, I hope my screen is visible.
Preeti, you can make it slideshow. It's not slideshow.
It's now, ma'am?
Yeah, it's okay now. Yeah, good.
So going with the title, Breaking of Fear, Way Through Gut and Environment. So fear is a memory which is aversive and not everybody wants to have it. So we want to get away from fear. And how are we going to get away from fear is through the nutrition and through enriched environment. So behavior is an interaction between genes and environment. Learning and memory is the most important mechanism that altered by the environment and nutrition. So the first term given by Hebb is enriched environment. He read the laboratory rats at home along with his children, and he saw that the performance of these rats were much better when given a problem-solving task. And thus he quotes it like this. The other component which is important for cognition is the nutrition, which in this floor I do not have to touch upon. So the few points to know here is a little about teicosohexanoic acid, which has an important role in the formation of the cell membrane, which is important. And this is the one which has shown that it has improved the cognition. So here we can see the encephalization with the DHA, and also the regions who consume more amount of fish, we see that their depression is less. Now, today I'm going to focus on my PhD work and work from the ITC Life Science Bangalore, that is on nutrition. So here what we did is the rats were exposed to the enriched environment and to the nutrition. And we already know that it induces plasticity and changes in the neuronal activity. So how this nutrition and the enriched environment has improved, and is there any underlying cause, is what I'm going to address today. So we all know, I don't have to explain this slide. So here I'll be talking about the classical conditioning wherein fear memory is being formed. So in this slide, we are seeing that the rat is exposed to the conditioned stimulus, which is the tone, and there is a response, which is a neutral response. When this is paired with the shock, all of us know that is the associating form of memory. There is a form of aversive memory which has been formed. Then on presentation of the conditioned stimulus alone, there is freezing. So on repeated presentation of the conditioned stimulus alone, without the unconditioned stimulus, that is a shock, then we see the extinction of fear memory. The whole focus is on the extinction of fear memory. And why this fear conditioning model is important is because it is a model for post-traumatic stress disorder. So this is a circuitry for fear, wherein we have to remember that there is amygdala, hippocampus, and for extinction, it is the prefrontal cortex. Now the circuitry is being strengthened on the presentation of fear, which is seen with increased synchronization between the amygdala and the hippocampus during the fear presentation. Now, once the fear is being formed, we know it has to be extinct, and how it could be extinct is through the region in the prefrontal cortex, that is the intralimbic cortex. Now, what intralimbic cortex does is it inhibits the amygdala and thus inhibits the fear. So we can see that it reduces the fear. Further modulation of the fear could be done by the hippocampus. Now, coming to the data, what we have found with the nutrition is that inclusive of micro and the macronutrients, we observe there is decreased anxiety. That is in the light dark test, we can see that the rat spent lesser time in the dark area, which means it is interested to explore in the light area, indicating decrease in the anxiety. Further, the body weight also improved with the diet, and the corticosterone levels remain the same. Now, to understand the spatial memory, what is the role? So here in the 8-arm radial maze, we have seen that there is reduction in the both reference memory error and the working memory error with the more number of correct choice. So what we are seeing as gray is the number of correct choices made. Thus, nutrition plays an important role in enhancement of spatial memory with less number of errors. Coming to the extinction of fear, so here the rats were exposed to the conditioning, after which 24 hours when we looked for the retention, there was less freezing in the rats which were exposed to the diet. Thus, it shows that there is immediate fear extinction in the rats exposed to the better nutrition. Thus, to summarize the first part, that is, there is decreased anxiety, increased cognition, and increased spatial memory with the rats exposed to the diet. Now coming to the enriched environment. So enriched environment is the cage where the rats are allowed to explore, and it receives all the kinds of stimulations. So in the following the enriched environment, we had the two paradigms, that is the contextual conditioning and the auditory conditioning. So in the contextual conditioning, no stimulus has been given, it is only the context. So it is majorly hippocampal dependent fear memory. So here what we did is there were two contexts in which one context they underwent the shock and they looked for the similar context, which means does the similar context produce the same amount of fear and how it could be extinct. So after the two rounds of habituation, they underwent fear conditioning, after which they were exposed to the extinction. So what we observed is that in this, there is no difference in the acquisition of fear, but on extinction training, wherein they were exposed to the context for 10 minutes without any shock. And what we observed is that there was better extinction in the rats which were exposed to the enriched environment. Now, all of us know that enriched environment has a better extinction. But what is the time duration during which the enriched environment to be given? So focusing on that, these rats, what we see in green, had a double exposure, that is before the training and after the extinction training, there was 2 exposure of the enriched environment. Whereas in this case, there was only 1 exposure, that is after the extinction training. So we see that twice exposure or the re-exposure to the enriched environment helped in the better extinction of fear memory. Thus, the timing of EE plays a crucial role in enhancing the extinction memory. Now, what forms the basis for the activities? To know that we implanted the electrode in the 3 important regions, that is the hippocampus, amygdala, and the intralimbic cortex. So this is just to show the electrode placement. And these were the recordings. I will not go into this. I'll go directly into the findings. That is, we observed that we analyzed the EEG in the during the 10 seconds, during the 2 behaviors, that is during the exploratory and the freezing behavior. And we observed that there was a significant increase in the intralimbic cortex, which is a region for extinction during the freezing. Thus, increased theta activity in the intralimbic cortex equated to better extinction. Just to summarize the part 2, he did not interfere with the fear retention. There was faster extinction, and also the re-exposure had a better extinction as compared to the single exposure. The theta activity was increased in the intralimbic region, indicating the processing of the extinction memory. Thus, timing of the EE plays an important role in extinction of fear memory. Now, this was about the context. Now, what about in case of auditory? In this case, we didn't have the timing and different EE exposure. We only had a 1 exposure, that is the EE rats and the control rats. So what we observed is that there was no difference in the baseline freezing, neither for the conditioned stimulus and for the stimulus which is not paired with the shock. What we observed, similar to that of the findings in case of contextual conditioning, is that there was better extinction in the enriched rat as compared to that of the normal rats. Now, to understand, now already we know that intralimbic cortex has its role. So we wanted to explore the intralimbic cortex, for which we did the single unit activity. So this is the instrument which we have in NIMHANS, that is a plexon, where we record the single unit activity. And this shows the region of the electrode, which is the region in the prefrontal cortex. Now, what we are seeing here is the 2 clusters. Now, the cluster separation is nothing but it separates the 2 different neurons. More the separation, that is an indication that there are 2 different neurons. So, and also these neurons should remain consistent throughout the recording, because whatever neurons we see during the conditioning, same neurons which have to sustain or remain consistent till the extinction. So sometimes through the technical movement of the electrodes, we lose on the neurons. So this is how we separate the 2 neurons. So we have the 2 neurons here. And depending on the type of neurons, there is a difference in the firing too. So it could be burst firing, it could be regular firing. So that is done through the autocorrelogram. So we can see here, this is the slide which tells us about the stability of the neurons. So across the behavior, we should have the neurons being retained. And this is where we have the discharge of the neurons. We can see here that in the regular firing, there is an exponential increase from 0 level. Whereas in the burst firing, there is an exponential decrease from an increased level. And this is where it is unclassified. So these are the softwares will allow us to separate these neurons. So what we observe is the mean firing rate. The mean firing rate was more in case of the enriched environment rats as compared to the normal rats. Thus, I would conclude it saying that increase in the mean discharge rate in the intralimbic cortex led to the increased extinction. So thus there is a physiological relationship between the firing of the intralimbic neurons to the conditioned stimulus, which has a function of extinction memory. Thus to conclude, diet and environment regulates behavior and the physiological process. Timing of the exposure to the EE plays an important role in the extension of fear memory, and this timing may help in the treatment of PTSD in terms of exposure therapy. I would like to acknowledge my guide, Dr. Lakshmi T. Rao, for continuous support throughout my PhD and my institute, that is where I did my PhD, that is NIMHANS, and the ITC Life Science, Bangalore. Thank you, one and all.
Thank you very much, Dr. Preeti. We really enjoyed the session. And the nice thing is that, you know, nature has a way of bringing us together. Things which you do, we like to do, and interests become combinatorial and complementary. Now it is my very pleasant duty. I think we can have questions right at the end, because then we are using what we call an integrated systems approach. Thank you, Preeti, and thank you, Dr. Lakshmi Rao, also for introducing us to Preeti. And I'll also thank Professor K.K. Deepak and Dr. Anil Pandey, who stimulated us to join this symposium, me and Dr. Suman Jain, and to introduce formally my co-chair and now the second speaker. Dr. Suman Jain is a professor in the Department of Physiology. She's an alumna of AIIMS, having done BSc in Human Biology, then MSc, then PhD. And she has been actively involved in deciphering the translational potential of RTMS and use of nanoparticles in patients as well as animal models. And she and I have been founder members of the Indian Society of Nanomedicine. She has made animal models of spinal cord injury, Parkinson's disease, Alzheimer's disease, cerebral palsy, and other neurological disorders. And she is working on giving magnetic stimulation and nano approaches both in clinical trials in humans as well as in the animal models, which is the true benchmark of a translational scientist. And she's recipient of AIIMS Research Excellence Award. And the presentation today is about a very interesting concept that is using the egg model and development of the auditory cortex and what we call the phenomenon of imprinting. Over to Professor Jain. We welcome you.
Thank you, ma'am. Thanks for actually very lucid introduction. So although like ma'am said, I have a great interest in nanotechnology and using magnetic stimulation for a number of neurological disorders. But today I'll be talking about the work about the effect of music stimulation on perceptual learning. Before that, I would like to thank Professor Sheshibala Singh and the whole team for giving us this opportunity to hold the symposium and deliver a talk and share our research work. So I'll be talking about prenatal music stimulation effect on perceptual learning. So what is perceptual learning? Perception, as we say, is the interpretation of the sensory information. And when we say perceptual learning, basically it is an experience-dependent enhancement of our ability to understand or interpret whatever we see, hear, feel, or taste or smell. And it is a long-lasting improvement, because if it is a learning, then it does involve neural circuitry, and there are long-lasting changes in the neural circuitry, which is resulting in this facilitation of interpretation. It is generally implicit, such that learning occurs without awareness,
Like a young child, when a newborn starts eating food, then this eye-hand coordination, we are not training them, they are learned. Even the recognition of who is mother, who is father is not being trained. So this is what is perceptual learning, that they see, they hear, they taste, or they smell, and they learn. Okay. However, it is also seen in adults and can be studied in laboratory by using certain simple perceptual tasks. So there are certain evidences in literature which says that during development, actually there is establishment of perceptual learning. It's been seen in humans that in utero by third trimester, so 20-24 weeks, there is laid down of auditory pathway, and mostly there is a functional development of cochlea, so that if there is external sound is being provided, there is an arousal of fetal activity in response to species typical sounds. It has also been reported that if as young as 2-day-old infant, even 24 hours old infant, is able to recognize their mother's voice in response to other women, if the two women are standing together, one is mother, then they are able to recognize their mother's voice as well as recognize that who is mother. However, recognition for the father develops slightly later as they mature. So some of these reports does suggest that there is a development of perceptual learning during prenatal period, and that it can affect the postnatal behavior. So our query was that what is the scientific basis of such observations, and therefore we wanted to do provide a scientific evidence that actually what is happening in the brain and how the perceptual learning is changing if you are providing some stimulation during the perinatal period. So for that we chose chick as animal model. So we chose chick because it's precocious in development. So that means when they are born, they have all their senses are quite well developed. And second, more important reason from practical point of view, that you can get fertilized eggs from the poultry farms. You can have incubator, you incubate them, and while they're incubating, you can play different types of sounds or music. And thereafter, when they are born, then you can take out the samples and do the study. So that's why we chose chick as an animal model. Now, if you look at the embryonic gestation period, so-called, then it can be crudely divided into prenatal period and postnatal period. So in the prenatal period is the time when actually there is a laying down of gross structure of various brain areas, and they start developing functionally. They start developing, and as the structure is being laid down, and the various areas or various structures are maturing, like cochlea, they start producing spontaneous discharges. So it is during that time that now, once the spontaneous discharge from these structures are there, they also become responsive to the external environment, and that is what is perinatal period, when there is activity dependent processes, and therefore that result in refinement of the various structures and also the synaptic circuitry and also the number of neurons. Okay. In case of chicks, basically, therefore, the auditory development can be divided into two periods. Pre-hearing period, that is the period when, as I said, when there is a laying down of the auditory pathway, and therefore there is a synaptic connections being formed between hair cells and efferents, or efferents along with the medulla, and cochlea starts to develop, generate spontaneous discharges. And then there is onset of hearing, when actually the chicks can respond actively, and that is and there is emergence of frequency selectivity and so on and so forth. So based on that, therefore based on this knowledge, then we designed a study. So we got the fertilized eggs from the poultry farm, authorized poultry farm. So we had an incubator. So this incubator had we had maintained temperature, humidity, and there was a ventilation, and this was the tray where we kept the eggs. And this tray was then tilted 4 times a day per 24 hours, for as it has been generally under natural conditions that eggs are being tilted. And they were divided into 3 groups: control, a species specific call stimulated group. And then we also wanted to see that if there is any development of perceptual learning, is it only due to species specific sounds, or any sound can act as a sensory stimulus and can affect the perceptual learning. So therefore we gave music stimulation also. Okay, so this was sitar music which we had played. So there were 3 groups. In the control, there was no auditory stimulation. Okay. And then in species-specific group, since from day 10 to 16, according to the literature, they are more responsive to low frequencies, and therefore we gave maternal calls. And from 16 to 21, then they also become responsive to high frequencies, so we gave hatchling calls. Similarly, in music-stimulated group, we gave low frequency, slow sitar music, and then fast music, which is sitar music. And this was given for 15 minutes per hour for 24 hours at 65 decibels. So this was continuous stimulation. Then to test the perceptual learning, we did the simultaneous choice for auditory preference. So this was the setup which we had indigenously designed. So in this setup, this is a large box of 160 centimeter to 80 centimeter. This is the storage box where we used to keep the chick. There were 2 approach areas. Okay. So in from one and we had placed the tape recorders outside of this box. So from one approach area outside, we played chicken maternal call. So CM is chicken maternal call, which is species typical sounds. And from other side, then we played bob white maternal call, which is non-specific sounds. And then we recorded, we placed the chick, and then we recorded number of parameters, like how many chicks are actually responding. Responding means to whether they are moving or they have shown freezing behavior and they're just staying at the start box where they were left. And then how much is the latency in either of the areas? So which area they're going first, and whether then in that area they're staying or not. So for how much is the total time they're spending in each area. So that is the deciding factor, that how much time they're spending and how they're moving. So what we observed was that now, when we recorded this, then we found that 95% of the chicks were actually moving towards the chicken maternal call. So even you can see in this graph, this is the first graph, this is number of responders, how many responders. And on the x-axis is different post-hatch days, post-hatch day 1, 2, and 3. And this green color is the control unstimulated group. And blue and purple, pink are the stimulated groups. So we found that number of responders, when I say number of responders, that means the ones which have responded and moved to the chicken maternal area, approach area, that was significantly higher than the control unstimulated group at post-hatch day 1. So at 24 hours itself, there was a significant increase. Now, when you look at the latency, then you found that latency was significantly decreased. And total time spent was significantly increased in this species, in this stimulated groups. So irrespective that whether we are stimulating using species specific or music group, these stimulated auditory stimulation, prenatal auditory stimulation was able to affect the postnatal perceptual behaviors. Okay. Then we looked at the neural circuitry, I mean what is happening in the brain, and therefore we took out the auditory cortex and we did Western blotting. I'm just going for synaptophysin, but we also did for PSD95 and other markers. And we found that there was a significant increase in the stimulated groups. There was a significant increase in the expression of the synaptophysin. Right? So then the other question then came to our mind was that, okay, now we have given auditory stimulation and therefore auditory, can it affect the, any other sense like visual system? And if there is any critical period for cross-medal plasticity. So for this, then we just divided into control and species-specific stimulated groups. Similarly, they were stimulated. Now to understand the critical period, then what we did, the species-specific stimulated group was further divided into 3 periods, 3 subgroups. In subgroup A, the stimulation was given only from day 10 to 16. So this is the time when actually the auditory system is developing. Then in subgroup B, we gave a stimulation from 17 day till the hatching. So the visual system actually starts developing from 16 day onwards. So this is in this group, therefore the visual system will be developing and auditory most probably would have been developed, become functional. Then in the last group, we gave continuous stimulation from 10 days till 21 days. Again, we did the similar type of behavioral study, except that now for testing the visual system, visual preference, so we introduced these taxidermically prepared models. On one side, we placed quail and the other side was chicken. And then so that the chicks should be able to move, and these were placed inside the approach area. From the loudspeakers, from the tape recorders, we just played chicken maternal calls from both the sides. So from both the sides, the auditory stimulus was same, but the models were different. So one was species specific and another was non-species specific. And then the chick was placed and similar parameters were recorded. So auditory, like I had said, that in the auditory, if you see the first graph, then in control, as compared to control, in all the three groups, there was significant increase in the number of responders and significant decrease in the latency and total time, increase in the total time spent. So that was quite similar to what we had seen earlier. Okay. Now, when we looked at the visual perceptual learning, then we found that in all the three stimulated groups, the number of responders was significantly higher. Okay. However, when we analyzed the latency, we found that latency actually reduced only in two groups. So these were group B and group C. Now, if you remember, B is the one in which we had given stimulation from 16-day onwards. Okay. And C is the one in which we had given from 10 to 21. In the group A, wherein we had given stimulation when the auditory system was developing 10 to 16 and visual has not started, there was no effect. Okay. Similarly, the time spent was increased only in the two groups B and C. So this was very, very interesting observation that that stimulation when provided when the system is developing is beneficial. Okay. So again, then we did synaptophysin PSD95. So this is in auditory cortex. In all the three groups, there was a significant increase. We had also done during the embryonic days this type of expression starting from E19 till post at day 3, and there was a significant increase in auditory cortex in all the three stimulated groups. But when we looked at the visual cortex, okay, we found again the similar results that in B and C there was a significant increase in synaptophysin in both the hemisphere, left hemisphere as well as right hemispheres. Okay, and in control and A group there was an increase over the period of days, but less as compared to the other two groups. Okay. So this is PSD95 expression. So this was the same results that in B and C there was a significant increase in the PSD95 expression in both the hemispheres. Then when we compared the left and right hemisphere in the male chicks, so we had also done the gender study. Then we found that the expression of the synaptic proteins was much higher in right hemisphere as compared to the left hemisphere. So in all the age groups irrespective of whether you are giving stimulation or not, even in control group, in the right hemisphere, the synaptic protein expression was much more as compared to the left hemisphere. And when we compared males and females, then also in all the groups, even in control group, the expression was much more in females as compared to the males. So this was very, very interesting results which we have found. Now, having done these studies, one next study what we do, so we found that okay, the perceptual learning is facilitated. So if you're giving prenatal species specific or music stimulation, it is enhancing both the auditory perceptual learning as well as the visual perceptual learning. Now, so therefore, now we wanted to know, okay, so summary is okay. So can it also affect spatial learning and memory, which is more dependent on hippocampus? So therefore, we designed a T-maze apparatus. So this is a T-maze, okay? And then we left the chick in the isolation box. And this is the T-maze long arm of the corridor, and these are the short arms. So the chick, one of the chicks was left here. Then they have to navigate to the brooder area, okay? So this brooder area was there. So then we recorded that how much time they spent in the isolation box, how much time they spent for exploring, and then total time. So this was the study experimental design. So in this, we had stimulated from 10 days till hatching. So we had only one group, and we had done training, 3 trials we gave for each of, during day 1, we gave 3 trials on each of the days, and then their retention was tested after 24 hours. So what is the effect of training? So what we can see, this is control group, this is species specific, and this is music stimulated group. Okay. So what you can see that in all the groups, over the 3 trials which was given on day 1, there was a facilitation of learning. So the latency or the total time taken reduced as they navigated the maze over the trials. So in all the 3 groups, the learning was there. But when we compared among the ages, then we found that 24 hours, there was a significant improvement, or there was a significant improvement at 24 hours. Okay. So there was a facilitation of learning at post-has day age 24 hours as compared to the controls. Now, when we compared among the groups, then we found that species-specific group and music group both significantly, there was a significant decrease in the exploration time and total time as compared to the control group. So in both the stimulated groups, there was a significant facilitation of spatial learning as compared to the control unstimulated group. Now, when we tested the retention, then we found that in control and species specific groups, they were able to retain the information after 24 hours. But the music stimulated group, there was a deficit. In the total time, isolation box or exploration time, all the parameters, there was a deficit. So that could be, we hypothesized, although all the environmental conditions were exactly similar. So what we hypothesized that now in species specific, when the chicken maternal call is given for 15 minutes, then after every one small call for 2 seconds, there is a break. So that is how the mother is making a call. So there is a break in the call. It is not continuous for 15 minutes. Whereas when we are playing the sitar music, music continuously goes for 15 minutes. So that could be one of the reasons that somehow the learning was facilitated, but memory could not be maintained. So that was the only explanation we could think of. Though we then, to rule out this, we also did the plasma cortisone levels, and we found that at 24 hours in both the species specific and music stimulated groups, there was a significant decrease in plasma cortisol levels, suggesting that in both the species specific and music group, the stress was less as compared to control, and that could have facilitated the learning. Then we also looked at the synaptic proteins in hippocampus, and we found that in both the synaptic proteins, in both the stimulated groups, there was a significant increase in the expression. So in both the stimulated groups, the neural substrate had increased as compared to the control unstimulated group. Therefore, from these studies, we concluded that there is a facilitation of both spatial and perceptual learning following prenatal auditory stimulation with either species specific or music sounds. And then this could be that the stimulated chicks are able to cope up better with the stress, or because of the presence of enhanced neural substrate in the brain. However, the complex rhythmic music do impair memory transiently. In the end, I would like to acknowledge my mentor, Professor Shashi Vadva. She was professor in anatomy department, and she was the one who initiated these studies. And then I joined her lab as postdoctoral fellow, and then continued later on when I was a faculty also. And I really acknowledge her and grateful to her for giving me, to getting me into this very, very interesting project. Professor Rashmi Mathur was mentor in physiology department, under which I did a lot of studies on magnetic stimulation and others. Professor Nag from anatomy department helped in morphological studies. Dr. Falguni Anand is now in NIMHANS, but she did her PhD with Dr. Shashi Vadva. And during my postdoctoral fellowship, we together worked for it, and she did a lot of very good work on this egg model. Dr. Shaboni Roy and Dr. Hina Kausar are the students who actually, Shaboni is PhD student, Hina is MSc student who did this work. And then I would like to acknowledge Department of Science and Technology for funding the project. Also want to thank all of my students and mentors in brain stimulation and neurophysiology lab at AIIMS Delhi. Thanks to all of you for your patient hearing. Thank you.
Thank you very much, Professor Suman Jain. I'm sure we all enjoyed this nice work, and it's a unique work on egg model. And to tell you further that Dr. Suman is planning to do this with me in the area of olfactory imprinting through dietary spices, and she is also planning to work in another project which is a multi-centric collaboration and bordering on space physiology, where we shall give some kind of microgravity stimulation to the egg model and see how the gravity sensing imprinting is developed. So thank you very much, and welcome Dr. Vandana Jain. I will again introduce Dr. Vandana Jain is the author of more than 80 peer-reviewed publications. She started the division of endocrinology at AIIMS, and she's guided many DM students, and she very passionately worked towards establishing this division in the Department of Pediatrics. Without taking more time, I would welcome Dr. Vandana Jain to give her talk and enlighten us on what happens from the animal model now to the human babies and children and adolescents. Dr. Vandana, please. Yeah. Dr. Suman, can you help with the slides if Dr. Vandana has shared with you, or maybe she can share at her own end?
Dr. Vandana, you want me to share the slides?
No, ma'am, I'll share from here.
Okay,
Just
good,
a
thanks.
minute.
Okay.
Yeah. So, share. Just give me 1 minute. So is my screen visible?
Not now. Not till now.
Is it visible?
No.
No?
No.
Just a minute.
You have to just go to share screen and share your window.
Yeah.
Yeah, now it's visible. You can make it slideshow.
Can you see the slideshow?
It's not in slideshow. We can see
Just
the
a
slides.
minute. Okay, just a minute. Okay, now I think it should work. Is it in slideshow now?
Yes, right.
Okay.
Yes.
So very good evening, everybody. And thank you, Dr. Suman Jain, Dr. KP Kocha ma'am, for inviting me to this interesting seminar. So I'll be talking on neurological construct of obesity, impact of early life environment, and modulation through lifestyle approaches. So this is an overview of my talk today. Regulation of appetite and satiety. What are the neurocircuitry which are involved in this regulation? Then our own experience with weight reduction in children with obesity. I'll also talk briefly about some newer interesting approaches which are actually based on neuromodulation. So how we can actually use our knowledge of the gut-brain crosstalk and the various neurocircuit mechanisms to actually think about novel approaches where the patient is not at the center stage, but we do something externally which helps the patient in regulating their obesity and satiety mechanisms. And then lastly, I'll be talking about a very interesting area that is the early life factors and the developmental programming, because especially in our country, as we know, we have a very, very high prevalence of low birth weight. And then on the other hand, we have such a high incidence of cardiometabolic disorders. So these two are actually related, and our own work, and I'll share a little bit about our own work in this regard as well. So obesity, as we all understand, it is basically a chronic imbalance between energy intake and energy expenditure. The key word here is chronic. So occasional overeating does not harm anybody, but if you chronically overlook the satiety cues and eat more and expend the energy less, that is what causes abnormal or excessive accumulation of fat in terms of obesity. So why does it develop? Because if we look at the satiety mechanisms that our body has developed, these are pretty robust. When we are hungry, the stomach is producing more ghrelin, And adipose tissue is obviously, it has, there is less of adipose tissue if you're hungry, if you're starved. So this will promote more of appetite. On the other hand, after eating, leptin increases and the ghrelin reduces. So this should cause satiety. But in reality, this is not happening. Humans eat relentlessly. So we all overlook the satiety cues. And there are various reasons: marketing, ready availability of food. And a very important thing is the physiology that may have evolved to deal with conditions of relative scarcity, because that used to be the norm. We were hunter-gatherers. So whenever we used to get food, we used to eat it. But now with abundant food availability also, we still tend to eat more. And then cue-driven food seeking and consumption, or something which is known as Pavlovian conditioning, that because food is seen as a reward. Especially, in fact, now there are many studies which have come up that fat and sugar or sweet taste, they also provide a sort of release of hormones which are actually related to pleasure. So hedonic or pleasure-driven food seeking, that is another important thing. And when we look at children, they are actually the victims of obesogenic environment. So this is what is happening. So obviously sedentary behavior, calorie-dense foods, junk food, whereas it should have been this kind of environment which we should have provided to our kids. So this is something that now the understanding has emerged, that normally we know body weight has a set point, and if we try to lose weight, then even with temporary decrease in weight, there are mechanisms which come into play. For example, reduction in fat-free mass or reduction in your resting metabolic rate, that again tend to make us gain that weight. But with the weight gain, actually the hedonic pathway here comes into play. So sedentary behavior, all these environmental factors, endocrine disruptors, stress, and most important, availability of cheap, energy-dense, highly palatable foods. So that leads to increase in weight, which is sustained over time, and a new set point is established and defended. So in fact, there was a PhD study by Dr. Tanu Bhatla in the Department of Psychiatry, and I was a co-guide for the study. So she actually looked at children with obesity and without obesity. It was a case control study, and looked at their eating behavior and impulsivity and body shape concerns using some psychological questionnaires. So food preferences, it was not surprising to see that food preferences, although all children, we can see that even the non-obese, the pink ones, the non-obese ones, more than 50% of them do like all sort of junk food, but then it was clearly more, preference for junk food was clearly more in the obese children. Interestingly, these children with obesity or overweight were found to have high impulsivity, high score on inattention, and on ADHD index also. So that means that there is some impulsivity which is there, which is probably, again, making them impulsively eat more. And then she also looked at eating behavior questionnaire, and it was interesting to see that enjoyment of food, food responsiveness, emotional overeating, the children with obesity scored more, whereas satiety responsiveness, slow eating, emotional undereating, and food fussiness, these were behaviors which were seen in children without obesity. So yes, there is a difference in eating behavior also, which may be contributing to obesity. Although this was a case control study, we can't say whether this was just an association or causal association, but still this was an interesting association that was seen. So let's try to understand satiety further. So this is an interesting figure, which was actually given by Blundell et al. In 1987, but then it was subsequently modified with a lot of understanding coming in about the role of various mediators. So if you look at it, basically satiation has various components, starting with sensory and cognitive even before we start eating. So meal quality, what are our expectations of reward or pleasure from it? So obviously if we see a gulab jamun or an ice cream, we tend to eat it rather than if we see a whole plate full of just salad. So meal quantity is another important thing. So small calorie dense food will not cause stretch or osmotic load. On the other hand, if you eat fruits, vegetables, the stomach is full, that meal quantity itself will act as a satiety cue. And that will obviously be mediated by these gut and intestinal hormones. The nutrient status, that is post-absorptive status, nutrient status. So once you've eaten, then your insulin increases and your nutrients increase, which again act as satiety cue. and then in the long term, the body fat mass. So this is the satiety cascade. So understanding each and every step of it will probably lead to improvement in our management of obesity. Again, when we see this, we understand that why weight loss and maintenance is not easy, because it was seen that fat-free mass and metabolic rate are the major determinants of the drive to eat. So when a person starts losing weight by various means, especially by dieting, then what is usually seen is that the fat mass does not increase, does not reduce that much, but the lean mass reduces quickly. And if a person is eating less, they tend to become slow. So resting metabolic rate as well as energy expenditure, they all go down, and that actually makes them crave for food. Similarly, in response to calorie restriction, the hunger hormone like ghrelin, they increase while the satiety hormones decrease. So that is why weight loss is not easy. So we have to try and fool the system. So when we talk to children with obesity and when we try to achieve weight loss in them, one is that we don't tell them that you don't have to eat these kind of foods. We don't give them a huge list of foods that they don't have to eat, and we don't go in for too much of calorie restriction. Rather, what we do is we tell them what to eat. So we tell them you have to eat 3 plates of salad, you have to eat fruits. And it has actually been seen that in an interesting study which I came across in 2020 itself, the results were published that promoting fruit and vegetable intake actually leads to reduction in discretionary food intake. If you're full, your stomach is full, food craving reduces automatically. 5-meal pattern, that again tells you the next meal is coming soon. So don't be, too greedy in eating. So even if you're given a smaller portion size, you know that the next meal is coming. So you are more likely to be content with that meal. Then other techniques like increasing water intake, more of fiber to keep the stomach full. And we just tell them, try to stop packaged foods, try to stop all sort of sweetened beverages, because again, these are calorie dense foods, and liquids. Liquids don't stay in the stomach for long. So gastric emptying is fast. So again, when we see the satiety cascade, the stomach fullness or the gut fullness is important. So sweetened beverages are totally useless. So if a person is trying to lose weight, they have to cut down on this. And importantly, you have to maintain your fat-free mass, lean mass by doing adequate exercise so that your RMR and energy expenditure don't go down, your lean mass doesn't go down, because if they go down, they will cause, again, weight gain. So we did a study which is going to, which is under publication in IJMR, although Jan 2022, but it has got delayed. So we looked, it was an RCT in which we had a 3-arm RCT to total of 165 children aged 11.6 years with a mean BMI of 26.3 kg per meter square, which is actually significant obesity, BMI Z-score of more than +2. They were enrolled. And when we see that children with obesity, because of high BMI, they actually had stage 1 hypertension in about 1/4, impaired fasting glucose again in about 1/4 of the children. Fasting hyperinsulinemia was present in more than 1/3, elevated HOMA-IR, again signifying insulin resistance in nearly 50%, and dyslipidemia also in nearly 50%. Also, we looked at the psychological scores. So they had high perceived stress, and again, body shape concerns were seen in about 17% each. So what we did was they were enrolled in either of the 3 arms. Group 1 was standard weight management, like normal dietitian consult and focus on physical activity. Group 2 was a yoga protocol, which Dr. Rajkumar Yadav was a co-investigator, and he was really helpful with giving us all the guidance for yoga and with diet. So again, in both the groups, diet was there, but here there was yoga. And group 3 was control. So control means that we were not doing anything, no active intervention. This intervention was for 18 weeks and follow-up was for 8 months. And we saw that in both group 1 and 2, there was a significant decline in BMI. And the median reduction in both groups 1 and 2 was about 4 centimeters. In comparison, children in the control arm had a median weight gain of around 2.5 kg and increase in waist circumference by 2.6 centimeters. So this is the natural course that they would not normally increase. So if we look at this, then actually there was a significant benefit. In addition, we saw that in yoga arm, there was a significant decline in systolic BP as well as prevalence of hyperinsulinemia. This table shows the change in diet in the yoga arm. So we can see that there was a very significant reduction in energy intake, specifically in fat, in carbohydrates, in free sugar, and increase in fiber intake. So all those dietary changes were also there, and diet and physical activity, they go hand in hand. So in fact, when we look at yoga Specifically, there have been a few studies which have shown that yoga actually supports healthy eating through motivation to eat healthfully and by promoting greater mindfulness. So mindfulness is very, very important. So most importantly, children, they just munch when they are watching TV or when they are bored. So if you incorporate mindfulness techniques, so children should not be distracted while eating. Eating should not be always accompanied by something else. So there should not be any multitasking when you're eating, slow eating, chewing a lot of times, all these things we tell them, and taking a smaller plate, smaller portion size. So all these are very helpful. And yoga also probably had an impact in improving their diet. So we have another ongoing study which we are currently doing, and this is the data of 73 children. These are children with obesity and fatty liver disease. So all of these children have fatty liver. And this is again an RCT. In one arm, we are giving diet and physical activity, and in the other arm, we are also giving metformin. So it's a placebo-controlled blinded study. So even I don't know which children have been taken in which arm. So it's a combined data. So again, we are seeing that there is a significant reduction in BMI, waist circumference. On MRI, the hepatic fat fraction has gone down, HbA1c has gone down, and liver transaminases and fat mass percentage has gone down. So again, basically showing that, yes, if you do a very good dietary intervention and teach the child how to eat mindfully, then there can be a sustained weight loss. So in this study, actually, I looked at a subset of children with BMI more than 30 kg per meter square, which would normally indicate in children, because their BMI is lower, this would indicate more than +3 or more than +4 BMI Z-score. So in that subset, I saw that 18 children, like 56%, had a reduction in BMI of more than 5%. And the highest reduction was up to 20%. And 34% children achieved weight loss of more than 10 kg in 6 months. So obviously not everybody responds, but yes, those who comply, they do respond to integrated lifestyle management approaches. So, but again, here all the effort has to be from the patient, obviously supported by the family and by the team, but can there be simpler solutions? So, I did some literature search and try to see what is new. And I think the most important approach is targeting the gut-brain crosstalk. And obviously we know bariatric surgery also sort of works here at this level, because the most common surgery that is performed in children is sleeve gastrectomy. So where the stomach volume is reduced. So obviously with a smaller quantity of food also, the stomach will stretch, the mechanoreceptors will come into play, and the satiety cascade will actually start working. And also the gut peptides like the ghrelin goes down, hunger hormone, so that goes down. So that is how bariatric surgery works. Then another thing is GLP-1 analog and vagal stimulation. So a little bit more about this. So GLP-1 is glucagon-like peptide 1. It is a very, very important mediator of the gut-brain dialogue. So it is synthesized by the enteroendocrine cells in response to direct nutrient sensing. And this slows down gastric emptying. And now it is also recognized that this serves as a satiety signal to hypothalamic nuclei. And in a recent systematic review and meta-analysis published in 2022, so including 12 trials with more than 11,000 participants, it was seen that it did achieve a weight loss which was more significant as compared to controls. Another interesting approach is transcutaneous vagus nerve stimulation. So how does vagus nerve work? Vagus nerve activity is normally mediated by mechanoreceptors. Again, so main thing was mechanoreceptor, but again, newer studies in animals have shown that it may also mediate post-ingestive fat and sugar sensing pathways. So these are critical for the development of food preferences. And I'm sure Dr. KP Kocher's work is also, she has been doing a lot of work in this area, and probably she would have more knowledge than me, but it was seen that transcutaneous vagal nerve stimulation, which is done like this, so within something through the ear, because there is an auricular branch of vagus nerve which can be stimulated like this. So it was shown that when this was done, then people preferred low-fat foods over high-fat foods. Another study was done, which was again recently published. Again, it showed that visual processing of food was also modulated by transcutaneous vagal nerve stimulation. So this is an interesting and promising approach. But again, all these approaches are in their infancy, and a systematic review on neuromodulation therapies showed that various approaches were used: deep brain stimulation, transcranial magnetic stimulation, transcranial direct current stimulation, percutaneous neurostimulation, vagus nerve stimulation, and gastric electrical stimulation. So about 3,000 participants were included in this systematic review, and it was seen that mostly in open label studies, people have shown promising results, but in double-blinded RCTs, such kind of work was, such kind of promising results have not yet been replicated. So probably these are in their infancy. We need to do more work on these. And the last part of the talk is maternal and early life factors. So very quickly, because developmental programming is a very, very key area, and especially for our country because of the high prevalence of low birth weight. So as well as now, in fact, increasing prevalence of maternal obesity. So these are two articles that I'll just show. One is maternal obesity and insulin resistance, how it affects the hypothalamic feeding pathway. So this was an experiment in mice in which offspring of diet-induced obese mothers were compared to those of lean control mothers. And it was seen that maternal obesity altered the molecular signature in the developing hypothalamus. So this led to change in the development of hypothalamic precursor cells and defective feeding regulation, which persisted till adulthood. So this can actually explain the transgenerational effect of obesity, how obesity will beget obesity in the offspring as well. Another study is an ongoing PhD thesis. This is under publication, ongoing PhD thesis by my student. So where we are looking at children who are born, infants who are born small for gestational age, and what happens when they have a catch-up growth or an accelerated growth pattern in infancy. So catch-up growth means that your weight Z-score is increasing by more than 0.67 in a defined time period. So here we looked at infants from birth to 6 months, and we divided them into two categories: those with catch-up growth, that is an increase in weight for its Z-score, and those without catch-up growth. So what we found was that obviously the weight was higher in those with catch-up growth, but this higher weight was chiefly contributed by fat mass, not by fat-free mass. So fat-free mass was same in both the groups. This figure shows it better. So catch-up growth, non-catch-up growth, both had almost similar fat-free mass, but the main difference was in the fat mass. So the fat mass percentage came out to be 26% in those with catch-up and about 20% in those without catch-up. So early catch-up leads to higher gain in fat mass, not lean mass. So catch-up can lead to higher adiposity later in life also. And this was again the same thing in a linear manner. So increase in delta weight led to increase in fat mass percentage. So small for gestational age babies, catching up, this is something which is a common scenario in our country. And this catch up can lead to very early programming of increase in fat mass rather than fat-free mass. So coming to the end of my talk, so the key messages are that yes, chronic overeating with reduced energy expenditure leads to obesity. Satiety is mediated by complex neurocircuitry with a significant cortical overlay. So that is why it's not simply hypothalamic, it is the cortex which is playing a significant function. There is a developmental programming of satiety and appetite as well as adipose tissue storage. And this is actually known as a predictive adaptive mismatch. So if the fetus is receiving less nutrition in utero, so it predicts that it will continue to receive less nutrition outside. So it tends to store more fuel as fat. But this becomes a mismatch if the external environment after birth is not matching. Integrated lifestyle approaches with focus on mindfulness and a strong component of motivation and support are useful for weight loss, and newer approaches of neuromodulation may be the way forward. Thank you.
Thank you, Dr. Vandana. It was a very enlightening talk and with a lot of what we call application value. Can I call upon Dr. Anil to first present, and then maybe I can close and titrate the time accordingly, because I would not like us to be deprived of Dr. Anil's talk time. And he shall actually be talking about synaptopathies and how synaptic proteins can be used to develop theranostics, both diagnosis, prognosis, as well as novel therapeutic approaches. Dr. Anil, are you ready?
Yeah. Yes, thank you.
Dr. Vanda, will you please stop sharing your screen so that Dr. Anil can share?
Can you see my screen?
Yes, sir.
Yes,
Go ahead. Yes, sir.
Okay. Yeah. Okay. Good evening, everyone, and thank you, organizers of Fips International Conference, and also Professor Jay and Professor Kosha for inviting me to present my work. So today I will be talking about presynaptic orchestra in neuronal health and disease, and mostly focused on an important molecule, as you see here, called bassoon. Okay, so what is this active zone or a cytomatrix at the active zone? So we all know that for learning and memory, the synaptic connections or tight synaptic connections are very important, and it contains presynaptic and postsynaptic sites. So the active zone is a specialized structure at the presynaptic compartment, which is responsible for synaptic vesicle release, neurotransmitter release into the synaptic cleft. So this part of a cytomatrix at this active zone, in short called as CAS, contain different important proteins, scaffolding proteins, including RIM, MUNC13, rim binding protein, CAST-ELK, Piccolo, bassoon, and liprin, and so on, as you can see here. So these are very important for several presynaptic functions, including the synaptic vesicle cycle, which contains different steps, including the recruitment, the tethering of synaptic vesicle, docking and priming into the presynaptic membrane, localization of calcium channels, and exocytosis and endocytosis. Interestingly enough, so this the whole thing at the active zone is a substrate for presynaptic plasticity. And these molecules, be it protein regulation or genetic mutations, have been linked to several diseases, which I will be talking a little bit later. So, however, of all these molecules, as I already mentioned, that I will be talking about bassoon, which is a huge scaffolding protein present at this active zone site, which actually identified in our well, not in our lab, but in my supervisor's lab, Professor Eckhard Gundelfinger, during a screen for novel candidates in presynaptic and postsynaptic compartments. And you can see here this molecule bassoon interact with several other molecules and mediate important functions at the presynaptic compartment. So in a single sentence, a bassoon is a presynaptic organizer protein because it is involved in transport of active zone material to the nascent synapses at first, and then it is involved in a localization of PQ type of calcium channels, to be specific, through interaction with the rim binding protein. And it is involved in synaptonuclear communication through interaction with the CTDP1, which is a transcriptional repressor of activity-dependent genes like a BDNF and ARC. And the bassoon is also important for synaptic development in hippocampus synapses. And the recent studies from our lab and the collaborators' lab shown that bassoon is an important molecule in regulating presynaptic protein turnover, integrity, and degradative pathways like autophagy and proteasomal degradation. And such important molecule, well, has been linked to several diseases, neurological diseases, ranging from neurodevelopmental conditions like epilepsy, Landorf-Kleffner syndrome, a childhood epilepsy, intellectual disability, and sensory impairment like a deafness, and neuropsychiatric condition, schizophrenia, and finally neurodegenerative conditions, including progressive supranuclear palsy like syndrome and multiple sclerosis. In line, the bassoon mutant mice lacking this gene or total gene or a central important axons develop severe epileptic seizures. Yeah, and also these mice show sensory impairments like visual and auditory impairments. Another enigmatic phenotype with these mice is the brain never stops growing. So though the animals, the knockout animals look small compared to the wild type controls, but as soon as you open the skull, you clearly quickly identify that it's a Bassoon mutant because the brain is such huge. And it also have elevated levels of BDNF and neurogenesis, probably due to epileptic seizures. We don't know yet. And these animals have, non-functional excitatory synapses in the hippocampus. Together, these epileptic seizures and the sensory impairments made these animals not really suitable for behavioral assessment. So when we talk about environment and enrichment, we know that this enrichment helps a lot with cognition, learning, and memory, and so on. So our colleagues in Italy, they try to do whether it's beneficial for these Bassoon mutants when they have enrichment in their cages. So interestingly, this actually did beneficial to the animals during the tonic-clonic phase of this epileptic seizure duration, which significantly reduces when the animals, the Bassoon mutants, raised in standard environment compared to the enriched environment. And also the long-term potentiation has been restored after they were enriched, they were reared in the enriched environment. As I said, I was talking about the learning and memory, synaptic connections, and Bassoon. And also I said that these are not really suitable for behavioral analysis because of the sensory impairments and severe epileptic seizures. So we did some modification at the genetic level. So we started generating conditional knockout mice using 3 locks approach. So by inserting the lock species around exon 2 upon recombination, so deletion of exon 2 leads to premature stop codon and then silencing of the gene. So today I will be talking about 2 different conditional mutants, which I actually started working since 2012 during my PhD and subsequent postdoc. One lacking Bassoon in excitatory neurons, and the other one lacking Bassoon in forebrain inhibitory neurons to address specific behaviorally relevant effects of Bassoon function or Bassoon loss in mice. So here you see that this is a conditional knockout of Bassoon in forebrain excitatory pre-synapses, which you can see in the immunohistochemical analysis using markers for Bassoon and the weak glute. These mice actually develop interesting behavioral phenotype in dentate gyrus dependent tasks like spatial pattern separation, where the mice are allowed or challenged with discriminating quite similar patterns of memory representation they encountered before. Slight changes with this memory representation, and also in the contextual fear memory. So this actually resemble the phenotype of the mice having more young granule cells or immature granule cells in the dentate gyrus. So we thought of looking into this aspect. So in physiology, we look into the medial perforant path to dentate gyrus pathway. And if you see that in the wild type situation, the young animals always have this higher excitable state. And this goes down when they become adults. However, if you see the knockout, the Bassoon knockouts in excitatory synapses, that you don't see this phenotype, actually indicating that they have a maturation problem in the dentate gyrus. Then we look into chemical or markers or cellular markers of this granule cell maturation window, so calretinin and double cotting. And you can see that both the markers are more in the knockout animals compared to the wild type animals. Indeed, I mentioned that the Bassoon knockout animals have more BDNF levels, and then we were thinking that okay, probably let's check why we have more excitable state in the knockout animals. So we look into the TrkB signaling, which is a receptor for BDNF, And then interestingly, we found that the TrkB levels, both the truncated and full length, they are more in the knockout animals in the dentate gyrus. And then when we block this with the K252A, we rescue this phenotype. To summarize, bassoon expression in excitatory synapses is crucial for maturation of dentate gyrus or circuit in the hippocampus through involvement of TrkB signaling in an age-dependent manner. And then move on to the other mutant lacking bassoon in inhibitory interneurons. You can see here that with the marker VGAD, which is inhibitory presynaptic marker, the bassoon is gone in these cells, in these presynapses in the knockout animals. Move on to the behavioral part of these animals. Actually, it's quite interesting. So the animals looks quite fine in their home cages, but as soon as I put them into an open field or a novel environment, they started running a lot. Like, so they have hyperlocomotory behavior in the novel environment, and also they have very strong anxiety phenotype, not only in the open field, the time they spend in the center versus the time they spend in the corners or other rings. They also show the same phenotype, the strong anxiety phenotype in elevated plasmase, a dark light test, and also in different conditions and different labs, actually. Another prominent phenotype we observe with these animals is social behavior deficits. So here in this task, they actually fail to identify a novel stranger mouse compared to the familiar stranger mouse, unlike wild type, which prefer the novel stranger mouse compared to the familiar mouse. And further, we also look into interaction with the female mice in estrus phase, and also urine of the female mice in estrus. Actually, these knockout animals, they avoid completely interaction with the females or female mice urine. And also, they don't make any communication, which is measured using ultrasonic vocalizations. Yeah. And another social behavior is they don't have nest building ability in their home cages. And also they show repetitive kind of behavior like rearings in the novel environment. Altogether, these behavioral phenotype in these animals show that the mice lacking bassoon inhibitory synapses develop behavioral phenotype which is reminiscent to autism spectrum disorders. So we see that the anxiety is disturbed and then the social behavior is disturbed. Then we focus on physiological measurements at ventral hippocampus. The first one we measured is network activity, which is measured through gamma oscillations. And you can see that the frequency of gamma oscillations is reduced in the knockout animals. And also these mice actually develop recurrent epileptic discharges. So they also show some kind of epilepsy, not so strong like total knockout, but they still show some epilepsy. So we see that the gamma oscillations are disturbed, and then we look into the cellular aspect, the cells, the interneurons responsible for these gamma oscillations, and you see that the parvalbumin density in the ventral hippocampus is reduced in the knockout animals. So going in this direction, so we have network activity disturbance, and then we have cellular component adding to this, and then we look into miniature currents in these animals by blocking all the inputs to the pyramidal cells, and what we see here that they have reduced frequency again, which is measured inter-event intervals, indicating that these animals have like many models or known models of autism or schizophrenia, that excitation inhibition imbalance. Finally, to summarize, so with the excitatory specific knockout, we show that they have a maturation problems at the dentate gyrus, like immature dentate gyrus, which is a cellular phenotype or endophenotype often seen in neurodevelopmental or neuropsychiatric conditions. And then we have now behavioral and physiological phenotype, the mice lacking bassoon inhibitory system, which is again showing relevance to autism or schizophrenia. So the bassoon is, to give an outlook, the bassoon can be used as a tool in studying presynaptic mechanisms underlying these different neuropathological conditions. Actually, I was quite grateful to get my own funding last 2 years and working on this, and now I am already applied for some other fundings, which I will be looking into different aspects for studying effect of genetic mutation of bassoon in Landau-Kleffner syndrome, childhood epilepsy, in developing this ASD phenotype or hippocampal development and maturation in mice. And further, I already generated another knockout of bassoon in specific subtype of interneuron, the parvalbumin interneurons, to study the circuit dysfunctions in neuropathology. Finally, I would like to thank my supervisors, mentors since my PhD, Professor Eckhard Gundelfinger and Professor Oliver Stark, for their continued support and mentorship. And then to postdocs in the lab, two labs actually, Dr. Gusel Kaliskan for his electrophysiology experiments, and Dr. Karina Montenegro for in vitro data, which I did not show today. And also the PhD student, Andre, who did patch clamping. And then these two master students, Isel and Samana, who were working with me in the last 2 years in doing some experiments for the project. And finally, collaborations from different parts of Germany, India, and France, and funding of my own funding, and then funding from my supervisors. Finally, I thank you for your attention. Again, thank you for giving me this wonderful opportunity to present my work. I think I am on
Thank
time.
you very much, Dr. Anil. You have really raised the bar very high, and we have seen all the models, how they have developed, and going right till the synaptic level and its applied value. And now what I'm going to do is, Dr. Suman, if you allow, I'm just going to take you on a little bit of a roller coaster ride for the next 6 to 7 minutes, because we started the previous session ended late by 12-15 minutes, but because most of the 4 speakers have done very excellently, so I will just cut out the redundancy so that my talk will then tell us that what are the novel neuromodulation approaches emanating from what we have studied from the previous 4 speakers in this session. So if Dr. Suman, you can please kindly help me by displaying the slides, and we'll do it quite quickly because it's the last session of the day. Yes, yes, very nice. Thank you so much.
I'll just take 1 minute to introduce you now.
Okay, the slides will introduce. Okay, fine. Please go ahead.
Just
Yes.
1 minute.
Yeah, sure.
So it's my pleasure introducing Dr. Kamalpreet Kochhar. She is professor at Department of Physiology, New Delhi. She did her MD in physiology from AIIMS Delhi, and then went on to do PhD degree in physiology from AIIMS. She has expertise in cognitive neurophysiology, nutrition, and integral health clinic. And she is exploring different aspects of brain physiology, cognitive physiology, nutrition, and transitions. She has skill sets, and she has pioneered recording of Barrett shaft potential. So that is her very, very strong point. She's the one of the pioneers in recording of Barrett shaft potentials in India, and also FNRIS. She has expertise as FNRIS, eye tracking, and recording of cortical event related potentials, etc. And recently she has initiated the development or established medical immunity center at AIIMS. So she's heading that unit, and she's also chief nutrition advisor, FIT India movement. She's principal investigator for MAITI sponsored projects on pandemic related online training for all.
I think, Dr. Suman, that is more than enough. Yeah. Thank you so much. My modesty doesn't allow you to do more. I'll just get on to the talk. Thank you.
Okay.
Yeah. Thank you. So we can quickly run through the second, third, and fourth slides. Second one, because what we are talking is very relevant. The second slide. Yeah. So this is marrying the traditional with the modern. That is, the Vata will tell us about the signaling pathways and the metabolic pathways through the Pitta, and the Kapha is regarding depositions, whether adipose or cholesterol. So we are trying to do this and study the background of nutrition in the light of the traditional knowledge. And next, please. And thereby come the field genomics and pharmacogenomics, that is our phytomedicines, culture-based and tradition-based, and how we can run this knowledge and run it and provide what we call in silico modeling. So that is what I will run through you. And as Dr. Vandana said about the brain-gut axis, we have 2 PhD students and 1 MSc student working on probiotic interventions. Next, please. And Dr. Suman is co-guide to each one of them. So we can correlate the Ayurveda and the modern biology and the biomarkers and the electrophysiology and the molecular biology to make a systems approach, joining the genotype and the phenotypic expression as well as the epigenetic modifications. Next, please. Yeah. So like Vandana also very nicely showed that our early metabolic apparatus is geared with the thrifty gene type as well as to store, because we all had scarcity, and each day or each time of the meal we had to hunt and forage for food. But all that has changed because now we have food everywhere and not a minute to think of breaks or satiety or to refuse. That is what she said. We eat relentlessly. Okay. Next, please. Yeah, so this was a book. Next, please. Yeah, so this is from our paper which we published on, fat addiction, the new trajectory, and about food addiction. And my colleague from psychiatry department, Dr. Siddharth Sarkar, Dr. Naim Ali Khan, whom Dr. Vandana Jain said, who has discovered that 6th taste, that is the taste of fat, and how we are differently geared because our fat taste receptors are geared differently. So next, please. And this was published, and an undergraduate student, Tamogna Ghosh, also did an exploratory study of fat addiction and food addiction, and we have translated the Yale food addiction scale and validated it in vernacular Hindi language. And now what we are doing is, as Suman said, we are using visual tracking, developing images of high fat, low fat, high salt, low salt, high carbohydrate, low carbohydrate food, and high glycemic index, low glycemic foods. And we are working to see the attention aspect of cognition to this food. We are working to see the reward aspect, how quickly the FNRS, non-invasive neuroimaging, lights up when these pictures are presented. We are working with dental caries in small children and made pictures of sugary foods. And we have made all these kind of permutations, combinations by using 4 domains of cognition. That is attention to food, then choice making to food, then memory to food, and the last one is the motor cognition, or what ma'am had said, bear-shaped potentials, that what are our processes and responses or downstream pathways to sight or presentation of food. Next, please. Yeah. So this is the same thing. You can see it in our papers on Google. Next, please. So now why I'm saying this is because I did my PhD under Dr. Bijlani, and previously we worked on core cereals, and then we worked on the immunological benefits of probiotics, and my PhD proper was on dietary spices or bioactive molecules. So the new approaches are that we work on nootropics, which are cognitive enhancers. The new approaches are we work till the patch clamp technique. My student Shweta Sharma is doing it with Dr. Suman Jain and also Dr. Jyotirmay Banerjee in the colon. So we are trying to see the vagal pathways, the brain-gut axis too directionally. We are trying to do the immunohistochemistry, as well as we are trying to link it with another way, which was that eating in electromagnetic properties, vessels, koi tambe ka glass like that, and therefore we are giving a theta burst as a second stream and comparing these two traditional methods in the modern paradigm. Next, please. I'm sorry if I'm a bit fast, but this is again to show that these days we used to move a finger, but with touch screen we don't even move a joint. Next, please. And we don't drink water, we just have beverages, very high calorie. Yeah. So this was part of the Hriday project, which I am a founding member of, and Shan is Student Health Action Network, where we give nutrition guidelines. Next, please. Yeah, so FNRS we all know and we can read up, because my dear delegates, we will not give you spoon feeding today, but my job is to sensitize you and invoke you to read further about us. You can always email us, always come for short-term training, and always collaborate with us. Next, please. Yeah, so these kind of things we are doing. And we also know that FNRS can also be used as a therapy. We have done a very small trial that whenever, just dhoop mein, you go into sunlight and it makes you feel good. So we got an incidental effect that is socially, not very fluent children. They felt better when we gave them FNRS, and we are trying to work on that as well as in stroke patients. Next, please. So I'm trying to combine the autonomic profile with the FNRS images along with visual tracking, and also seeing their motor cognition responses to actually find out the whole pathway of response to food images as one part of our work. Next, please. So we give common pixelated images of food and non-food. Dr. Suman, thank you so much. Next one. Yeah. So this is one example with Dr. Rajkumar Yadav and his student. We had developed this for obesity, and then the intervention of yoga, and we saw that attention to food images reduced after mindfulness based meditative practices and yoga based lifestyle short-term intervention management. Next, please. And we are carrying this work further. Yes, next, please. Yeah, so this is the whole combination of things which we do for cognition management, and we do it for food. We also do it for neurodevelopmental disorders. We also do it for neurodegenerative disorders. So basically, as people say कि हम मशीनें use करके ये सारा निकालते हैं, and then we combine it with questionnaires of quality of life, of hunger scores, of stress-based questionnaires, and food frequency questionnaires, and also MOCA scales. And we are doing it in Parkinson's disease and seeing the various aspects. Next, please. Yeah, so we are using the gut microbiome both for human subjects as well as in animal models. And then this work is under going with 2 PhD students, and yes, and one MSc student then had a bright idea that when we are having phytomedicines and then we are doing clinical trials and nothing comes out of it, so why not do what we call the culture based or iogenomic based and phytogenomic based matching or in silico modeling. So we are doing that now. Next, please. Here also, Dr. Suman is the co-guide of that student. So we are seeing the protein databases, we are seeing the enzyme databases in the human body, like for Parkinson's disease. And then we are trying to find out what traditional plants were used and what our software iterative loops give us, and what pops up that this should be tried instead of wasting time, effort, and energy. So that is what we are doing now, and we are getting good results. Next. Yeah, so this is nutrigenomics and nutrigenetics, and we need to consider that, we need to go to personalized or individualized medicine. And as I showed the first slide, we need to marry the two. Next. So yeah, we can, I think, Suman, run through this. Everybody knows this, and this has been also alluded to by Preeti as well as Vandana, and also Dr. Anil. Next, please. So the gut is like, from metazoa, it has a lot of neurotransmitters. Food also contains a lot of neurotransmitters, like in Chinese cooking, we have glutamate and ibutinate, and we have a lot of good sensing mechanisms. And how our, So this is just one slide to tell us about cognitive enhancers and how we need to work through them and how we need to see the signaling pathways like G protein coupled receptors, which is coming. Yes, next please. Yeah. So this is a throughput or a work diagram. Okay, so that is what, so nutrition is not ki khana tola. It has lot of manifestations in multiple domains. Next please. Yeah. Next, yes. So metabolic syndrome, as we said, the nature versus nurture debate, the time of the day when we eat, the components we eat. So it is all very, very, very multifactorial, and therefore the interventions also need to be programmed according to that. Yes, next please. I think we are towards the end. Yeah, we can run through this. Yes, next. Yeah. So just a word about spices because I've done my PhD. Yes, next. Yeah. So these are the various ways the spices act, and please understand that a physiological dose and a supraphysiological and a pharmacological are different, and we need to keep in mind the synergy of the various molecules acting together in combination, and also the ways they are cooked and the culture in which their spices are used. Next. Yeah, so many of them have, so this is one slide which tells us about licorice, how it acts as a mulathi, as like Rhiza glabra, how it acts on anti-ulcer. So there's many more. I don't want to bore you or even information overload at the end of a very, very busy day. So I think I'm going to the end. Yeah, so Dr. Pobali, she had in the previous session talked about nanotechnology. Our review is under print in nanobiotechnology reviews. That is one of my students had come to me for short-term training. Her name is Drishti Garg, and she told me that how we can use nanotechnology and improve the spices shelf life and deliverability. Next please. So this is particularly with respect to spices. Yes. So she had already told this, and I'm just don't want to repeat the same thing from session 2. Yes, I come to this. I like this slide very much. That we started as early man by eating roots, and after so many generations and millennia, we are again being prescribed to eat fiber. And therefore, this is a circularity which is eternal. But yes, we have scientific based tools and techniques to evidence each of the mechanisms of action. Thank you very much. It was a pleasure talking to you. Dr. Suman, yeah, we can close the session now. And
thank you, ma'am. Thanks a lot. We can have a few questions, although there is no question in the chat box, but we can have few questions from the audience. They can unmute themselves and can ask questions from
questions
any of the
or comments. Yes. And
yes,
again,
yes.
I would like to thank my co-speakers and also Professor Sheshibala Singh. We had also had a symposium 2-3 years back in Japan, the Federation of Asia-Oceania Physiological Societies, where Professor Deepak, me, Dr. Naim Khan, Dr. Rajkumar Yadav, and Siddharth Sarkar, we had all gone there, and we had talked about nutrition and integrated approaches to management. Yes.
So any questions from any of the delegates? We can have 1 or 2 questions. I think I have one question to Dr. Anil if he's there. Dr. Anil? Yeah, yes.
Yeah, he's there, yes.
Yes. Anil, if I get it correctly, that bassoon which you said, is it during the development or maturation, does the concentration is changing over a period of time? You said it is age dependent. So I was just wondering that does it differ from young in an embryo to an adult?
So yes, it is actually highly expressed during development, like 3 to 4 weeks of age. Okay. Especially in the dentate gyrus. And then the later on, it's consistent. Actually, there are like, so we always get on Western blot analysis, we always get the 2 bands, a bigger one and the small one. So it was actually the first one, the bigger one around 420, the small one around 200 or something. So the 200 band, which we were getting like in the adult animals, is actually actually expressed more, before around 3-4 weeks. Later it is expressed less, and the above band around 420 is expressed more. I mean, we still did not explore this aspect, why it's happening, and if there is something relevant to this development of hippocampus or something. So this is one aspect we will certainly look into in the future.
Yeah, it's a very interesting study. So because you were saying that earlier age need may be required for synaptic function development or maturation, but later on, if the concentration is more, it may become excitotoxic and may lead to some pathologies. So
this is exactly happened in
and then you are saying there are 2 isoforms or 2 bands, then actually it's something to look for. I mean, that's really interesting that it has sort of 2 isoforms, and then one is expressing, and they're expressing at different timings. So that's really interesting.
Yeah,
really
I mean, this side toxicity, I agree, because this is what actually happening in multiple sclerosis patients. So there is boson expression, boson aggregates are forming in the soma actually, which is quite interesting. So yeah, I mean, there are many interesting aspects, and also with like a very pronounced social behavior, what we see also seen in other genetic models like SHANK3 or Fragile X of autism. So this is interesting. Also consider this as a model and look into synaptic mechanisms, which is what I am aiming for. Yeah.
Okay. Best of luck. That's really interesting work.
Thank you.
And
Thank you, Dr.
I think
Suman.
one question to Preeti. Last one question, I think. Preeti, are you there?
Yes, ma'am. Yes, ma'am. I'm there.
Yeah. So, Preeti, that's again a very interesting work. I know Lakshmi is doing a lot of work on, and you did that thesis. I've heard you a number of times. But what I was actually today learned that even giving a supplement, food, better food or good food, can improve, lead to a lot of improvements. I mean, reduce the anxiety and has a lot of effect. Did you combine the enriched environment with good food?
No. That is actually Dr. Bindu's plan to include both of this. She has actually worked on that, and they too have seen that improvement.
Okay, so if you're providing enriched environment along with good food, is it an additive effect?
It should be improved better. So that was a combination study which they did. Am I audible?
Okay. Yeah. Now you are audible. Yes. Very, very interesting. Thank you, Preeti. Thanks to all the
Thank you very much. It was really a pleasure listening to everybody and participating. Thank you, Shashi ma'am.
Thank you. Hello.
Good evening, Dr.
Thank you.
Shashi. Nice to see
Thank
you.
Nice
And thank
seeing
you.
Yeah, Dr. Kocher and Dr. Suman. Really great to see both of you.
Same here, ma'am. Thanks, ma'am, for giving this opportunity to organize this
Madam Shashi
symposium.
has done a lot of
Really
work for
good.
Indian Army and DRDO and making adaptogens and kind of good food, and some of it is very classified, and she's been, I think, rewarded also for this work. So we are very happy to be here today. Thank you very much. I think we can have your permission to close the session today.
Sure. Thank you, Dr. Kocher. Thank you, Suman. Thank you. It was nice talking to you. And thank you, everyone who have joined us online. Thank you.
Thank you. Bye. Have a nice weekend.
You too have a nice weekend. Yeah. Thank you.
Dr. Suman
Please
Jain.
join us tomorrow.
Thank you so much, Dr. KP Kocher, Dr. Suman Jain, and all the speakers of Symposium 3. With this, we will finally end our today's program. We would like to thank all the chairpersons and speakers for their active participation and would hope that you join us tomorrow again. We will start a program at 11 a.m. tomorrow on the same platform. Thank you.
Thank you. Thank you, Valencia. Good. Thank you.